Phology. 1 origin and evolution of Earth. 1 age of the Earth. 1 motions of the Earth. 1 Earth's magnetosphere. 2 internal structure of the Earth. 2 distribution of oceans and continents. 3 mechanism of plates movement. For volcanoes. 6 landforms and their evolution. 7.2. Climatology. 11 difference between climate and weather. 11 Earth's atmosphere. 11 climate change and atmosphere. 12 heat budget. 12 cryosphere and climate change. 13 Fujiwara effect. 14.3. Oceanography. 15 ocean reliefs. 15 salinity. 15 movement of ocean waters. 16 climate change and ocean circulation. 17 coral reefs. 17 ocean pollution. 18 marine resources. 18 Atlantic meridional overturning circulation (AMOC). 19 deep ocean exploration initiatives. 19.4. Indian climate. 21 characteristic features of Indian climate. 21 factors determining the climate of India. 21 Indian monsoon. 22 origin of Indian monsoon. 22 nature and important aspects of monsoon. 23 Indian Ocean Dipole (IOD) and Indian monsoon. 24 El Nino and Indian monsoon. 24 La Nina and Indian monsoon. 24 Why cyclones are rare during peak monsoon months, July and August. 25 Impact of cyclones anticyclones on monsoon. 25 Distribution of rainfall. 25 Changing rainfall pattern in the country. 26 Monsoon and economic life of India. 27 Conclusion. 27. 5. Population and migration in India. 28 Significance of population studies. 28 Trends in population growth. 28 Factors responsible for high population growth in India. 28 Implications of high population growth. 29 Distribution of population and its density. 29 Population census in India. 30 Working population. 30 Demographic dividend, window of opportunities. 30 Human development. 31 China and India, contrasting population trends. 33 Migration. 33 Internal migration. 33 External migration. 35.6. Human settlements and associated issues. 38 Classification of settlements. 38 Urbanization in India. 38 The faulty pattern of urbanization. 39 Human settlements and water pollution. 40 Human settlements and air pollution. 41 Climate change impact on coastal Indian cities. 42 Climate smart cities assessment and its impact. 42 Way ahead for sustainable and inclusive human settlement. 43.7. Land use pattern and its changing trend. 44 Land use planning. 44 Importance of land use planning. 44 Impact of land use change. 44 Changing trends in land use pattern in India. 45 Land use classification. 45 Link between land use change and climate change. 46 Desertification. 47.8. Location of primary, secondary, and tertiary sector industries. 49 Primary activities. 49 Agriculture sector in India. 50 Types of agriculture. 50 Cooperative farming in India. 51 Rising share of agricultural employment. 52 Major constraints in Indian agriculture. 52 Dairy sector in India. 53 Agro-based and agro-processing industries. 54 Mining sector in India. 55 Secondary sector. 57 Importance of the industrial sector in the Indian context. 57 Types of industries. 58 Factors influencing the location of industries. 59 Industrial corridors, IC, in India. 59 Strategy of regional resource-based manufacturing and management. 60 Textile industries. 61 Cotton textile industry. 61 Jute industry. 63 Sugar industry. 64 Tertiary sector. 67 Quaternary sector knowledge-based industries. 68 Canary sector. 69.9. Minerals and energy resources. 71 Types of mineral resources. 71 Distribution of key mineral resources in India. 71 Production of minerals. 73 Energy resources. 74 Sources of energy. 75 Major sources of power generation in India. 75 Problems with India as power sector. 75 Initiatives taken to resolve challenges. 76 Way forward. 76 Non-conventional sources of energy. 76 Solar power. 76 Tidal energy. 77 Hydrogen-based energy. 78 Hybrid renewable energy. 78 Gas-based economy. 79 Fly ash. 80 Lithium reserves. 80 Offshore wind energy. 81.10 Water resources and their management in India. 83 Water scarcity. 83 Water resource management, WRM. 83 Water use efficiency. 84 Micro-watershed development and management. 86 Government steps for water resource management. 86 Way ahead for water resource management. 87 Draft water policy. 87 Dam Safety Act, 2021. 88.11 Transport and communication in India. 90. Utility of transportation in improving industrial growth. 90. Railway transport system. 90. Road transport. 92. Civil aviation. 94. Shipping and inland waterways. 95. Interlinking of rivers. 98. Development of pipeline transport. 98. 12. Geographical perspective to disasters in India. 100. Hazard vis-a-vis disaster. 100. Classification of disaster. 100. Earthquake. 100. Cyclones. 103. Drought. 104. Landslides. 105. Heat wave. 107. Forest fire. 109. Floods. 110. Urban flood. 111. Glacial lakes outburst floods. 112. 1. Geomorphology. Origin and evolution of Earth. Our planet Earth is part of a vast and dynamic solar system. Understanding Earth's origins is intricately linked to understanding the birth of the solar system itself. There are the following theories given for the origin and evolution of Earth. Big Bang Theory, proposed by Edwin Hubble. This theory suggests the universe originated roughly 13.6 billion years ago from a singular point, expanding rapidly after a colossal explosion. Nebular hypothesis, developed by Kant and Laplace. This theory proposes the initial existence of a large, hot, gaseous nebula. Over time, radiation caused it to lose heat, leading to contraction and cooling. This spinning mass developed a bulge due to its rotation, and eventually, material separated into rings that condensed to form planets, while the central mass became the Sun. However, this theory struggles to explain the vast difference in angular momentum between the Sun and the planets. Planetesimal hypothesis. Chamberlain and Moulton proposed that a passing star interacted with the Sun, pulling out a cigar-shaped extension of material. This material supposedly condensed to form planets, explaining meteorites. However, the intense heat from the early Earth would have likely caused gases to escape rather than condense. Tidal hypothesis. Jeans and Jeffrey proposed a binary star scenario where the Sun interacted with another star, causing tidal forces to pull out material that formed the planets. A limitation of this theory is that it doesn't account for the disruptive forces within the Sun. Protoplanet hypothesis. This theory suggests that rapidly rotating nebular material formed large swirling regions called vortexes. These vortexes attracted surrounding material through gravity, eventually becoming protoplanets. Smaller vortexes within these larger ones might have formed planetary satellites. While each theory offers valuable insights, they all have limitations. New discoveries constantly refine our understanding, making Earth's origin an ongoing scientific mystery. Age of the Earth. Scientists estimate Earth to be roughly 4.54 billion years old, with a margin of error of about 50 million years. To estimate the age, they employed a technique called radiometric dating. This method analyzes the breakdown of radioactive elements within rocks. Radiometric dating comes in two approaches. One approach measures the presence of short-lived radioactive elements like carbon-14. In other, scientists can track the decay of long-lived radioactive elements alongside their stable decay products, such as potassium-14 decaying into argon-40. By analyzing these ratios, scientists can calculate the age of the rock and, consequently, gain valuable insights into the age of our planet. Motions of the Earth. The Earth's two main motions are rotation and revolution. Rotation refers to the Earth spinning on its axis, creating a day and night cycle. Revolution is the Earth's movement around the Sun in a fixed path or orbit. Effects of Earth's rotation, day and night. The Earth's rotation creates the 24-hour cycle of daylight and darkness. Earth's shape. Rotation causes the Earth to bulge slightly at the equator and flatten at the poles. Daily phenomena. We experience sunrise, sunset, and noon due to Earth's rotation. Wind and current deflection. The Coriolis effect, caused by Earth's rotation, deflects winds and ocean currents. Apparent movement. The rotation creates the illusion that the Sun, stars, and the Moon are moving across the sky. Effects of Earth's revolution. Our planet travels around the Sun in an elliptical orbit, causing its speed to vary throughout the year. It's slowest when farthest from the Sun, aphelion, and fastest when closest, perihelion. Consequences of revolution. Seasonal changes. The tilt of Earth's axis as it revolves around the Sun results in the variation of seasons. Different parts of the Earth receive varying amounts of sunlight throughout the year, leading to seasonal changes. Daylight length. The length of daylight hours also changes due to the Earth's revolution. Days are longer in summer and shorter in winter in the respective hemispheres. Shifting wind belts. The revolution influences global wind patterns. As the Earth revolves, wind belts shift, impacting weather patterns worldwide. The three North Poles. There are three North Poles of the Earth: the geographic, the magnetic, and the geomagnetic. Geographic North Pole. This is the physical top of the Earth, the point where the axis of rotation intersects the Earth's surface. Magnetic North Pole. This is the point in the northern hemisphere where the Earth's magnetic field dips straight down. It's not fixed and constantly drifts due to changes in the magnetic field. Geomagnetic North Pole. This is the northernmost point of the magnetosphere, the Earth's magnetic shield that protects us from charged particles from the Sun. Keywords: hot gaseous nebula, centrifugal force, gravitational pull, tidal distortions, biparental origin of Sun, protoplanets, jigsaw fit of the continents, glacial deposits, placer deposits, fossil distribution, polar fleeing force, tidal force, etc. Earth SMAGNETOSBHERE. Earth's interior acts like a giant magnet, generating a protective bubble called the magnetosphere. This dynamic region, shaped by the Earth's rotation and the constant flow of charged particles from the Sun, solar wind, shields our planet from harmful radiation and atmospheric erosion. The churning of molten iron deep within Earth's outer core creates this magnetic field, extending far out into space to safeguard our planet. Internal structure of the Earth. Most of our knowledge about the interior of the Earth is largely based on estimates and inferences. Yet, a part of the information is obtained through direct observations and analysis of materials, broadly divided into three major parts: direct sources, indirect sources, deep ocean drilling project, volcanic eruption. Analysis of matter's properties indirectly provides information about the interior. Meteors that at times reach the Earth, gravitation, magnetic field, seismic activity. It is one of the most important sources of information about the interior of the Earth. Hence, we shall discuss it in some detail. On the basis of seismic investigations, the Earth's interior has been 1. The crust 2. The mantle 3. The core. Crust. The outermost shell, thinnest over oceans, 5 to 10 kilometers, and thicker under continents, 35 kilometers, reaching 70 kilometers in mountain belts. The Mohorovičić discontinuity separates the crust from the mantle. Continental crust has 2 layers: Océal, upper rich in silica and aluminum, 11 kilometers thick. Ocima, lower rich in silica and magnesium, 22 kilometers thick. The Conrad discontinuity separates Sial and Sima. Tianma, lithosphere Mani. Sima mu km. Our compound NHD crust 0-S. Asthenosphere. J&C Manlo. Conrad Usconium TTNH Meho Pisnanye. D nert TJ. Kofor COR. Core. HIR, 6,400 kilometers. Dash, Lehman and Innes Peace core mantle. The source of Earth's internal energy, driving phenomena like plate tectonics and earthquakes. It extends from the Mohorovičić discontinuity to 2,900 kilometers depth. The Gutenberg-Weichert discontinuity separates the mantle from the core. Increased seismic wave velocities indicate denser material in the mantle compared to the crust. The mantle has 2 layers. O upper mantle, 0 to 1,000 kilometers. The Gutenberg layer within it has a zone of decreased seismic velocity. O lower mantle, 1,000 kilometers to 2,900 kilometers. The lithosphere, comprising the crust and the upper mantle's uppermost part, rests on the asthenosphere, a plastic-like zone in the lower mantle. Core, Earth's innermost layer, separated from the mantle by the Gutenberg-Weichert discontinuity and extending to the center. The core consists of a liquid outer core and a solid inner core due to immense pressure. The absence of S-waves suggests the outer core's liquid state. The core's temperature is estimated to be around 6,000 degrees Celsius, with immense pressure exceeding 3 million atmospheres. The core is believed to be composed primarily of nickel and iron. Distribution of oceans and continents. The distribution of oceans and continents as it is today has not been the same throughout geological history. Various theories have been put forward to explain the relative motion of the oceans and the continents. Continental drift theory. Alfred Wegener was the first person who put forward a comprehensive theory of continental drift in 1912. Theory. He considered that all the continents were once joined together in the form of Pangaea, surrounded by sea on all sides known as Panthalassa. Pangaea first broke into Laurasia and Gondwana, forming northern and southern components respectively. In the subsequent phases, Laurasia and Gondwana land continued to break to occupy today's position. Evidence for continental drift. Jigsaw fit all the continents. The shorelines of continents, particularly South America and Africa, fit together like puzzle pieces, suggesting they were once joined. Rocks lying across the continents having the same age. Rocks of similar age and composition are found on opposite sides of oceans, like the 2-billion-year-old rocks along the coasts of Brazil and Western Africa. Glacial deposits. Sediments of the Gondwana system of India are the same across 6 different land masses. The base is composed of tillite, a form of glacial deposit, which indicates prolonged glaciation. Placer deposits. Rich gold deposits in Ghana, lacking a local source rock, are believed to have originated from gold-bearing veins in Brazil, further suggesting a past connection. Fossil distribution. fossils of Mesosaurus, a reptile found in shallow waters, are present in both South America and Africa, implying these continents were once close together. Force responsible for causing the drift. O. Wegner suggested two forces responsible for drifting the continents. Polar fleeing force. It is associated with the rotation of the Earth. Tidal force. It is due to the attraction between the Sun and the Moon. O. Wegner believed that the application of these forces over a long duration resulted in the drifting of continents. Although the theory of Wegner has been accepted, the forces responsible for causing the drift have been rejected. Convectional currents theory, 1930s, Arthur Holmes theory. Continental movement is caused by slow-moving currents of hot rock within the Earth's mantle. Driving force. Heat from radioactive elements in the mantle creates temperature differences, leading to the circulation of hot, buoyant rock. Criticism. Some scientists question whether radioactive decay generates enough heat to sustain the vigorous convection currents needed for continental movement. Seafloor spreading theory, 1961. Harry Hess theory. The ocean floor is constantly spreading at mid-ocean ridges due to volcanic eruptions. New seafloor pushes older sections outward, causing continents to drift apart. Evidence. Oceanic crust is younger near ridges and progressively older farther away. The spreading of one ocean basin doesn't shrink another, suggesting additional processes are at play. Seafloor consumption. Hess theorized that seafloor pushed by spreading ridges is consumed by subduction zones at oceanic trenches. Plate tectonics theory, 1967. McKinsey, Parker, and Morgan theory. Earth's rigid outer shell, the lithosphere, is broken into large, moving plates, tectonic plates. These plates consist of both continental and oceanic crust. Plate movement. Plates move horizontally across the Earth's surface at a few centimeters per year. Plate composition. Plates can be predominantly oceanic, e.g., Pacific Plate, or continental, e.g., Eurasian Plate, or a combination of both. Mechanism of plates movement. The Earth's lithosphere is divided into many major and some minor plates. Young fold mountain ridges, trenches, and/or faults surround these major plates. The major plates are as follows. 1. Antarctica and the surrounding oceanic plate. 2. North American, with the western Atlantic floor separated from the South American plate along the Caribbean islands, plate 3. South American, with the western Atlantic floor separated from the North American plate along the Caribbean islands, plate 4. Pacific plate 5. India, Australia, New Zealand, plate 6. Africa with the eastern Atlantic floor, plate 7. Eurasia and the adjacent oceanic plate. Names of some important minor plates are given below. 1. Cocos plate, between Central America and the Pacific plate. 2. Nazca plate, between South America and Pacific plate. 3. Arabian plate, mostly the Saudi Arabian landmass. 4. Philippine plate, between the Asiatic and Pacific plates. 5. Caroline plate, between the Philippine and Indian plates, north of New Guinea. 6. Fuji plate, northeast of Australia. Plate boundaries. There are 3 types of plate boundaries. Divergent boundaries. Plates move away at mid-ocean ridges where new seafloor forms. This creates rift valleys and volcanic rock like basalt, fast cooling, and gabbro, slow cooling. Convergent boundaries. When 2 plates come together, it is known as a convergent boundary. Oceanic continental convergence. Denser oceanic plates subduct beneath lighter continental plates, forming deep oceanic trenches. Subduction zones, like those under the Cascade Mountains, fuel volcanic activity. Oceanic convergence. Similar to above, the denser plate plunges into the mantle, creating trenches and volcanic island arcs, e.g., Japan. Continental convergence. 2 buoyant to subduct, colliding continents crumple to form massive mountain ranges, like the Himalayas. Transform boundaries. Here, plates slide past each other horizontally, generating immense friction and creating transform faults like the San Andreas Fault. Seismicity and earthquakes. Earthquakes and their source. Earthquakes are sudden bursts of energy released within the Earth's lithosphere, causing the ground to shake. This energy originates at the hypocenter, located deep underground, and travels outward in the form of seismic waves. When a large earthquake strikes underwater, it can displace the seabed enough to trigger a tsunami. Causes of earthquakes. The primary cause of earthquakes is the movement and interaction of Earth's tectonic plates. However, other factors can also play a role, including volcanic eruptions, meteor impacts, and underground nuclear explosions. Types of seismic waves. Primary, P, waves. Similar to sound waves, P waves travel through solids, liquids, and gases. They are the fastest and have the highest frequency among earthquake waves. Secondary, S, waves. These waves cause particles to move perpendicular to their path. Unlike P waves, S waves can only travel through solids and have similar characteristics to P waves in terms of frequency. Surface, L, waves, confined to the Earth's surface. L waves are the slowest but most destructive type of seismic wave. They have a rolling motion and cause significant ground shaking. Shadow zones. Certain areas on Earth, called shadow zones, don't experience both P and S waves due to the Earth's internal structure. P waves can travel through the liquid core, while S waves cannot. This difference creates zones where only P waves are detected beyond a specific distance from the epicenter. By analyzing the behavior of seismic waves, scientists can infer details about the Earth's interior. The increasing velocity of P and S waves with depth suggests Earth's composition changes as we move towards the center. This likely indicates a layered structure with denser materials closer to the core. Recording earthquakes, seismographs. These instruments record the shaking of the ground during an earthquake, creating a seismogram for analysis. Richter scale measures the earthquake's magnitude, energy released, on a scale of 0 to 10, with higher numbers indicating greater force. Mercalli scale measures the intensity, perceived shaking, and damage, on a scale of 1 to 12, with higher numbers indicating more severe impacts. Wave shadow ZKP wave shadow zone types of earthquakes, tectonic earthquakes, the most common type, caused by the movement of tectonic plates. Volcanic earthquakes occur near active volcanoes due to magma movement. Collapse earthquakes result from the caving in of underground mines or caverns. Explosion earthquakes, triggered by the detonation of powerful explosives or nuclear devices. Induced earthquakes can be caused by human activities like filling large reservoirs. Devastating consequences of earthquakes, ground shaking and rupture, the violent shaking of the Earth's surface, sometimes accompanied by cracks or fissures. Landslides and avalanches. Earthquakes can trigger landslides on slopes and avalanches in mountainous regions. Fires. Damaged electrical lines or ruptured gas pipelines can ignite fires. Soil liquefaction. The shaking can turn solid soil into a liquid state, leading to structural instability. Tsunamis and floods. Underwater earthquakes can generate destructive tsunamis, while damaged dams or waterways can cause flooding. Loss of life. Tragically, earthquakes can lead to casualties among humans and animals. Global distribution of earthquakes. The Circum-Pacific Seismic Belt, which is found along the rim of the Pacific Ocean, is the world's greatest earthquake belt. In this area, around 81% of Earth's largest earthquakes occur, due to which it is known as Ring of Fire. The Alpide earthquake belt spreads from Java to Sumatra, goes through the Himalayas, the Mediterranean, and then completes into the Atlantic. This belt causes about 17% of the world's largest earthquakes. The third prominent belt is Mid-Atlantic Ridge, which is submerged. The ridge shows where two tectonic plates are spreading apart, a divergent plate boundary. Seismic mapping of India. According to the history of earthquakes in the country, a total of 59% of the land of India, comprising all states of India, is prone to earthquakes of different intensities. Seismic zone map OL India, -2002a. About 59% of the land area of India is liable IO seismic hazard damage. Zone intensity very high risk zone area Liawa IO shaking intensity 9 and above, zone 4. Zone 3. Zone 2. High risk zone intensity VIN. Moderate risk zone intensity VIL. Low risk zone 6 and lower. Seismic zonation and intensity map of India. Seismic zoning map of the country has classified the total area of the country into 4 seismic zones. Zone V is seismically the most active region, while Zone 2 is the least. Approximately 11% of the area of the country falls in Zone V, 18% in Zone 4, 30% in Zone 3, and the remaining in Zone 2. Volcanoes. The term volcano refers to an opening in the Earth's surface from which lava, gases, ash, and rock fragments erupt. The structure of a volcano grows with every eruption. Deep underground, molten rock, magma, gathers in chambers before traveling upwards through conduits and erupting from vents. Key parts: OFA volcano, magma chamber, a fiery underground reservoir where molten rock and gases accumulate. Conduit, a pipe-like passage that channels magma and volcanic materials from the chamber to the surface. Vent, the opening at the top of a volcano through which volcanic materials erupt. Crater, a bowl-shaped depression surrounding the central vent, formed by explosive eruptions. Slopes, the sides of a volcano that gradually descend from the central vent. Volcano. Types of volcanoes. Composite volcanoes. Composite volcanoes are made of felsic to intermediate rock. The viscosity of the lava means that eruptions at these volcanoes are most of the time explosive. Shield volcanoes. The lava that creates shield volcanoes is fluid and flows easily. The low viscosity also means that shield eruptions are often non-explosive. Caldera. They are mostly so explosive that when they erupt, they tend to collapse on themselves rather than building any tall structure. The collapsed depressions are called calderas. Cinder cones. A cinder cone has a cone shape, but is much smaller than a composite volcano. Mid-ocean ridge volcanoes. These volcanoes occur in oceanic areas. The central portion of this ridge experiences frequent eruptions. Landforms and their evolution. A landform is a feature on the Earth's surface which is formed naturally, and it often has a shape like a valley or mountain. Their size ranges from small like hills or much larger like mountains. Wind aeolian landforms. Wind, a powerful factor in hot deserts with scarce vegetation and low rainfall, creates unique aeolian landforms through erosion and deposition. Erosion landforms. Ovinifacts, rocks abraded and polished by windblown sand, forming pitted and grooved surfaces. Yardongs, streamlined ridges of compacted sand carved by wind erosion, aligned with the prevailing wind direction. Deflation hollows, blowout dunes. Hollows formed when wind removes loose surface material. O mushroom rocks. Wind erosion creates rocks with wider tops and narrower bases as wind blasts the lower portions more intensely. O zugin. Flat-topped mesas with a layer of soft rock beneath a harder cap rock, remnants of wind erosion. O inselbergs. Isolated hills with steep slopes and rounded tops, left behind by wind erosion of surrounding softer rock. Depositional landforms. O sand dunes. Wind-formed mounds of sand, found in deserts and along beaches. Crescentic dunes. Crescent-shaped dunes resembling the letter C. Linear dunes. Straight or nearly straight lines of dunes. Star dunes. Dunes with pointed ridges and slip faces on at least 3 sides. Parabolic dunes. Similar to crescent dunes but with the slip face facing inwards. Dami dunes. The rarest type, circular with no slip face. Loess. Fine wind-blown dust deposited beyond deserts, typically uniform and porous. Example. Loess deposits along the Mississippi River Valley. Glacial landforms. Glacier is a huge mass of moving ice that moves due to gravity. Erosion by glaciers is mainly due to plucking and abrasion. Erosional landforms. O cirques. Bowl-shaped depressions at high elevations created by glacial erosion on mountainsides. O nunataks, arates, and horns. These features result from erosion by multiple glaciers flowing in different directions. Nunataks. Rocky peaks protruding from glacier ice. Arates. Sharp ridges separating or once separating glaciers. Horns. Pointed peaks carved by glaciers on multiple sides. O crevasses. Deep cracks formed in moving glaciers. O fjords. Long, narrow inlets created when glacial valleys meet the ocean. Depositional landforms. O moraines. Hills or ridges formed by sediments deposited by melting glaciers. O glacial till. Unsorted mixture of rocks and debris left behind by glaciers, ranging from boulders to fine particles. Glacial flour. The finest component of glacial till, responsible for the cloudy appearance of glacial-fed rivers and lakes. O glacial erratics. Large boulders deposited by retreating glaciers, often far from their origin. Significance of glaciated landforms. O glaciated landforms act as clues to past climates. For instance, the presence of glacial boulders in places like Talcher, India, suggests a period of glaciation in the region's history. Landforms formed due underground waterkarst topography. Karst landscapes, characterized by unique landforms, are formed in regions with soluble bedrock, like limestone, and abundant rainfall. Erosional landforms. O sinkholes. Depressions or holes caused by collapsing bedrock or cave ceilings. O dolines. Larger depressions formed by merging sinkholes. O uvulus. Even larger depressions created by the merging of multiple dolines and sinkholes. O polges. Very large depressions, sometimes influenced by faulting. O disappearing streams. Surface streams that vanish underground through swallow holes, re-emerging as caves further on. Depositional landforms. O stalactites. Icicle-like formations hanging from cave ceilings, created by mineral precipitation. O stalagmites. Mounds rising from cave floors, formed by dripping mineral deposits. O pillars. The fusion of stalactites and stalagmites. Significance of karst landscape. O karst areas preserved artifacts from early human development. O provided valuable resources for our ancestors. O supported unique ecological niches with diverse life forms. Fluvial landform. Of fluvial systems are dominated by river and streams erosion. Erosional landform. O waterfalls, plunging rivers over hard rock ledges, often found in young rivers. O canyons and gorges, deep valleys with steep sides, formed by erosion. Canyons may have steep slopes and be very deep. O river valleys, low-lying areas between mountains or hills, often with a river flowing through them. O potholes, bowl-shaped depressions and rocks scoured by swirling water and sediments. Depositional landforms. O alluvial fans and cones, fan-shaped deposits of sediment left by flowing water. Fans have gentler slopes than cones. O natural levees, raised banks of sediment built up along a river's edge due to overflowing water. O floodplains, low, flat areas bordering rivers, prone to flooding and rich in sediment deposits. O channels and bars, elongated underwater sand ridges, channels, and elevated areas of deposited sediment, bars, within rivers. O deltas, triangular landforms at river mouths, formed by sediment deposition in lakes or seas, characteristic of mature rivers. Significance of fluvial landforms. O plains created out of the deposition of fluvial systems are one of the fertile regions of the world which has supported a number of civilizations. O also the rocks brought by the fluvial system represent the mineral composition of the source rocks. Coastal landforms. Erosional landform. O headlands and bays, powerful waves erode softer rock, carving out bays, while resistant rock forms jutting headlands. O cliffs and wave-cut platforms. Relentless waves pound cliffs, creating steep slopes. Erosion by waves also creates a flat, wave-cut platform at the cliff base. O caves, arches, stacks, and stumps. The relentless assault of waves on headlands carves caves. Over time, caves can grow into arches, then stacks, isolated rock pillars, and eventually stumps as erosion continues. Depositional landforms. O beaches. These sandy havens are formed from bits of rock worn down by waves and deposited by the sea. O spits, bars and lagoon. Spits are elongated stretches of sand extending into the sea. If a spit grows across a bay and connects two headlands, it becomes a bar, sometimes forming lagoons, shallow lakes, behind it. Significance of coastal landforms. Tourism hubs. Coastal landforms, especially beaches, are major tourist destinations. Mineral resources. Beaches can hold valuable minerals like gold, Subarnarekha River, and thorium Kerala. Growing threat of coastal erosion. Vulnerable coastlines. India's coastline faces significant erosion, threatening 33.6% of its coastline. Erosion in Odisha is a prime example, impacting 28% of its coast. Impact on communities. Coastal erosion displaces communities, destroys habitats, and disrupts fishing by taking away space for boats, nets, and operations. Government efforts for prevention of coastal erosion. Planting mangroves and shelter belts. Installing geotubes. Resettlement programs for displaced communities. Rs. 1,500 crores has been allocated for mitigation measures to prevent erosion. Conclusion. The study of geomorphology provides critical insights into the processes that shape the Earth's surface, offering a comprehensive understanding of the dynamic interactions between geological, hydrological, atmospheric, and biological forces. By examining landforms and the processes that create and modify them, geomorphologists can interpret the past environments and predict future changes, thereby contributing to our knowledge of natural hazards, environmental management, and landscape evolution. The knowledge gained from geomorphology equips us with the ability to make informed decisions that can protect and preserve our environment, ensure the sustainable development of resources, and safeguard communities from geomorphic hazards. As we move forward, continued research and education in this field will remain pivotal in our quest to understand and live harmoniously within the Earth's dynamic landscape. Keywords: Big Bang Theory, Nebular Hypothesis, Planetesimal Hypothesis, Tidal Hypothesis, Protoplanet Hypothesis, Radiometric Dating, Rotation, Revolution, Earth's Bulge, Coriolis Effect, Aphelion, Perihelion, Earth's Magnetosphere, Conrad Discontinuity, Mantle, Gutenberg-Weichert Discontinuity, Lithosphere, Asthenosphere, Karst Topography, Dolines, Uvulas, Pulges, Stalactites, Stalagmites. Previous to your question, Mains. 1. How are the fjords formed? Why do they constitute some of the most picturesque areas of the world? 2023. 2. Discuss the geophysical characteristics of Circum-Pacific Zone. 2023. How can the mountain ecosystem be restored from the negative impact of development initiatives and tourism? 2019. 4. Define mantle plume and explain its role in plate tectonics. 2018. 5. How does the Juno mission of NASA help to understand the origin and evolution of the Earth? 2017. 6. Why are the world's fold mountain systems located along the margins of continents? Bring out the association between the global distribution of fold mountains and the earthquakes and volcanoes. 2014. 7. Explain the formation of thousands of islands in the Indonesian and Philippines archipelagos. 2014. 8. What do you understand by the theory of continental drift? Discuss the prominent evidence in its support. 2013. OnlyIAS by Physics Wallah. 1 OFA Foundation UROB courses. Sankalp 2026. English. Prahaar 2025 Titan 2025. English. Starts from 9 for 99. English T. For extra discount, our planet is enveloped by a layer of gases, primarily nitrogen and oxygen, known as the atmosphere. This gaseous blanket extends outwards, taking a sphere-like shape, wider at the equator and slightly flattened at the poles due to Earth's rotation and gravity. The atmosphere is further divided into distinct layers, each with varying temperatures and unique chemical compositions. These layers are held in place by Earth's gravity, which also influences the types of gases present within the atmosphere. Difference between climate and weather timescale. Weather is short-term, hours to days, while argon 0.33%, xenon 0.000009%, neon 0.0012%, hydrogen 0.00005%, helium 0.0005%, krypton 0.0001%, carbon dioxide 0.32%, 20.35%, 72.02%, nitrogen, oxygen. Climate is long-term, decades to centuries. Think of weather as what you experience daily, and climate as the average weather patterns over a long period. Variability. Weather is highly variable, changing rapidly. Climate represents the average weather conditions, smoothing out the daily fluctuations. Spatial scope. Weather can vary significantly even over short distances. Climate describes the general weather patterns over a larger area, like a city, region, or the entire planet. Predictability. Weather is difficult to predict for more than a few days due to its sensitivity to small changes. Climate is more predictable on longer timescales because it's influenced by larger, more stable factors. Impact. Weather affects our daily lives, while climate has broader consequences for ecosystems, agriculture, water resources, and society as a whole. Climate change can have significant long-term impacts on everything from habitats to extreme weather events. Earth's atmosphere, the atmosphere is made up of different types of gases, water vapor, and dust particles. The composition of the atmosphere is not static. It changes according to the time and place. Nitrogen and oxygen are the two main gases in the atmosphere. 99% part of it is made up of these two gases. Other gases like organs, carbon dioxide, hydrogen, neon, helium, etc. form the remaining part of the atmosphere. Structure of atmosphere. Layers details. Troposphere. The lowest layer, averaging 13 kilometers high, with most weather phenomena. Thicker at the equator, 18 kilometers, and thinner at the poles, 8 kilometers. Temperature drops steadily with altitude, 1 degree Celsius per 165 m. Separated from the stratosphere by the tropopause, constant temperature around minus 45 degrees Celsius to 80 degrees Celsius. Stratosphere. Extends up to 50 kilometers above Earth. Contains most of the atmosphere's ozone, absorbing UV rays and causing temperature to rise with height. Temperatures vary seasonally, highest over the summer pole and lowest over the winter pole. Ideal for air travel due to minimal clouds and weather. May contain cirrus clouds at lower levels. Mesosphere. Above the stratosphere, reaching a minimum temperature of minus 90 degrees Celsius at the mesopause. Most meteors burn up here upon entering Earth's atmosphere. Extremely cold temperatures cause sublimation of scarce water vapor into polar mesospheric noctilucent clouds. Thermosphere. Temperature rises again due to absorption of ultraviolet and X-ray radiation from the Sun. The International Space Station and satellites orbit in this layer. The Kármán line, 100 kilometers altitude, separates Earth's atmosphere from outer space. Ionosphere, upper region, 80 to 400 kilometers, with electrically charged currents. Reflects radio waves, enabling radio communication. Exosphere, above the ionosphere, extending beyond 400 kilometers. Extremely thin air with gradually increasing temperature. Climate change and atmosphere. Human activity is causing changes in the lower and middle atmosphere, which in turn affect the upper atmosphere through wind patterns. These changes have significant consequences. Heat waves. Climate change intensifies high-pressure systems, leading to more frequent and severe heat waves. Contracting upper atmosphere. Rising C02 levels cool and shrink the upper atmosphere, impacting the lifespan of space debris. Surface ozone. Warming temperatures can increase ground-level ozone, a harmful air pollutant. Uneven heating and cooling. Ozone warms the climate, while some particles like black carbon can contribute to warming, and others like sulfates can have a cooling effect. Drastic climatic changes. Climate models predict drastic changes if we continue on a business-as-usual path, including a global temperature rise of 2.8 degrees Celsius, with even higher increases on land and in the Arctic. Addressing climate change is crucial to mitigate these atmospheric disruptions and their cascading effects. Heat budget. The Earth absorbs incoming solar radiation, shortwave radiation, and releases heat back into space as terrestrial radiation, long-wave radiation. This balance between the incoming and outgoing heat allows the Earth to maintain a stable temperature, which is referred to as the Earth's heat budget. Climate and Earth's energy budget. Uneven heating and regulation. The spherical Earth receives uneven solar heating, with warmer equatorial regions and cooler polar regions. Further, the atmosphere and oceans, Earth's heat engine, work together through various processes to redistribute heat and maintain equilibrium. Climate forcings and imbalance. Factors like solar activity, volcanic eruptions, natural and human activities, aerosols, deforestation, greenhouse gases, can disrupt this balance. These influences, called climate forcings, can tip the scales and lead to climate change. Human impact. The recent NASA study confirms human-generated greenhouse gases as the primary driver of global warming. This imbalance in Earth's energy budget, caused by trapped heat, results in long-term shifts in global climate patterns. Synergies between urban heat island and heat waves. Heat waves are periods of extremely high temperatures, exceeding typical maximum levels, often occurring in the northwestern and south-central regions of India during the summer season. Impacts of heat waves. Examples of heat wave impacts include the 2018 record-breaking heat wave in Northeast Asia, which resulted in a significant number of hospitalizations for heat strokes in Japan and prolonged high-temperature warnings in China. Role of anticyclones. Recent research suggests a correlation between the occurrence of extreme summer heat events in Northeast Asia and the involvement of anticyclones in the region. Urban heat island effect. During heat waves, urban areas experience amplified temperature increases compared to surrounding rural areas. Factors such as increased sensible heat release, reduced evaporative cooling, and higher anthropogenic heat contribute to this effect. Urban heat islands are formed as urban areas exhibit higher temperatures due to changes in the surface energy budget, increased heat storage capacity of artificial surfaces, and reduced evaporative cooling. Atmospheric river underscore 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 narrow channels of moisture. Atmospheric rivers are long, narrow corridors in the atmosphere that ferry vast quantities of water vapor from tropical regions towards the poles. Moisture powerhouses. These ribbons of moisture can stretch for thousands of kilometers and are characterized by exceptionally high water vapor content. Rainmakers and troublemakers. Atmospheric rivers play a critical role in Earth's water cycle, delivering essential precipitation. However, upon reaching land, they can unleash heavy rain and snowfall, potentially triggering floods, landslides, and other damaging weather extremes. Cryosphere and climate change. The cryosphere refers to those parts of the Earth's surface where water is in solid form, including snow cover, glaciers, ice caps, ice sheets, sea ice, frozen lakes and rivers, and permafrost, permanently frozen ground. According to the Intergovernmental Panel on Climate Change, IPCC, Special Report on the Ocean and Cryosphere in a Changing Climate, SROC, in recent decades, the cryosphere has experienced significant reductions due to global warming. This includes the shrinking of ice sheets and glaciers, diminished snow cover, decreased extent and thickness of Arctic sea ice, and rising temperatures in permafrost regions. Impacts of cryosphere on global climate. Albedo effect. The bright, reflective surfaces of the cryosphere bounce sunlight back into space, keeping Earth cool. However, melting ice exposes darker surfaces, leading to increased heat absorption and further warming. Rising seas. Melting glaciers and ice sheets contribute to rising sea levels, threatening coastal communities with flooding, erosion, and displacement. Ocean disruption. Freshwater from melting ice disrupts ocean salinity and temperature, impacting global circulation patterns and potentially altering regional climates. Feedback loops. The cryosphere interacts with other climate systems. Melting ice releases trapped greenhouse gases, accelerating warming in a vicious cycle. Water reservoir. The cryosphere stores vast amounts of freshwater as ice and snow. Changes in the cryosphere can disrupt water supplies for human consumption, agriculture, and hydropower, leading to scarcity and conflicts. Habitat loss. Melting ice threatens polar ecosystems and species reliant on cold conditions. This disrupts ecological balance and reduces overall biodiversity. Significance of cryosphere climate regulation. By reflecting sunlight, the cryosphere cools the planet and influences global climate patterns. Sea level control. The cryosphere helps regulate sea levels, preventing catastrophic flooding of coastal regions. Water security. Melting ice provides freshwater for ecosystems and human populations downstream. Climate feedback. Changes in the cryosphere can amplify climate change through feedback loops. Biodiversity support. The cryosphere sustains unique ecosystems and cold-adapted species. Weather patterns. The cryosphere influences weather patterns, affecting storms, precipitation, and temperature extremes. Initiatives to protect cryosphere. PACER, Polar Science and Cryosphere Research. This program directly investigates the polar regions and all forms of frozen Earth surfaces. PACER supports research on polar climates, ice sheets, glaciers, and permafrost, fostering collaboration among scientists and institutions to build a comprehensive knowledge base on these critical regions. Across Atmosphere and Cryosphere through the Earth System Science Research Program, this initiative focuses on the interconnectedness between the atmosphere and the cryosphere. Across aims to improve our understanding of how these two systems interact and influence climate change, weather patterns, and environmental processes. Fujiwara effect. Definition. The Fujiwara effect is a phenomenon in meteorology where two nearby cyclonic systems, such as tropical cyclones or hurricanes, rotate around a common center and interact with each other. The effect occurs when the cyclones are close enough to influence each other's movement and intensification. Conclusion. In essence, climatology not only deepens our scientific comprehension of Earth's climate systems but also empowers us to make informed decisions to safeguard our planet's future. As we continue to face the realities of a changing climate, the importance of ongoing research, education, and international cooperation in climatology cannot be overstated. Through a collective effort, we can better understand, predict, and respond to the climatic changes that shape our world. Keywords: interseasonal oscillation, monsoons active and break periods, surface level ozone, ground ozone, magnetic dipole uneven warming and cooling, short wave and long wave radiation, climate forcings, highly reflective blanket, albedo, decline in Arctic sea ice, coastal community on risk, permafrost, polar vortexes, etc. Previous your question. 1. Troposphere is a very significant atmosphere layer that determines weather processes. How? 2022-2. The process of desertification does not have climate boundaries. Justify with examples. 2019-3. How does the cryosphere affect global climate? 2017-4. Discuss the concept of air mass and explain its role in macroclimatic changes. 2016-5. Tropical cyclones are largely confined to the South China Sea, Bay of Bengal, and Gulf of Mexico. Why? 2014-6. Most of the unusual climatic happenings are explained as an outcome of the El Niño effect. Do you agree? 2014-7. Bring out the causes for the formation of heat islands in the urban habitat of the world. 2013-8. What do you understand about the phenomenon of temperature inversion in meteorology? How does it affect the weather and the inhabitants of the place? 2013. Oceans cover more than 70% of the Earth's surface. Its health, humanity's well-being, and the living environment that keeps us all alive are all intricately interwoven. Despite this, ocean acidification, climate change, polluting activities, and overexploitation of marine resources have made oceans one of the most endangered ecosystems on the planet. Ocean reliefs, continental shelf, shallow submerged extension of the continent is called the continental shelf. Continental slope, the continuous sloping portion of the continental margin, extending down to the deep sea floor of the abyssal plain, is known as continental slope. Abyssal plains, these are the extremely flat and featureless plains of the deep ocean floor. Submarine trenches, oceanic trenches are prominent, long, narrow topographic depressions of the ocean floor. Salinity refers to the amount of dissolved salts in grams per kilogram of seawater. It's a crucial factor influencing ocean behavior and climate. Why is salinity important? Ocean circulation, salinity, along with temperature, determines seawater density, which drives ocean currents that transport heat around the globe, impacting global climate. Water cycle, sea surface salinity reflects Earth's water cycle, indicating the balance between freshwater entering precipitation, rivers, and leaving evaporation, the oceans. Factors affecting salinity, evaporation. High evaporation in warm, dry regions increases salinity. Freshwater input, precipitation, rivers, and icebergs decrease salinity, e.g., equatorial regions. Ocean current mixing. Enclosed seas with limited mixing have higher salinity, while freely circulating areas have lower salinity. Climate change. Rising temperatures lead to increased evaporation and potentially higher salinity. Distribution of salinity, vertical. Salinity generally increases with depth at high latitudes, peaks around 35 meters in mid-latitudes, and then decreases towards the equator. Horizontal. Global ocean salinity ranges from 33 to 37 grams per kilogram. The highest salinity is observed between 15 degrees and 20 degrees latitudes, gradually decreasing northward. Regional variations in salinity. Pacific Ocean. Salinity varies due to its vast size and shape. Atlantic Ocean. Average salinity is around 36 to 37 grams per kilogram. Indian Ocean. Average salinity is 35 grams per kilogram. The Bay of Bengal has lower salinity due to the Ganges River, while the Arabian Sea has higher salinity due to high evaporation. Other seas. The North Sea witnesses higher salinity due to more saline water influx by the North Atlantic Drift. The Baltic Sea has low salinity due to the addition of river waters in huge amounts. The Mediterranean Sea shows higher salinity because of high evaporation. Black Sea records low salinity due to huge freshwater influx by rivers. Impact of salinity. First, along with temperature, they directly affect seawater density. Salty water is denser than freshwater, and therefore the circulation of ocean currents from the tropics to the poles. Sea surface salinity is closely linked to Earth's overall water cycle and to flow of freshwater in and out of oceans through evaporation and precipitation. Any changes, small or big, in salinity and ocean currents can affect the climate of the region and marine life. Movement of ocean waters. The movement of ocean water takes place in three forms, which are waves, tides, and currents. Waves. Ocean waves are created by wind transferring energy to the water, causing the characteristic rise and fall in oscillatory movements. Waves move horizontally, with the energy traveling through the water, not the water itself. The highest point of a wave is called the crest, while the lowest point is called the trough. Tides. Tides are the regular rise and fall of sea levels, occurring once or twice daily. The gravitational pull of the moon, sun, and Earth's rotation are the primary forces driving tides. Tides are divided based on frequency and sun-moon-Earth alignment. Based on frequency, semi-diurnal tides, 2 high and 2 low tides occur in a day. Diurnal tides, only 1 high and 1 low tide occur in a day. Based on sun-moon-Earth alignment, spring tides, highest and lowest tides occur when the sun, moon, and Earth are in a straight line, new moon or full moon. Neap tides, less dramatic high and low tides occur when the sun and moon are at right angles to Earth, first and third quarters. Ocean currents. The ocean currents are the horizontal flow of oceanic water in a particular direction over a long distance. They are like a flowing river within the ocean. Forces driving ocean current. Primary forces, which initiate water movement. Sun's heat, insolation. Warmer equatorial waters expand, causing a slight bulge compared to cooler mid-latitude waters, initiating movement. Wind's influence. Surface water is dragged by wind friction with the Coriolis force, deflecting winds due to Earth's rotation, shaping current direction, rightward in the north, leftward in the south. Examples include the Gulf Stream, north, and the Brazilian Current, south. O. Landmasses as obstacles. Landmasses like the tip of South America divert currents, creating the Peruvian current. Secondary factors, which impact current flow. O. Temperature and salinity. Denser, saltier water sinks, while lighter water rises, influencing vertical movement within currents. O. Climate change impact. Rising sea surface temperatures due to greenhouse gases may disrupt major currents like the Atlantic Meridional overturning circulation, AMOC, potentially altering global climate patterns. Effects of ocean current. Climate control. Ocean currents play a significant role in regulating regional climates. Warm currents raise temperatures in nearby areas, while cold currents have a cooling effect, e.g., North Atlantic drift warming England, Canary current cooling Spain and Portugal, rainfall in deserts. Warm currents contribute to increased rainfall along coastlines and even inland areas. Conversely, cold currents can create deserts on the western sides of continents and subtropical zones. Fishing zone. The convergence of warm and cold currents creates ideal conditions for plankton growth, which in turn supports abundant fish populations, making these areas prime fishing grounds. Navigation. Ocean currents can influence ship navigation. Understanding these currents allows for more efficient travel routes. Temperature moderation. By redistributing heat, currents help regulate coastal temperatures. For instance, the warm North Atlantic drift keeps the coast of England mild, while the Canary current tempers the climate of Spain and Portugal. Gyre, drift, and stream. Features description. Gyre, large system of rotating ocean current, with large wind movements, is called a gyre. Force, Coriolis force. Drift. When the huge ocean water moves forward because of the prevailing wind, it is called a drift. E.g. North Atlantic drift. Stream. Ocean water moving in a definite path like a river on the continent is called a stream. They are speedier than drifts. E.g. Gulf Stream. Climate change and ocean circulation. The vast network of ocean currents plays a critical role in regulating Earth's climate. These currents transport heat, impacting everything from local weather patterns to global climate stability. Changes in ocean circulation due to climate change can have far-reaching consequences. Disrupted marine ecosystems. Shifts in water temperature and currents can disrupt spawning grounds and alter the connectivity between marine ecosystems, impacting fish populations and overall biodiversity. Altered carbon cycle. Melting sea ice caused by warming winds disrupts the growth of algae, which plays a crucial role in absorbing atmospheric carbon dioxide. This can further accelerate climate change. Fisheries at risk. Changing current patterns can disrupt the recruitment of fish stocks, jeopardizing food security and livelihoods for millions who depend on the ocean. Multiple threats. Rising ocean temperatures, acidification, and declining oxygen levels create a multitude of threats to marine life and the delicate balance of ocean ecosystems. Coral reefs. Coral reefs are underwater structures built by tiny coral animals called polyps. Hundreds to thousands of polyps work together, forming colonies that create these vibrant ecosystems. India has 3 major types of coral reefs. O. Fringing reefs, bordering the coastline, creating shallow lagoons. O. Barrier reefs, running parallel to the shore at a distance. O. Atolls, ring-shaped reefs encircling a lagoon, found in mid-ocean. Ideal environmental conditions for corals to grow. Sunlight. Zooxanthellae algae within polyps need sunlight for photosynthesis. Solid foundation. A hard surface allows for attachment and reef development. Warm, clear water. Ideal temperatures are around 20 degrees Celsius with good water clarity. Salinity. Corals extract calcium from salty water to build their skeletons. Nutrients. A steady supply of nutrients supports healthy coral growth. Impact of global warming on coral life system. Rising ocean temperatures, a consequence of global warming, pose a significant threat to coral life. This warming triggers coral bleaching, a phenomenon where coral expels the vital algae living within them, causing them to turn white and weaken. Example: Great Barrier Reef in Australia. Coral bleaching is becoming increasingly severe and frequent due to heat stress. Factors causing coral bleaching. Ocean warming. Climate change is the primary culprit. Pollution, runoff, storm-generated debris, and other pollutants can harm corals. Excessive sunlight. High solar radiation can bleach shallow water corals. Low tides. Extended exposure to air during low tides can bleach shallow corals. Significance of coral reef for ocean ecosystem. Economic powerhouse. Reefs support fisheries and tourism, generating jobs and revenue. Biodiversity hotspot. Coral reefs teem with marine life, housing around 4,000 fish species and countless others. Natural barrier. Reefs protect coastlines by absorbing wave energy, reducing erosion and storm damage. Conservation of corals. Sustainable practices and a reduction in human impact are crucial to prevent further damage and allow coral reefs to recover. Legal safeguards. India has implemented various laws to protect coral reefs, including the Wildlife Protection Act, 1972, Schedule 1, the Environment Protection Act, 1986, EPA, Coastal Regulation Zone Notification, CRZ, 1991 under the EPA, Marine Protected Areas, MPAs. Ocean pollution. Ocean pollution is a growing threat which encompasses a variety of contaminants, including toxic metals, chemicals, plastics, waste, and agricultural runoff. These pollutants disrupt delicate marine ecosystems and pose a risk to human health. Impact of ocean pollution. Hazard of microplastics. Microplastics are plastic particles smaller than 5 millimeters, are a major concern. They account for over 80% of ocean debris. Marine life ingests these microplastics, mistaking them for food. This contamination travels up the food chain, potentially reaching humans who consume seafood. Harm marine life. Ingestion of microplastics can reduce feeding capacity and harm marine organisms. Overall, ocean pollution disrupts ecosystems and destroys habitats. Oxygen depletion. Decomposing debris depletes oxygen levels in the water, suffocating marine life. Example: formation of dead zones, human health risks. Research suggests ocean pollution can harm human health through contaminated seafood and sea spray aerosols containing pollutants. Marine pollution mitigation. Climate change action. Reducing greenhouse gas emissions is crucial to combat climate change, a major contributor to ocean pollution. Enhanced monitoring. Better observation and data analysis are needed to understand oxygen depletion and other ocean health changes. Raising awareness. Public education is key to changing human behavior and mitigating the impact of our activities on the oceans. International efforts. Regulations and treaties. Several international agreements like MARPOL and UNCLOS aim to control pollution from ships and protect the marine environment. These efforts require continued enforcement and strengthening. Fact-wise, according to one of the UNESCO research, plastic waste makes up 80% of all marine pollution, and around 8 to 10 million metric tons of plastic end up in the ocean each year. Research states that, by 2050, plastic will likely outweigh all fish in the sea. Marine resources encompass a vast array of valuable materials found in the ocean, from living organisms, fish, coral, to minerals, oil, gas, and even tourism potential. These resources take millions of years to form, like oil and gas deposits from decayed marine life. Marine wealth comes in many forms. Biological resources. This includes animal life, fish, shellfish, etc. Plant life, phytoplankton, seagrass, and coral reefs. Mineral resources. These include sand and gravel deposits, as well as fuel minerals like oil and natural gas. Human activities threaten these vital resources. A recent report indicates that over 60% of the world's coral reefs are under threat. Marine heatwaves and unsustainable fishing practices further endanger marine ecosystems. Conservation measures. International initiatives like the Blue Carbon Initiative and Blue Nature Alliance promote conservation and restoration of marine ecosystems. Programs like Magical Mangroves raise awareness about the importance of mangrove protection. Blue infrastructure development in Southeast Asia seeks to balance coastal development with ecological protection. Fact-wise, as per Global Biodiversity Outlook 5, GBO 5, 2020, more than 60% of the world's coral reefs biodiversity are under threat. 2016 marine heatwaves across North Australia led to severe bleaching of the Great Barrier Reef, led to mangrove die-offs in the Gulf of Carpentaria. The proportion of fish stocks fished sustainably is down by 5% since 2010. Atlantic Meridional Overturning Circulation, AMOC. The AMOC is a massive system of ocean currents transporting warm tropical waters northward. This circulation is crucial for regulating global climate as it redistributes heat, impacting weather patterns worldwide. AMOC's influence, fluctuations, and impacts. The AMOC naturally fluctuates, but a weakening could have significant consequences. For instance, the U.S. East Coast might face rising sea levels, Europe could experience harsher winters and more extreme heat waves, and the UK could see an increase in intense storms. Indian Ocean's role. Interestingly, recent research suggests rising temperatures in the Indian Ocean might actually help AMOC by influencing air and water circulation patterns in the Atlantic. Understanding the AMOC's complex dynamics and potential influences like the Indian Ocean is crucial for predicting future climate patterns and mitigating their potential impacts. Importance. It controls ocean heat distribution and atmospheric carbon dioxide levels, thus playing a critical role in global climate. Deep ocean exploration initiatives. The vast expanse of the deep ocean remains largely unexplored, holding immense potential for resource discovery and scientific understanding. Let's have a look into 3 key initiatives. Deep Ocean Mission, DM, launched by India. DM tackles technological challenges to explore the deep sea. Its focus areas include underwater vehicles, resource extraction technologies like those for polymetallic nodules, and even climate change consulting services. This mission aims to unlock valuable resources within India's exclusive economic zone and boost the nation's blue economy. Seabed 2030. This collaborative project strives to create a definitive map of the entire ocean floor by 2030. By gathering and integrating existing bathymetric data, Seabed 2030 offers crucial insights for understanding ocean circulation, marine ecosystems, and climate patterns. This global effort empowers informed decision-making related to ocean health, a critical factor for the well-being of our planet and its people. OStorms. This comprehensive program emphasizes the importance of ocean data in various aspects. OStorms focuses on improving ocean services, developing advanced technologies and observations, assessing resources, and conducting scientific research. By creating robust ocean models, OStorms aims to support sustainable management of ocean resources and inform policy decisions. Conclusion. Oceanography is a vital field that enhances our understanding of the world's oceans, which cover over 70% of Earth's surface. The study of ocean currents, marine ecosystems, and oceanic processes not only enriches our knowledge of natural phenomena but also highlights the critical role oceans play in regulating climate, supporting biodiversity, and sustaining human livelihoods. As we face increasing environmental challenges, the insights gained from oceanography are essential for developing sustainable practices and policies to protect our oceans and ensure the health of our planet for future generations. Keywords: ocean acidification, salinity, continental shelf, ocean currents, tides, waves, coral reefs, marine pollution, marine resources, phytoplankton, seagrass, microplastics, Atlantic meridional overturning circulation, MOC, deep ocean exploration, bathymetric data, blue economy, seabed 2030, OStorms, sustainable management, climate change. Previous year question mains. 1. Discuss the causes of depletion of mangroves and explain their importance in maintaining coastal ecology. 2019 2. How do ocean currents and water masses differ in their impacts on marine life and the coastal environment? Give suitable examples. 2019 3. Assess the impact of global warming on coral life system with examples. 2019 4. What are the consequences of spreading dead zones on marine ecosystem? 2018 5. Explain the factors responsible for the origin of ocean currents. How do they influence regional climates, fishing, and navigation? 2015 6. Critically evaluate the various resources of the oceans which can be harnessed to meet the resource crisis in the world. 2015. UPSC Optional Course 2025 English FT. Anthropology PSIR History. Sociology Geography Public Administration. Adjust coupon code 8 999 for extra discount. L992-061-3613 PW. Live India's climate significantly impacts its people's lives. The tropical monsoon climate, with its hot and humid summers and monsoonal rains, shapes everything from economic activities to clothing choices. However, this weather is highly variable, with extreme events like droughts, floods, and cyclones disrupting lives and livelihoods. These events are expected to worsen due to climate change. Fact-wise. For seasons: winter, December to February; summer, March to May; monsoon, June to September; and post-monsoon or autumn, October and November. Extreme temperatures: above 50 degrees Celsius in summer in Churu, Rajasthan, and in winter minus 45 degrees Celsius in Dras, Ladakh. Regional variation: hot-cold in the north, moderate on the coast, arid in the west, and humid in the northeast. Varying rainfall patterns: heavy on the western coast, wet in the northeast. Highest rainfall occurs in Cherrapunji, Meghalaya, around 1080 cm, and in Jaisalmer, Rajasthan, records merely above 9 cm. Cyclones: coastal regions prone to cyclones, especially in the Bay of Bengal. Characteristic features of Indian climate. India's climate is a complex interplay of several factors: geographic diversity, location, altitude, distance from the sea, and local relief features all contribute to regional variations. Multiple seasons. India experiences 3 primary seasons: winter, summer, monsoon, but can be further divided into 6 based on subtle weather shifts. Seasonal wind reversal. Winds change direction between winter, northeast to southwest, and summer, southwest to northeast. Monsoonal rainfall. Most of the annual rainfall, 80%, occurs in short bursts during the summer monsoon. Pressure systems. High and low pressure systems over land influence temperatures, with summer heat creating low pressure areas. Natural calamities. The monsoonal nature of rainfall makes India prone to floods, droughts, and other weather-related disasters. Jet stream influence. The upper air circulation patterns, including the westerly jet stream, impact winter weather. Latitudinal variation. Southern India, closer to the equator, is generally hot, while the north experiences colder winters due to its temperate zone location. Keywords: weather patterns. Sea level rise. Reversal off winds. Seasonal and variation of rainfall. Diversity of Indian climate. Plurality of seasons. Surface pressure and wind. Jet stream and upper air circulation. Western cyclonic disturbance and tropical cyclones. Impact of high and low pressure over the land. Distances from the sea, continentality. Distribution of air pressure and winds. Inflow of western cyclones. Factors determining the climate of India. Location and relief: Himalayan mountains. The Himalayas block cold Arctic winds, shaping India's climate. Land and water distribution. Uneven heating of land and sea creates distinct seasonal air pressure zones. Coastal proximity. Coastal areas experience moderate temperatures due to the sea's influence, while inland regions face extremes, e.g., the Konkan coast has moderate temperatures but Kanpur and Amritsar are affected by extreme temperatures. Altitude. Temperatures decrease with elevation as air cools during ascent. Varied relief. India's diverse topography impacts temperature, air pressure, wind patterns, and rainfall distribution. Air pressure and winds pressure and wind systems. Temperature, elevation, and Earth's rotation influence air pressure and wind patterns, driving airflow from high to low pressure zones. Jet streams. Upper-level wind currents, jet streams, redistribute heat and moisture across the globe. Air masses. Distinct air masses, categorized by temperature and moisture, influence different regions. In winter, western cyclones bring rain to specific areas, while the southwest monsoon triggers widespread rainfall due to tropical depressions arising from the warm Indian Ocean. These factors have different mechanisms with reference to the winter and summer season of the year separately. Indian monsoon. The term monsoon is derived from the Arabic word mawsanti meaning season. It is a global phenomenon caused by seasonal wind reversals. However, the most significant monsoon rains occur in South Asia, particularly India, Myanmar, Sri Lanka, Bangladesh, and Bhutan. For India, the monsoon is critical, bringing seasonal rains that shape its agriculture, economy, and way of life. The arrival, duration, intensity, and distribution of the monsoon are all vital factors. The thermal theory of monsoons. Halley's thermal theory attributes the Indian monsoon to the uneven heating of land and sea caused by the sun's apparent northward movement. Two key factors contribute to the strong monsoons in India: the vast size of the subcontinent and surrounding seas, and the towering Himalayas. Halley's theory explains the mechanism as follows. Solar shift. After the March equinox, the sun appears to move north, increasing solar radiation in the northern hemisphere, especially over India. Intense heating. This radiation heats the Indian subcontinent, creating a large low-pressure belt stretching from the northwest plains to the east coast. Low-pressure system. This low pressure acts like a magnet, drawing in moisture-laden air masses from the surrounding oceans. Monsoon onset. The inflow of these air masses triggers the arrival of the monsoon season in India. Origin of Indian monsoon. The Indian monsoon, driven by differential heating of land and sea, is influenced by several other key factors. Jet streams. Subtropical jet stream weakens and shifts north, allowing monsoon winds to move northward and bring rain. Tropical easterly stream guides moisture-laden depressions from the Bay of Bengal and Arabian Sea, influencing rainfall patterns. Subtropical westerly jet stream plays a role in winter rainfall by bringing western cyclonic disturbances. The Himalayas and Tibetan Plateau. Heating of these land masses initiates the monsoon circulation with clockwise air movement and creates the foundation for both the tropical easterly jet stream and the Central Asian westerly jet stream. El Niño Southern Oscillation, YNSO events involving temperature fluctuations in the Pacific Ocean significantly impact global weather patterns, including the Indian monsoon. El Niño. Warmer Pacific waters during El Niño lead to drier conditions and deficient monsoon rainfall in India. La Niña. La Niña typically brings stronger than normal monsoon rainfall to India. Walker circulation. Pressure and temperature variations between the Pacific Ocean regions drive the Walker circulation. A stronger Indian Ocean branch during La Niña leads to more intense monsoon winds and potentially higher rainfall. Weaker monsoon winds are observed during El Niño events. Jet streams. Jet streams are fast-moving currents of air high in the atmosphere, typically between 6 and 9 miles above Earth's surface. These currents are characterized by strong winds blowing predominantly from west to east. The Earth's uneven heating, especially between warm and cold air masses, creates the temperature difference that fuels jet stream formation. Factors influencing flow. Land masses. Land creates friction and disrupts the smooth flow of jet streams, causing them to meander. Earth's rotation strengthens this effect, leading to the jet stream's characteristic wavy pattern. Coriolis effect. This phenomenon deflects moving air masses, shaping the jet stream's curved path. It deflects air to the right in the northern hemisphere and left in the southern hemisphere. Key features. Flow and location. Jet streams generally flow west to east, influenced by Earth's rotation. They encircle the globe, commonly found between the poles and 20 degrees latitude in both hemispheres. Meandering path. Their path is not a straight line, but a wavy pattern influenced by atmospheric conditions. Wind speeds. The jet streams have an average velocity of 120 km per hour in winter and 50 km per hour in summer. The strongest winds are typically found at the crests and troughs of the jet stream. Seasonal shifts. The jet stream's position changes with seasons. In winter, it follows the southern slopes of the Himalayas, while in summer, it shifts north due to variations in land and ocean heating patterns. Types of jet streams. Subtropical jet streams. Located above 30 degrees latitude in both hemispheres, these jet streams have a more consistent west-to-east flow due to Earth's rotation. Mid-latitude or polar front jet streams. Found between polar jet stream is located between 50 to 60-degree latitude lines in both northern and southern hemispheres. Latitude. These jet streams form where cold polar air meets warm tropical air. They move east, but have a more variable position compared to subtropical jet streams due to the dynamic nature of the polar front. Nature and important aspects of monsoon. Systematic studies of rainfall in the South Asian region provide insights into various aspects of the monsoon, including O. Onset of the monsoon. O. Rain-bearing systems. O. Break in the monsoon. O. Retreat of the monsoon. Onset of the monsoon. The arrival of the monsoon in India is influenced by several key factors: land and sea temperature contrast. Summer's intense heat creates a low-pressure zone over northwest India. This suction effect attracts moisture-laden southeast trade winds across the equator, triggering the monsoon's journey. Intertropical convergence zone, ITCZ, on the move. The ITCZ, a belt of low pressure where trade winds converge, shifts northward with the sun's apparent movement. This shift aligns with the arrival of the monsoon in India. Additionally, some other specific conditions also influence the southwest monsoon's onset: low-pressure systems. Low-pressure areas or depressions forming in the Bay of Bengal and Arabian Sea around late May or early June can kickstart the monsoon's mainland arrival. Cyclonic activity. The formation of cyclonic vortices near Kerala and Lakshadweep can push the monsoon current northward along the west coast. Temperature-driven troughs. Temperature differences between land and sea can create a trough off the west coast, potentially leading to a delayed or weakened monsoon onset. Crossing the equator. When trade winds from the southern hemisphere cross the equator, they bring a powerful surge of monsoon winds towards India. Rain-bearing systems. The southwest monsoon splits into two branches upon reaching the southern tip of the Indian peninsula: the Arabian Sea branch and the Bay of Bengal branch. Arabian Sea branch. This branch divides into three streams upon reaching mainland India. The first stream strikes the western coast head-on, causing heavy rainfall exceeding 250 centimeters annually due to the orographic effect. This means winds carrying moisture rise over the western Ghats, causing heavy precipitation on the windward side, up to 500 centimeters, and a dramatic reduction on the leeward side, around 30 to 50 centimeters. The second stream travels through the Nirmada Tapi troughs, a narrow valley system in central India. The third stream moves alongside the Aravalli Range with minimal rainfall impact. Bay of Bengal branch. This branch also splits into two distinct streams. The first stream crosses the Ganga-Brahmaputra Delta and reaches Meghalaya, encountering the orographic effect once again. This results in intense rainfall, with Cherrapunji receiving an average of 1,102 centimeters annually and Mawsynram holding the record for the highest yearly rainfall at 1,221 centimeters. The second stream follows the Himalayan foothills, deflected westward by the mountain range, and brings widespread rainfall to the Ganges Plain. Break in the monsoon. During the southwest monsoon period, after having rained for a few days, if rain fails to occur for 1 or more weeks, it is known as a break in the monsoon. These dry spells are quite common during the rainy season. Retreat in monsoon. In simple words, retreating means withdrawal. So, the withdrawal of southwest monsoon winds from the skies of North India during the months of October and November is known as the retreating monsoon. The withdrawal is gradual and takes about 3 months. Indian Ocean Dipole, IOD. In Indian monsoon, the Indian Ocean Dipole, IOD, is a climate phenomenon characterized by the difference in sea surface temperature between the eastern, Bay of Bengal, and western, Arabian Sea regions of the Indian Ocean. The Indian Ocean Dipole, IOD, has a significant impact on the Indian monsoon, influencing the distribution and intensity of rainfall across the Indian subcontinent. The positive and negative phases of the IOD can have contrasting effects on the monsoon rainfall patterns. Positive IOD. Warmer west, cooler east. Warmer sea surface temperatures in the western Indian Ocean and cooler temperatures in the east create a positive ID phase. Enhanced monsoon. This temperature pattern strengthens atmospheric conditions that favor monsoon circulation. It leads to increased moisture transport and higher rainfall, particularly in central India. Increased rainfall. Observations show that central India receives above-average rainfall during positive ID years. Negative ID. Cooler west, warmer east. A negative ID occurs when the temperature gradient reverses, with cooler waters in the west and warmer waters in the east. Weaker monsoon. This disrupts the monsoon circulation, leading to a weaker and potentially delayed monsoon arrival. Drought risk. Negative ID can contribute to drought conditions, particularly in central and eastern India, due to below-average rainfall. El Niño and Indian monsoon. El Niño, a Pacific Ocean warming phenomenon, significantly affects the Indian monsoon. Warmer central and eastern Pacific waters disrupt global atmospheric circulation patterns, impacting the Indian subcontinent's rainfall. Some key points regarding El Niño. Weakened monsoon. El Niño disrupts atmospheric circulation, reducing moisture flow across the equator. This translates to weaker monsoons and decreased rainfall across India. Delayed arrival. El Niño can delay the monsoon's arrival, impacting agricultural planning, water resource management, and other sectors dependent on timely rainfall. Uneven distribution. El Niño's effects vary across India. Central and northern regions are more susceptible to below-average rainfall and drought during El Niño years. Regional variations. El Niño can disrupt rainfall patterns, leading to areas with increased deficits and others with localized flooding. The severity depends on the El Niño's strength and regional atmospheric conditions. La Niña and Indian monsoon. La Niña is a climate pattern characterized by cooler than average sea surface temperatures in the central and eastern equatorial Pacific Ocean, along with changes in atmospheric circulation patterns like winds, pressure, and rainfall. Impact on Indian monsoons. Enhanced monsoonal rainfall. La Niña conditions generally lead to increased rainfall during the southwest monsoon, June-September, over India. Reduced winter rainfall. However, La Niña has an adverse effect on the northeast monsoon, December-February, bringing less rainfall to the region. Cyclone activity. La Niña years tend to see low-pressure systems and cyclones forming in the Bay of Bengal positioned further north than usual. Reduced rainfall in southern India. Due to this northward shift, these systems tend to recurve, bend back eastward, instead of moving westward. Consequently, southern Indian regions like Tamil Nadu receive less rainfall during La Niña events. Why cyclones are rare during peak monsoon months, July and August? Tropical cyclones require specific environmental conditions for formation. These include warm ocean waters. Surface water temperatures need to be at least 26.5 degrees Celsius throughout a significant depth, around 50 meters. Moist layers. The atmosphere needs to be relatively moist, especially at around 5 kilometers above the surface. Low wind shear. Minimal variation in wind speed and direction between the surface and upper atmosphere is crucial. However, during the peak monsoon months of July and August, certain factors reduce the likelihood of cyclone formation. Strong surface winds. Monsoon winds blow from the southwest or west at the surface, particularly south of the monsoon trough. Easterly or southeasterly winds prevail north of the trough, and these winds are generally stronger over the ocean than land. Upper-level winds. Upper-level winds also exhibit a westerly or southwesterly direction to the south and a southeasterly or easterly direction to the north of the monsoon trough. These winds increase in speed with altitude. Westerly winds reach a maximum of 20 to 25 knots, while easterly winds strengthen significantly, reaching speeds of 60 to 80 knots over the Indian Peninsula. High wind shear. The combination of strong and varying winds at different altitudes creates high vertical wind shear, which disrupts the development and organization of a storm system, making cyclone formation unfavorable during these months. While the monsoon season provides the warm ocean temperatures and moist atmosphere necessary for cyclones, the strong and variable wind patterns prevalent during July and August create high wind shear, hindering the development of these powerful storms. Impact of cyclones. Anticyclones on monsoon. The Indian monsoon may experience further delays and weakening due to the presence of an anticyclone in the Arabian Sea, a cyclone in the Indian Ocean, and a powerful typhoon in the Pacific Ocean. The anticyclone and typhoon can hinder the flow of monsoon winds towards the mainland, potentially impacting rainfall distribution and causing delays in the monsoon onset. However, the Indian Meteorological Department has rejected these speculations and stated that the impact of these oceanic activities on the monsoon is not scientifically supported. The condition of El Niño is also a factor that could affect the monsoon, although its impact is deemed to be insignificant by the IMD. The possibility of a weaker and delayed monsoon has already shown its impact on early crop sowing, with a decrease in rice acreage. Distribution of rainfall. Key factors determining distribution of rainfall. Relief features. Mountains and plateaus play a crucial role. Areas on the windward side, facing the moisture-laden winds, receive more rain than the leeward side. For example, the Western Ghats receive heavy rainfall due to their windward position. Cyclonic depressions. These low-pressure systems bring heavy rain to specific regions as they move across the country. The eastern coast and deltas often experience heavy rainfall due to depressions forming over the Bay of Bengal. Direction of winds. The direction of moisture-laden winds significantly impacts rainfall distribution. For instance, the Aravalli Hills block the Arabian Sea branch of the monsoon, leading to low rainfall in Rajasthan. Rainfall patterns. Decreasing northward. Rainfall generally decreases as we move north from Meghalaya, known for its high rainfall, towards the plains of Haryana and Punjab. Coastal to interior decrease. Similar to the north, rainfall in peninsular India tends to decrease as you move inland from the coast. Altitude increase. In the northeast, rainfall increases with altitude, with Mawsynram, located on a plateau, receiving exceptionally high rainfall. Rainfall distribution. High rainfall above 200 centimeters Western Ghats, subhimalayan regions of the northeast, and the Garo, Khasi, and Jaintia hills of Meghalaya. Moderate rainfall. 100 to 200 centimeters parts of the Western Ghats, West Bengal, Odisha, Bihar, and several other states. Low rainfall 60 to 100 centimeters parts of Uttar Pradesh, Rajasthan, and the interior Deccan Plateau. Inadequate rainfall, less than 60 centimeters Western Rajasthan, Gujarat, Ladakh, and parts of south-central India. Changing rainfall pattern in the country. The India Meteorological Department, IMD, analyzed monsoon rainfall patterns across India using data from the past 30 years, 1989 to 2018, at both state and district levels. Key findings are decreasing rainfall. 5 states, Uttar Pradesh, Bihar, West Bengal, Meghalaya, and Nagaland, experienced significant declines in southwest monsoon rainfall during this period. Annual rainfall in these states, along with Arunachal Pradesh and Himachal Pradesh, also shows a downward trend. State-specific variations. While the above states saw a decrease, other regions haven't shown any significant changes in southwest monsoon rainfall during the analyzed timeframe. District-level analysis. Examining rainfall data at the district level reveals more nuanced patterns. Several districts across the country experienced significant changes in both southwest monsoon and annual rainfall over the past 30 years. Increase in heavy rainfall events. Interestingly, the frequency of heavy rainfall days has increased significantly in certain areas, including Saurashtra and Kutch, parts of Rajasthan, Tamil Nadu, Andhra Pradesh, Odisha, Chhattisgarh, Madhya Pradesh, West Bengal, Northeast India, Konkan and Goa, and Uttarakhand. Köppen's classification of climatic regions of India. Köppen identified a close relationship between the distribution of vegetation and climate. Köppen's classification of climatic regions of India is an empirical classification based on mean annual and mean monthly temperature and precipitation data. Köppen climatic groups are subdivided into types, designated by small letters, based on the seasonality of precipitation and temperature characteristics. Climate classification and climate region are as follows. Monsoon type. With the short dry season, AMW. The western coastal region south of Goa experiences this type of climate. O monsoon type. With dry season and summers, AS. The region of this type of climate extends along the Coromandel coast. O tropical savanna type. Almost the entire peninsular region except for some coastal parts experiences this type of climate. O semi-arid steppe climate. BSHW. This climatic region includes the interior parts of the peninsular plateau and some parts of Gujarat, Rajasthan, Haryana, Punjab and Jammu and Kashmir. O hot desert type. BWHW. This type of climate is found only in the western part of Rajasthan. O monsoon type. With dry winters, CWG. Largely northern plains of India experience this type of climate. O cold humid winter type. With short summer, DFC. This climate is characterized by a short summer season. This region covers the northeastern parts of India. O polar type. This type of climate is experienced in Jammu and Kashmir and the neighboring mountain ranges. Monsoon and economic life of India. Agricultural dependence. Over 64% of India's population relies on agriculture for their livelihood, making the monsoon season critical. This seasonal rainfall pattern forms the backbone of the agricultural cycle. Diverse crops. India's climate, influenced by regional variations in monsoon rainfall, allows for a wide variety of crops to be cultivated throughout the country, excluding the Himalayas, where temperatures are consistently low. Rainfall challenges. Uneven monsoon rainfall distribution can lead to droughts or floods in certain areas each year. Irrigation and rainfall. Timely and well-distributed rainfall is crucial for agricultural success. Regions with limited irrigation infrastructure are particularly vulnerable to failed monsoons. Seasonal benefits. Winter rainfall from temperate cyclones in North India provides valuable moisture for rabi crops, crops sown in winter and harvested in spring. Climatic impact. India's diverse regional climates, shaped by the monsoon, are reflected in the country's varied food preferences, clothing styles, and housing types. Conclusion. The climate of India is undergoing significant changes, with rising temperatures, warming of the Indian Ocean, changes in rainfall patterns, increased drought frequency, sea level rise, and shifting cyclone patterns. These changes are largely attributed to human-induced factors, such as greenhouse gas emissions and aerosol forcing. It is crucial for India to continue monitoring and studying these changes to better understand their impacts and develop strategies for adaptation and mitigation to ensure the sustainability and resilience of the country's ecosystems, economy, and society in the face of climate change. Keywords: monsoon, jet streams, El Niño, southern oscillation, INSO, ITCZ, monsoon break, Indian Ocean dipole, I0D, La Niña, Köppen's climate classification, monsoon economy, climate change, shifting rainfall patterns, monsoonal floods, climate policy. Previous year question. 1. Why is the southwest monsoon called Purvaya Easterly in the Bhojpur region? How has this directional seasonal wind system influenced the cultural ethos of the region? 2023. 2. Why is the Indian Regional Navigational Satellite System, RNSS, needed? How does it help in navigation? 2018. 3. What characteristics can be assigned to monsoon climate that succeeds in feeding more than 50% of the one population residing in monsoon Asia? 2017. 4. In spite of adverse environmental impact, coal mining is still inevitable for development. Discuss 2017. 5. How far do you agree that the behavior of the Indian monsoon has been changing due to humanizing landscapes? Discuss. 2015. 6. The recent cyclone on the east coast of India was called Phelan. How are the tropical cyclones named across the world? 2013. 7. There is no formation of deltas by rivers of the Western Ghat. Why? 2013. 5. Population and migration in India. The World Health Organization, WHO, defines population as the complete set of inhabitants residing in a specific location, be it a country, territory, or geographic area. This definition can encompass the total population or be broken down by factors like sex and/or age group at a given moment. Population, fact-wise. Total population. As of early 2024, India's population is approximately 1.44 billion, making it the most populous country in the world, having overtaken China in mid-2023 population growth rate. Population of India in 2024 has grown at a rate of 0.81% from 2023. Sex ratio. As of the end of 2023, the sex ratio is around 939 females per 1,000 males. Population density. The population density of India in early 2024 is approximately 439 people per square kilometer. Rural-urban population. The rural population accounts for about 65%, while the urban population makes up about 35%. Significance of population studies. Economic powerhouse. They analyze the workforce, size, skills, demographics, to inform economic strategies and assess market potential based on consumer behavior and purchasing power. Social safety net. By identifying vulnerable populations, children, elderly, low income, these studies inform social welfare programs and resource allocation. Promoting well-being. Understanding fertility rates, contraceptive use, and reproductive health allows policymakers to develop strategies for family planning, reducing maternal infant mortality, and improving overall well-being. Policy foundations. Evidence-based policymaking relies on population studies to understand the needs, aspirations, and priorities of different demographic groups. Planning for the future. Population data on density, distribution, and growth patterns informs infrastructure planning, transportation, housing, utilities, and guides resource allocation across various administrative functions. Trends in population growth. Period of stagnant population, 1901–1921. High birth rates were offset by high death rates, resulting in slow or even negative population growth. The year 1921 marks a turning point, known as the demographic divide, due to this period's low growth. Period of steady growth, 1921–1951. Birth rates remained high, but mortality rates began to decline due to improvements in health, sanitation, and food distribution systems. This period's growth was driven by a decrease in deaths. Period of rapid high growth, 1951–1981. Mortality rates declined while birth rates remained high, leading to a period of rapid population growth. This explosion was fueled by continued high fertility. Period OF high growth W with definite signs OF slow ing down, 1981–2011. The highest ever growth rate of 22.2% was recorded in 1971 to 1981, followed by a gradual decline. The 2021 census showed a lower population increase compared to the previous decade, indicating success in family planning efforts and a shift towards smaller families. Factors responsible for high population growth in India. High fertility rates. Although declining slightly, India's average fertility rate remains above replacement levels, 2.0 children per woman. NFHS 5 data, 2.0 in 2019–21. Declining mortality rates. Improved healthcare and nutrition have led to a significant drop in mortality rates, especially for infants. Are at 35 per 1,000 live births according to NFHS 5. This translates to a longer lifespan for the population. Limited family planning access. Despite progress, only half of married women utilize modern contraceptives, hindering population control efforts. Poverty and education. Poverty and low education levels are linked to higher fertility rates, as seen in India's 27.5% population living below the poverty line, census 2011 data. Cultural and social influences. Cultural preferences for larger families and societal pressures play a role in shaping family size decisions. Implications of high population growth. Issues. Resource strain. Rising population creates pressure on vital resources like food, water, housing, and energy. Infrastructure overload. Existing infrastructure for transportation, healthcare, education, and sanitation becomes overburdened. Job market strain. High population growth can lead to unemployment and underemployment if job creation doesn't keep pace. Increased social needs. Growing populations demand more healthcare services and educational institutions. Environmental degradation. Environmental issues like deforestation, pollution, and resource depletion worsen. Potential benefits. Economic growth. A larger domestic market and increased consumer demand can stimulate economic growth. Demographic dividend. With proper investment in education and skills development, a young population can lead to increased productivity and economic growth. Challenge and considerations, social welfare. Providing adequate social services and welfare programs becomes more difficult with a larger population. Unplanned urbanization. Rapid urbanization can lead to strain on urban infrastructure and unplanned growth. Sustainable development. Long-term planning and policies are crucial to address challenges and promote sustainable development. Distribution of population and its density. Uneven distribution is an important aspect of India's population. High-density pockets have developed around urbanized, developed areas and plains regions. Backward areas and hilly, desert regions are sparsely populated. Reasons pertaining to unequal population distribution. Terrain. Flat plains are more conducive to agriculture, transportation networks, and industries, leading to higher population density. E.g., high density in Ganges Plain versus low density in Arunachal Pradesh. Climate. Areas with extreme temperatures or scarce rainfall tend to have lower population concentration. E.g., the Himalayas and their desert. India's population density mirrors its rainfall patterns. Mineral resources. Deposits of minerals attract investment, create jobs, especially in labor-intensive mining, and lead to higher population density. E.g., Chota Nagpur Plateau in Jharkhand. Fertile soil. Land with fertile soil supports productive agriculture and fosters settlements, as seen in the densely populated Ganges Plains with alluvial soil. Urbanization. Economic activity and job opportunities draw people to cities, resulting in higher population density compared to rural areas. E.g., major metros like Delhi, Mumbai, Kolkata, Bengaluru, and Chennai. Distribution. Southern versus northern India. The population growth and improvement in demographic parameters in India is directly proportional to the level of development in the state. Health and education facilities are the primary pillars which decide the population pyramid of any region. In India's southern developed states show improvement in population attributes compared to northern states. Southern states have entered into stage 4 of the demographic transition model, having low death and low birth rates leading to low growth rates. The total fertility rate of these states is below replacement level of 2.1. Population census in India. Definition. As outlined by the UN, a population census comprehensively collects, analyses, and disseminates demographic, economic, and social data about a nation's population at a specific point in time. Importance. Census data plays a crucial role in India's policy-making, development planning, and evaluation of government programs. It serves as a vital tool to understand the country's population dynamics and inform evidence-based decision-making. A historical endeavor, the first population census in India dates back to 1872 under Lord Mayo's rule, aiming to gather comprehensive data for British India. This marked the beginning of a decennial, every 10 years, census tradition that continues to this day. The second census took place in 1881 by Lord Ripon and continued to provide demographic insights to aid governance and policy-making every decade. Independent India's commitment. The first census after independence was conducted in 1951, marking the 7th in this ongoing series. This continuity underscores India's commitment to using census data for national progress. Working population. Labor force participation rate. For the period October-December 2023, the LFBR in urban areas rose to 49.9%, up from 48.2% in the same period of the previous year. The overall LFBR for individuals aged 15 years and above reached 54.6% for 2022-23. Female labor force participation rate. The female labor force participation rate saw a significant rise, reaching 37% in 2023 according to the Periodic Labor Force Survey 2022-23. Worker population ratio. The WPR for urban areas increased from 44.7% in October-December 2022 to 46.6% in October-December 2023. Unemployment rate. The overall unemployment rate in urban areas decreased to 6.5% for October-December 2023, down from 7.2% in the same quarter of the previous year. For rural areas, the unemployment rate was reported as 2.4% for 2022-23. Demographic dividend. Window of Opportunities. United Nations Population Fund, UNPF. Demographic dividend is defined as the economic growth potential that can result from a change in population age structure where shares of the working age, 15 to 64 years, population is greater than non-working age share. India would experience this phase between 2018 to 2055. This phase will be available at different times in different states. A country with both an increasing number of young people and declining fertility has the potential to reap a demographic dividend. Increase in labor force leads to increase in economic productivity - increase in GDP - increase in living standard and improvement in HDI score. Significance of demographic dividend DD. Economic boom. A larger workforce translates to higher productivity, driving economic growth and market expansion. Innovation hub. A youthful population brings fresh ideas and fosters entrepreneurship, leading to innovation and technological advancements. Social upliftment. The dividend provides a window to invest in education, healthcare, and social security systems, reducing poverty and empowering marginalized groups. Sustainable future. With a skilled workforce and a focus on human capital development, the demographic dividend empowers a nation for long-term, sustainable growth and global competitiveness. India's advantage. India is poised to benefit immensely from this phenomenon, with its large working-age population creating a vast consumer market and a strong labor force. Challenges. Social issues. Limited opportunities, lack of access to quality healthcare, education, and equal participation for women restricts human potential. Brain drain. Migration of skilled individuals weakens a country's human capital base. Economic concerns. Job market woes. Insufficient jobs and unequal income distribution create economic disparity. Underinvestment. Lack of investment in crucial sectors hinders growth and development. Political obstacles. Short-sighted policies. Inconsistent policies, lack of long-term planning, and limited political will to prioritize human development create roadblocks. Governance issues. Corruption and inefficient governance hinder effective implementation of reforms. Environmental threats. Climate change. Environmental issues like pollution, ecosystem degradation, and climate change impact livelihoods and well-being. Technological hurdles. Digital divide. Unequal access to technology and digital literacy widens social and economic gaps. Job displacement. Automation necessitates reskilling and upskilling the workforce to address job disruptions. Way forward. Investing in youth, prioritize quality education, vocational training, and digital literacy to prepare young people for the workforce. Jobs and enterprise. Promote entrepreneurship and support small businesses to create employment opportunities. Empowering women. Ensure equal access to education and employment for women to unlock their full potential. Social safety nets. Establish strong social protection systems to safeguard vulnerable populations. Global knowledge sharing. Collaborate with other countries to learn from best practices and facilitate technology transfer. By focusing on these key areas, India can effectively capitalize on its demographic dividend and create a brighter future for all. Digital divide. Definition. Digital divide refers to the deprivation of accessibility, affordability, and availability towards information and communications technologies across the demographics and regions. Accessibility. According to Oxfam India Inequality Report 2022, only 2.7% among the poorest 20% households in India have access to a computer and 8.9% to internet facilities. Digital literacy. Only 38% of households are digitally literate across India. Usage of the internet. Furthermore, internet usage is considerably lower in rural areas, with only 31% of the rural population utilizing the internet, in contrast to 67% of the urban population. Lack of access to marginalized. Merely 4% of students belonging to South Carolina and ST communities had access to both computers and the internet, highlighting significant disparities across caste groups. SPG goals. Access to ICT is essential to achieve Sustainable Development Goals, SDGs, for 2030 Human Development, United Nations Development Program, UNDP. Human development is the process of enlarging people's choices, said choices allowing them to lead a long and healthy life, to be educated, to enjoy a decent standard of living, as well as political freedom. Other guaranteed human rights and various ingredients of self-respect. The term development indicates qualitative change, which is value positive as against quantitative and value neutral change associated with the term growth. Fact-wise. Literacy rate in India. As of the latest report by the National Statistical Office, NSO, the literacy rate in India stands at 77.7% in 2023. Life expectancy. It is 70.19 years in 2022 and expected to reach 82.0 by 2100 according to UN estimates. Globally, it is 72.6 years. Human Development Index. India ranks 134 out of 191 countries in HDI 2024. Global Hunger Index. 111 out of 121 countries in 2023. Gender Gap Index. 127 out of 146 in the 2023 report. Significance of human development. Sustainable livelihoods. A key focus of human development is creating sustainable income-generating opportunities, particularly in agriculture and entrepreneurship, for a more secure future. Building a skilled nation. Human development fosters a skilled workforce, driving productivity, innovation, and India's competitive edge in the global market. Alignment with global goals. India's human development efforts contribute to achieving the UN's Sustainable Development Goals, SDGs, by tackling poverty, promoting education and gender equality, ensuring good health, and fostering sustainability. Health for all. Prioritizing quality healthcare services is a cornerstone of human development, ensuring improved health outcomes and accessibility for all. Empowering the vulnerable. Human development works towards uplifting marginalized groups, including women, children, rural communities, and tribal populations, by ensuring equal opportunities and participation. Various indices to measure human development. Human Development Index, HDI. It is the most commonly used index published by UNDP, which combines three basic dimensions of human development: life expectancy, education, and gross national income, GNI, per capita. Gender Gap Index published by World Economic Forum. This index measures gender disparities by incorporating gender-specific data into the HDI calculation. It takes into account the differences in life expectancy, education, and income between men and women. India ranks 135 among 146 countries. Gender Inequality Index (GH). The GII highlights gender-based inequalities in reproductive health, empowerment, and labor market participation. It considers indicators such as maternal mortality rate, adolescent birth rate, educational attainment, and representation in parliament. India ranks 122 among 190 countries in 2021. Inequality Adjusted Human Development Index, HDI. This index adjusts the HDI for inequality within a country. It is part of the HDR. It takes into account disparities in health, education, and income distribution among the population. Multidimensional Poverty Index, MPI. The MPI considers multiple dimensions of poverty, including health, education, and standard of living. It identifies individuals who experience simultaneous deprivations in various aspects of their lives. India ranks first in 2022. Key challenges for human development in India: poverty. Widespread poverty, 16.4% according to MPI, limits access to basic needs, healthcare, and education. Education, quality education, especially in rural and marginalized areas, remains a hurdle. Healthcare, limited access to quality healthcare, particularly in remote areas, 1.4 beds per 1,000 people, 1 doctor per 1,445 people, 1.7 nurses per 1,000 people. Gender inequality, persistent disparities in education, employment, and access to resources for women. Unemployment, high unemployment rate, 8.11% in April 2023, especially among youth. Digital divide, bridging the gap in access to technology for equitable participation. Population growth, managing a growing population, surpassed China at 1.4 billion, and its impact on resources and services. Way forward, empower individuals, promote skill development programs aligned with industry needs, and create opportunities for entrepreneurship to enhance employability and economic self-sufficiency. Strengthen social safety nets, implement robust social programs like healthcare coverage, income support, and nutrition initiatives to protect vulnerable populations and reduce inequality. Promote gender equality, empower women through education, job opportunities, and participation in decision-making to achieve inclusive and sustainable development. Ensure environmental sustainability, integrate green practices into development plans, focusing on renewable energy, sustainable agriculture, waste management, and conservation efforts. Drive innovation, encourage research and collaboration across academia, industry, and government to develop innovative solutions for a sustainable future. Initiatives by government to increase human development, skill development. Launched in 2015, the Skill India Mission and the National Skill Development Mission, (NSDM), aim to enhance the employability of the Indian workforce through skill training programs and vocational training. Clean Energy and Health. The Pradhan Mantri Ujjwala Yojana, PMEY 2016, provides clean cooking fuel, LPG, to low-income households, while the Swachh Bharat Abhiyan Clean India Mission 2014 promotes sanitation and hygiene by eradicating open defecation. The National Health Mission, NHM 2013, focuses on improving healthcare access and reducing maternal and child mortality rates. Rural Development and Livelihoods. The Mahatma Gandhi National Rural Employment Guarantee Act, MNREGA 2005, guarantees rural households 100 days of work per year, while the National Nutrition Mission, Poshan Abhiyan 2017, tackles malnutrition, particularly among women and children. China and India, contrasting population trends. Population growth. India's population surpassed China in April 2023, reaching approximately 1.426 billion people, according to the United Nations. In contrast, China's population peaked in 2022 and has started to decline. Projections indicate that China's population could fall below 1 billion by the end of the century due to low fertility rates and an aging population. Fertility rates. China's strict family planning policies, one-child policy, led to a sharp fertility decline, reaching 1.2 births per woman in 2022. India's fertility rate is declining more gradually, 2.0 births per woman in 2022, and is projected to peak around 2064 before decreasing. Impact of policies. China's population structure is shifting towards an older population due to its low fertility rates. India's federal structure resulted in varying impacts of family planning policies, leading to a more gradual population shift. Challenge and considerations. Both countries face challenges with aging populations and require planning for healthcare and social security. Sex ratio imbalances at birth due to son preference persist in both nations. Sustainable development. China and India's population size and growth significantly impact their ability to achieve the Sustainable Development Goals. Ensuring the well-being of their populations is vital for sustainable development and leaving no one behind. Migration. Migration refers to the movement of persons away from their place of usual residence, either across an international border or within a country. It includes a wide variety of movements, such as migration for work, education, family reunification, or humanitarian reasons. International Organization for Migration, IOM migrant, is a person who moves away from his or her place of usual residence, whether within a country or across an international border, temporarily or permanently, and for a variety of reasons. Broadly, migration can be divided as internal migration and external migration. Internal migration. Internal migration in India involves the movement of people within the country for various reasons such as job opportunities, education, and improved living conditions. It contributes to urbanization and economic growth while presenting challenges of housing and social integration. Fact-wise, number of internal migrants. The 2011 census recorded the number of internal migrants in India at 45.36 crores, which accounted for 37% of the country's population at that time. Annual net migrant flows. The annual net migrant flows in India amounted to approximately 1% of the working-age population. World Migration Report 2024. India is the origin of the largest number of international migrants in the world, nearly 18 million, with large diasporas in countries like the UAE, the US, and Saudi Arabia. According to the report, India has a slightly higher share of female immigrants than males. Countries with a significantly high proportion of male immigrants include India, Bangladesh, and Pakistan. Types of internal migration. Interstate migration. People move across state borders seeking better jobs, education, or living conditions. Rural-urban migration. Driven by aspirations for improved opportunities, people migrate from rural areas to cities for jobs, education, and healthcare. Urban-rural migration. This counterflow, though less common, involves individuals seeking a quieter life, returning after retirement, or pursuing specific rural professions. Seasonal migration. Temporary movement of workers, common in agriculture, follows seasonal demands for labor across regions. Educational migration. Students migrate to pursue higher education in colleges, universities, or institutes located in cities or other states. Reverse migration. Individuals or families return to their place of origin due to job loss, economic hardship, or personal reasons. Factors responsible for internal migration. Economic factors. Migration is often driven by the search for better employment opportunities, higher wages, and improved living standards. This includes a trend of rural-urban migration for diverse jobs and infrastructure. Social factors. Marriage, access to quality education, and existing social networks, family, community, are significant reasons for internal migration, especially for women seeking spousal residence or educational opportunities. Demographic factors. High population density, limited resources, and age, younger for education jobs, older for retirement healthcare, can influence migration patterns. Environmental factors. Natural disasters, environmental degradation, water scarcity, pollution, and climate change can push people to migrate for better living conditions and reduced vulnerability. Political factors. Political instability, conflicts, and government policies, infrastructure projects, development initiatives, can trigger migration for safety or economic opportunities in specific regions. Significance of internal migration. Economic push. Internal migration acts as a motor for economic growth, supplying labor to booming industries and urban centers, which stimulates production and development across the nation. Bridging the divide. It has the potential to lessen regional imbalances by promoting economic activity and improving living standards in less developed areas. Urban transformation. Internal migration is a key driver of urbanization, creating jobs and expanding access to essential services in urban areas. This fosters economic diversification and a higher quality of life. Upward mobility. Individuals can leverage internal migration to elevate their social and economic standing. It opens doors to better education, healthcare, and employment opportunities. Cross-pollination of ideas. The movement of people facilitates the exchange of skills, knowledge, and innovative ideas, enriching the local economy and social systems. Investing in people. By allowing individuals to access better education and skill development opportunities, internal migration enhances overall productivity and competitiveness, propelling economic growth. Challenges. Strained urban infrastructure. Rapid migration burdens urban infrastructure, leading to overcrowded slums with inadequate water, sanitation, and healthcare. Social disadvantage. Migrants often face social exclusion, discrimination, and limited access to essential services like education, healthcare, and social welfare schemes. Economic insecurity. Limited job opportunities, particularly in the informal sector, lead to low wages, exploitation, and precarious work conditions for migrants. Vulnerability to abuse. Migrant women and children are especially vulnerable to exploitation, trafficking, and forced labor due to a lack of legal protection, awareness, and social support. Social disruption. Migration can disrupt social networks, separate families, and negatively impact the emotional and psychological well-being of migrants and their loved ones. Limited health care. Migrants, especially those in informal settlements, often have limited access to essential healthcare services. Way forward. Integrated approach. Implement comprehensive urban planning that incorporates infrastructure development, basic services, and migration management strategies. Equality and inclusion. Ensure equal access to social welfare programs, education, and healthcare for migrants, while combating discrimination. Empowerment and opportunity. Enhance job prospects for migrants through livelihood creation, entrepreneurship support, and skill development programs. Safeguarding rights. Strengthen legal protections for migrants, address exploitation and trafficking, and establish support systems to address their needs. Social integration. Minimize family separation by facilitating reunification and provide social support networks to promote migrant well-being. Bridging the gap. Improve access to education through language support, simplified documentation processes, and migrant-friendly healthcare services. Key terms: out-migration and in-migration. Seasonal migration. Reverse migration. Brain drain. Social remittances. Internal migration. Pull and push factors. Demographic consequences. Migrant workers, etc. External migration. External migration refers to the movement of people from one country to another for the purpose of changing their place of residence. It involves crossing international borders and can be either voluntary or forced. External migration has a significant impact on both the sending and receiving countries. Types of external migration. Immigration from India to various parts of the world. This refers to the migration of Indian nationals to other countries for various reasons, such as employment opportunities, education, family reunification, or seeking better living conditions. Immigration of people from different countries to India. This involves individuals from different countries moving to India for various purposes, including employment, business, education, or joining family members who are already residing in the country. Refugee migration. This type of migration involves individuals who are forced to flee their home countries due to persecution, conflict, or other forms of violence. Factors responsible for external migration. Economic factors. People migrate seeking better jobs, higher wages, and improved living standards in other countries. Education. Students and professionals migrate for higher education, advanced degrees, or specialized training abroad. Safety and security. Political instability, conflict, persecution, and social unrest can push individuals to seek refuge externally. Environmental concerns. Natural disasters, climate change, and environmental degradation can force people to migrate for a safer and more sustainable life. Global opportunities. Globalization creates demand for labor in various sectors, attracting migrants to fill skill gaps. Seeking equality. Discrimination based on race, ethnicity, religion, or beliefs can drive migration for a more tolerant and inclusive society. Healthcare needs. People migrate for access to better healthcare services, specialized treatments, or advanced medical infrastructure unavailable at home. Improved quality of life. Migration can be driven by a desire for a higher standard of living, better infrastructure, and access to amenities like healthcare, education, and social services. Resource-based migration. Regions with significant natural resources may experience migration due to employment opportunities in mining, oil and gas, or agriculture. External migration. A double-edged sword. Positive impacts. Economic boost. Migration fuels economic growth in both sending and receiving countries. Remittances, investments, and skills transfer contribute to development. Cultural diversity. Migration fosters vibrant cultural exchange, enriching societies with diverse ideas, traditions, and experiences. Skilled workforce. Migrants gain valuable skills and knowledge abroad, which they can utilize back home, enhancing human capital. Innovation hubs. Migrants often bring fresh perspectives and entrepreneurial spirit, driving innovation and business growth in host countries. Filling the gap. External migration helps address labor shortages, providing a skilled and diverse workforce for host countries. Global network. Migration strengthens global connections, fostering collaboration across borders and benefiting trade, diplomacy, and international relations. Negative impacts. Brain drain. Migration of skilled professionals can deprive sending countries of talent and expertise, hindering development. Vulnerable populations. Migrants can face exploitation and discrimination, particularly those lacking legal protections and support systems. Remittance reliance. Overdependence on remittances creates economic vulnerability in sending countries, affecting long-term development. Social friction, cultural differences, resource competition, and job displacement fears can lead to social tensions between migrants and host communities. Lost investment. Sending countries lose the investment made in educating and training migrants who settle permanently abroad. Social disruption. Migration can lead to family separation, lack of social support systems, and challenges in maintaining cultural identity. Way forward. Facilitate integration. Implement strong policies to help migrants integrate into their new communities, housing, healthcare, education, etc. Improve migrant well-being. Provide adequate social security for migrants, tackling issues like poor housing, exploitative work, and lack of healthcare access. Develop targeted support programs like health insurance and housing projects. Protect migrant rights. Establish mechanisms guaranteeing basic rights for migrant workers in both their home and destination states. Invest in skills and opportunities. Partner with the private sector to enhance migrant skills and create employment and entrepreneurial possibilities. International cooperation. Collaborate with international partners to address shared migration challenges, protect migrant rights, and promote safe and orderly migration through information sharing and coordinated policies. External migration presents both opportunities and challenges. By acknowledging its inevitability, implementing effective integration policies, and fostering international cooperation, we can harness its benefits for inclusive and sustainable development. Conclusion. The dynamics of population and migration are pivotal in shaping the social, economic, and environmental landscapes both nationally and globally. Population trends, including growth, decline, and age structure, influence resource allocation and development strategies. Migration, driven by various push and pull factors, transforms both origin and destination regions, impacting cultural diversity, economic opportunities, and social structures. Understanding these patterns is crucial for policymakers to address challenges such as urbanization, labor market needs, and social integration. As the world continues to evolve, a comprehensive grasp of population and migration processes remains essential for fostering sustainable and inclusive development. Keywords: crude literacy rate, effective literacy rate, human productivity, demographic dividend, demographic disaster, demographic bulge, financial inclusion, inclusive growth, online fraud, upskilling, digital divide, digital inequality, 5C approach for financial literacy, content plus capacity plus community plus communication plus collaboration. Previous year question, Mains. 1. Why did human development fail to keep pace with economic development in India 2023-2? Discuss the main objectives of population education and point out the measures to achieve them in India in detail. 2021. 3. The COVID-19 pandemic accelerated class inequalities and poverty in India. Comment. 2024. Mention core strategies for the transformation of aspirational districts in India and explain the nature of convergence, collaboration, and competition for its success. 2018. 5. Critically examine whether growing population is the cause of poverty or poverty is the main cause of population increase in India. 2015. 6. Discuss the changes in the trends of labor migration within and outside India in the last 4 decades. 2015. THICS and ESA-SH Course 20. June 24, 2024. Atul Garg Sir Ethics. Price: M5000, offline, 710000, online, essay. Copy. Ethics discussion in question-answer format. Coverage of 150+ ethics and 50+ essay questions. Theme-wise essay coverage. 2 ethics and 2 essay full-length tests with evaluation. Evaluation by faculty. 1 TO1 sessions with faculty for personal doubts. 7. Special focus on time management, tackling philosophical essays, case studies 6 human settlements and associated issues. In geography, a settlement, locality or populated place, is a community in which people live. The complexity of a settlement can range from a small number of dwellings grouped together to the largest of cities with surrounding urbanized areas. Settlements may include hamlets, villages, towns, and cities. Settlements can broadly be divided into TWO types: rural and urban. Classification of settlements. Urban settlement. The majority of people living in cities work in non-primary industries like manufacturing and services. The population density in urban areas is typically high, more than 400 persons per square km. Declared an urban settlement by the government. The following standards are used in India to categorize urban settlements. According to the 2011 census, there should be more than 5,000 people living there. At least 75% of working men should be employed in non-primary industries. The town area committee should have informed the urban area, which should have a municipality, corporation, or canton board. Urbanization in India. Definition. The population transfer from rural to urban regions. The resulting decline in the number of people living in rural areas and the methods by which societies adjust to this transition are all referred to as urbanization. Status of urbanization in India. Urbanization in India as mainly a post-independence phenomenon due to the adoption of a mixed system of economy by the country, which gave rise to the development of the private sector. The urban population of India attained a value of 475 million people in 2021. In 2021, India's urbanization rate was 1.34%. In 2021, India's urbanization rate climbed 1.5% year-over-year. The indicator climbed by 19.6% from 2010 to 2021. Between 2010 and 2021, India's urbanization rate was at its highest in 2021 and at its lowest in 2010. Reason for increasing urbanization: economic opportunities. Cities often offer more job opportunities and higher wages compared to rural areas. 68% of the world population is projected to live in urban areas by 2050, says UN. By 2050, 68% of the world's population, up from 55% today, is anticipated to reside in cities. According to projections, by 2050, there could be 2.5 billion more people living in urban areas worldwide due to urbanization, which is the gradual movement of people from rural to urban areas. Nearly 90% of this population growth would occur in Asia and Africa. Access to services and amenities. Urban areas provide better access to essential services such as healthcare, education, and transportation. The availability of amenities such as entertainment, shopping, and cultural activities also attracts people to cities. Improved infrastructure. Cities typically have better infrastructure, including roads, public transport, electricity, and internet connectivity. Rural to urban migration. People migrate from rural areas to cities in search of a better quality of life and opportunities. Population growth and urban sprawl. Natural population growth contributes to the expansion of urban areas. As cities grow, they expand outward, incorporating surrounding areas into the urban fabric, a phenomenon known as urban sprawl. Problems: India's urbanization, overcrowding, and housing shortages. Rapid urbanization leads to overcrowded cities with insufficient housing, resulting in the proliferation of slums and informal settlements. Many urban residents face inadequate living conditions, lacking access to basic amenities like clean water and sanitation. Infrastructure strain. Urban infrastructure, including roads, public transport, sewage, and electricity, often struggles to keep pace with the growing population. This results in traffic congestion, frequent power outages, and inadequate waste management systems. Environmental degradation. Increased urbanization leads to air and water pollution, loss of green spaces, and higher levels of solid waste. Social inequality. Many urban poor lack access to quality education, healthcare, and employment opportunities, perpetuating cycles of poverty. A resource scarcity. Cities often struggle with water shortages, over-extraction of groundwater, and competition for land, affecting both urban and rural populations. Problems caused by the pandemic. The COVID-19 pandemic has worsened the plight of the urban poor and slum residents. Slum dwellers' capacity to earn a living was seriously harmed by the sudden imposition of a complete COVID shutdown. The faulty pattern of urbanization. Due to overpopulation and better pull factors, the urban city gives rise to new areas called suburbs. But due to unplanned urbanization and suburbanization, there are pockets of slums developed in between them. E.G. Sanjay Colony is a slum in South Delhi situated in the Okhla industrial area. Social cultural implications. Gated communities. The rise of gated communities manifest into cosmopolitan areas surrounded by lower middle class, poor ghetto slums. This creates a huge socio-cultural divide between these areas. Mental health. Huge mental barrier between the different habitations of slums and so-called civil habitations. There is a feeling of inferiority complex in slum habitats, thus inhibiting their growth as proper humans. Social immobility. Lack of opportunity leads to the informalization of ghettos in terms of employment, which results in a lack of upward social mobility. Education and public health. They have to rely on public schools and hospitals which majorly are in an archaic state. Whereas others have good convents and private hospitals, 247 with world-class facilities. Water supply and sewerage problem. Slum dwellers have to rely on tankers, which is also not regular, and the issue of tanker mafias exists. In spite of Swachh Bharat Abhiyan, basic sewerage issue pertains. Urban crime. Due to lack of basic amenities, opportunities, alienation, and formalization of employment, the youth are more prone to crime exposure. Measure suggestions. In situ slum rehabilitation programs. 2013, it will remove the fear of removal from their sites, e.g. PM Awas Yojana, Jahan Juggi Wahin Mahan, scheme of Delhi government, etc. Amrut. 2015, assuring that every family has access to a tap with a guaranteed supply of water and a sewer connection is the goal of the Atal mission for urban rejuvenation and urban transformation. Pradhan Urban Mantri Awas Yojana, PMAYU, 2015, by offering a rebate on the interest rate of a home loan during repayment via EMI. It makes home loans affordable for the urban poor. Smart City Mission has the potential to mitigate poverty in the cities as it aims to target basic services for the people in a holistic manner. Gender-sensitive infrastructure should be a priority as it has a positive role in health, education, income, and housing in slum families. Had this been in place, slums like Dharavi would not be in the news for being a COVID-19 hotspot. Urban Water Body Information System, OWISE, provide real-time information on the water spread area for all the water bodies in the country using automated feature extraction algorithms. Human settlements and water pollution. With rapid urbanization, the country is facing a massive waste management challenge. Over 377 million urban people live in 7,935 towns and cities and generate 62 million tons of municipal solid waste per annum. Lakes' water bodies are battling. Waste disposal, deposition of pollutants, and continuous disposal of waste have severely depleted the lake's water quality. The National Green Tribunal, NGT, expressed dissatisfaction over the response of Central Groundwater Authorities, CGWA, to the widespread issue of toxic arsenic and fluoride in groundwater across India. Groundwater contamination due to arsenic is prevalent in 230 districts across 25 states of India, while that caused due to fluoride is prevalent in 469 districts across 27 states. Dismal situation of urban water bodies in India. In the National Capital Territory of Delhi alone, due to haphazard urbanization, as many as 232 water bodies are already off the recovery list. Bangalore lost at least 66 water bodies between 1973 and 2007. Chennai has fared the worst in conserving water bodies. All that remains in the name of a wetland ecosystem in the city is the Palakarani Marsh, which has shrunk to a tenth of its size since 1965. Significance of urban water bodies. Causes of urban water bodies. Pollution. Reduce urban heat island effect. Water in water bodies will absorb more heat before the surrounding begins to get warmer and subsequently evaporates. Furthermore, water bodies also reflect solar radiation, giving a moderating effect. Water bodies stabilize the microclimate parameters, such as relative humidity, temperature, and air movements, etc. Water bodies regulate the diurnal variation of air temperature, making it ambient. Carbon sequestration. Instead of releasing carbon dioxide into the atmosphere, plant communities and soils retain carbon. Employment generation, through waterways, fishing, etc. Daily water requirement. Due to the high per capita consumption of water, the significance of urban water bodies is huge. Religious purpose. Water has historically been worshipped in Indian culture. Rapid unplanned urbanization. Rapid urbanization in India during the recent decades has given rise to several environmental problems such as water supply, wastewater generation and its collection, treatment, and disposal. Discharge of untreated sewage. Nearly 80% of the water supplied for domestic use passes out as wastewater. In most cases, this wastewater is let out untreated and causes large-scale pollution of the surface water. Limitations of state authorities. The State Disaster Mitigation Plan has a limited scope when it comes to intervening in matters of unplanned urban infrastructure, including drainage and urban sewage systems. Religious and social practices. Carcasses of cattle and other animals are disposed of in rivers or water bodies. Dead bodies are cremated on the water bodies. Partially burnt bodies are also flung into the water bodies. Way forward to improve the conditions of urban water bodies, improving the capacity of urban drainage systems, so it would manage waste discharge and municipal waste effectively. Restricting encroachment and fragmentation of urban water bodies. Ensuring planned urbanization so that it takes the delineation and protection of catchment areas, drainage channels, and areas of lakes, ponds, etc. Stakeholder participation and capacity building for better management of urban water bodies. Proper monitoring of industrial waste through enforcing the Environment Protection Act, 1986. Water bodies act as detoxifiers to purify the environment and as a sponge and sluice to protect the urban ecosystem from hazards posed by numerous anthropogenic and geomorphological factors. Human settlements and air pollution. Along with urbanization comes industrialization, vehicular pollution, and the burning of fossil fuel. Noxious industrial fumes or dust from various industries such as VPT, or for that matter vehicular pollution. The geographical location of the city is acting as a catalyst for the rapid growth of air pollutants. Impact of air pollution. Urban heat island effect. Rapid urbanization has led to the India has been identified as the world's third most polluted country, as per the World Air Quality Report 2023 by IQAir. 9 out of the top 10 most polluted cities in the world are from India. Growth of concrete jungle and blacktop roads. Almost 85% of the urban area is covered with concrete structures and metal roads. This is trapping the solar energy and results in the creation of the urban heat island, UPSC phenomenon. Health issues. Long-term exposure to outdoor and household air pollution contributed to over 1.67 million annual deaths from stroke, heart attack, diabetes, lung cancer, chronic lung diseases, and neonatal diseases in India in 2019, according to the State of Global Air 2020. LITVEPORATIONSCAUSETIESTOREMAINWASIDE. Mental health. Chronic exposure to polluted environments can contribute to stress and anxiety. Agricultural impact. Air pollution, particularly ground-level ozone, negatively affects crop yields, leading to economic losses in the agricultural sector. Regarding biodiversity, air pollution emissions' detrimental impacts may have an effect on the diversity of life on Earth. Because of air pollution, SO2 and NOx emissions in the atmosphere undergo oxidation and moist deposition, which results in acid rain. In turn, this means that acid rain may harm our biodiversity. On buildings and materials, emissions of SOx and NOx can damage plant and animal life, as well as material surfaces, and potentially cause structural damages. One such illustration is India's white marble Taj Mahal, which is turning yellow as a result of acid rain and SOx emissions from industry. Causes of air pollution: burning of urban waste, diesel soot, vehicular exhaust, road and construction dust, and power generation. Unplanned urbanization. Haphazard growth of urban areas has led to the proliferation of slums, and poor public transport has increased the burden of personal vehicles on the road. Landfills used for waste management also release pollutants in the air. Vehicle emissions. Exhaust from cars, trucks, and buses releases pollutants like nitrogen oxides, NOx, carbon monoxide, CO, and particulate matter, PM. Agricultural activities. Use of pesticides, fertilizers, and burning of crop residues release harmful chemicals and particulates into the air. Poor governance. The issue of environment and pollution is still to get the policy priority it deserves. Fireworks. Firecrackers were nevertheless used extensively during Diwali despite the ban. Although it might not be the main reason for air pollution, it undoubtedly helps it to build up. Steps to combat air pollution. National Clean Air Program, NCAP. It was intended to build and strengthen the institutional capacity to monitor air quality across India. Prana Portal. It was introduced in non-attainment cities, NAC, or cities that could not satisfy the ambient air quality standards under NCAP, as part of the National Clean Air Program, NCAP. Flue gas desulfurization. Industries in urban areas must comply with desulfurization norms. BS6 vehicle. A quantum jump from BS4 to BS6 and subsequent electric vehicles would be a step in the right direction. Vehicle scrapping policy. It would arrest the increasing pollution from old vehicles in an economically sustainable way. National ambient air quality standards. Notification of industry-specific emission and effluent limits, as well as national ambient air quality standards. Climate change impact on coastal Indian cities. Sea level rise. 27 million people in Mumbai may be affected by climate change by 2035, with a high risk of flooding and sea level rise. Saltwater intrusion. Rising sea levels also contribute to saltwater intrusion into coastal aquifers, affecting the quality and availability of freshwater resources. This intrusion threatens groundwater supplies, which many coastal cities rely on for drinking water and agricultural purposes. Contamination of freshwater sources can lead to health risks and exacerbate water scarcity issues in already densely populated areas. Erosion and coastal degradation. Climate change accelerates coastal erosion, posing a threat to the stability of shoreline areas. In Indian cities like Goa, erosion is already a significant concern, impacting beaches, infrastructure, and ecosystems. As sea levels rise and storms become more frequent and severe, erosion rates are expected to increase, jeopardizing coastal habitats, tourist attractions, and coastal communities' livelihoods. Economic vulnerability. Coastal cities are often economic hubs with key industries such as shipping, fishing, and tourism. Climate change impacts like sea level rise, extreme weather events, and coastal erosion can disrupt these industries, leading to economic losses and affecting livelihoods. Additionally, the cost of adaptation and mitigation measures to protect coastal infrastructure and communities from climate risks can strain local and national budgets, further exacerbating economic vulnerabilities. Climate Smart Cities Assessment and ITS Impact. To inculcate climate-sensitive approach to urban planning and development, the Climate Smart Cities Assessment Framework for 100 Smart Cities was launched by the Ministry of Housing and Urban Affairs. The framework has 30 diverse indicators across 5 sectors that monitor and guide the cities to help them to assess their own preparedness to tackle the issue of climate change as well as degrading air quality. Mandate: energy and green buildings. It aims to achieve energy-efficient street lighting in the city, green building adoption and promotion. With this, energy demand of cities is met in a sustainable way so that pollution is minimized. Mobility and air quality. Adequate availability of public transport would be ensured along with this clean technologies shared vehicles promoted so that minimum vehicular pollution occurs. Thus phenomena like temperature anomaly, urban heat islands, and air pollution are tackled in urban areas. Waste management. It aims to manage landfills and dump sites on scientific lines so that a minimum amount of toxic gases and polluting gases get discharged into the atmosphere. Further dry waste is recovered and recycled, leading to waste minimization. Urban planning, green cover, and biodiversity. Increase in green cover promotes biodiversity and maintains ecological balance. It will make an effective heat sink in cities, and further diurnal temperature patterns would not get adversely affected. Apart from this, it will make cities disaster resilient. Water resource management. Effective water resources management and adoption of an energy-efficient wastewater management system ensures the availability of potable water and reduces the pollution of water. Thus, it will support local water bodies and flora and fauna there. Further floodwater stagnation risk would be minimized through efficient drainage patterns. Sustainable Cities India Program. The National Institute of Urban Affairs, NIUA, and the World Economic Forum have signed a Memorandum of Understanding, MOU, to work together on a jointly developed Sustainable Cities India program. Objective: Sustainable Cities India aims to make it possible for cities to decarbonize in a methodical and sustainable fashion that will lower emissions and produce resilient and equitable urban ecosystems. This program works hand in hand with India's pledge at COP26 to achieve net zero emissions by 2070. Components. In 5 to 7 Indian cities over the course of 2 years, the Forum and NIUA will adapt the Forum's City Sprint process and toolbox of solutions for decarbonization. City Sprint process, a series of workshops including representatives from business, government, and civil society, is part of the City Sprint initiative, which aims to facilitate decarbonization, particularly through clean electrification and circularity. Toolbox solution. It offers a digital platform with more than 200 examples of best practices for clean electrification, efficiency, and smart infrastructure in buildings, energy systems, and mobility for more than 110 towns worldwide. Conclusion. At present, India is seeing a high pace of urbanization, but its unplanned nature and deregulated development created socio-economic implications. The situation further worsened due to its interwoven relation with climate change. The Climate Smart Cities Assessment Framework breaks this intricate bonding, and through this Sustainable Development Goal 11, sustainable cities and communities can be achieved. Way ahead for sustainable and inclusive human settlement, inclusive cities. In cities, the poor and lower income groups must be integrated into the mainstream. The planning should take into account the needs of the marginalized groups, such as housing, health, water, transportation, and other services at reasonable pricing. Affordable housing. It is a significant concern for low-income populations, and in the absence of a feasible model that meets their needs, India can tackle the problem by enacting a series of regulations and incentives that would bridge the price affordability gap. Delivery of services. The major job of ULBs should be to manage the water supply and sewerage system. They should be in charge of water supply and distribution in their geographical jurisdictions, whether from their own sources or through collaboration with parastatals and other service providers. Integration. To establish sustainable cities or metropolitan regions and integrate multiple urban development and related programs at the municipal, state, and national levels. India must make urban planning a central, recognized function by investing in talented people, a rigorous fact foundation, and innovative urban design. In recent years, the government has launched a number of initiatives targeted at urban planning and administration, including Smart City, Amrut, Digital India, Swachh Bharat, and Hriday. For these programs to succeed, they need a solid foundation of effective planning and management. Conclusion. Human settlements are complex and dynamic systems influenced by a myriad of social, economic, and environmental factors. Understanding the distribution, structure, and functions of settlements helps in addressing urban and rural challenges, such as housing shortages, infrastructure deficits, and environmental degradation. Sustainable development practices and effective urban planning are crucial to mitigate these issues and enhance the quality of life. As populations continue to grow and migrate, adaptive strategies must be implemented to ensure that human settlements remain resilient and inclusive, fostering harmonious coexistence with the natural environment. Keywords: inclusive cities, resource management, gender-sensitive, resource scarcity, social immobility, toolbox solution, financial mismanagement. Land use pattern and its changing trend. India's land use pattern is characterized by a diverse range of sectors. Agriculture is a dominant sector, with land primarily used for growing food crops like rice, wheat, and pulses, as well as cash crops such as cotton, sugarcane, and oilseeds. Forests cover a significant portion of the country, serving as habitats for wildlife, sources of timber, and contributors to biodiversity conservation. Urban areas are expanding rapidly, resulting in the conversion of agricultural and rural land into residential, commercial, and industrial zones. Industrial land is dedicated to manufacturing and industrial activities. These land use sectors interact with each other, and the dynamic nature of India's land use reflects the country's unique geographical and socio-economic characteristics. SDG 15. Life on land. By 2030, combat desertification, restore degraded land and soil, including land affected by desertification, drought, and floods, and strive to achieve a land degradation-neutral world. According to the Agricultural Census of 2015-16, the total reported area of operational holdings in the country was around 146 million hectares, with a net sown area of approximately 140.05 million hectares. According to the India State of Forest Report 2021, the total forest cover in the country was estimated to be around 789 square kilometers, which accounts for approximately 21.71% of the total geographical area of India. According to the wasteland mapping exercise conducted by the Indian Space Research Organization, ISRO, the total wasteland area in India was estimated to be around 55.76 million hectares. Land use planning encompasses the development of policies to effectively regulate the usage of land. This is to be done for maximizing the use of the available resources and achieving more desirable outcomes in both social and environmental areas. Importance of land use planning. Conservation of natural resources. It contributes to the conservation of natural resources, such as forests, wetlands, and water bodies. For example, land use plans may include provisions for the protection and restoration of riparian zones to safeguard water quality and maintain ecosystem services. Sustainable development. It promotes sustainable development by ensuring the efficient use of land resources and balancing economic, social, and environmental considerations. For example, it can facilitate the preservation of agricultural lands for food production, protect natural habitats and ecosystems, and guide the location of infrastructure to minimize environmental impacts. Climate change adaptation. It plays a vital role in climate change adaptation by considering the vulnerability of different areas to climate risks. For example, land use plans may incorporate measures such as green infrastructure or wetland restoration to enhance resilience and reduce the impacts of extreme weather events. Economic development and investment. Land use planning provides a framework for attracting investments and promoting economic development. For example, land use plans may designate specific areas as industrial parks to encourage the establishment of manufacturing facilities and create employment opportunities. Disaster risk reduction. It plays a crucial role in mitigating and managing the risks associated with natural disasters. For instance, it can designate floodplains as non-buildable areas, ensure proper drainage systems, and restrict development in high-risk zones prone to earthquakes or landslides. Impact of land use change. Increases pressure on land. Human influence on land and natural resources is accelerating due to population growth and increasing food requirements. Increasing agricultural intensity puts pressure on land resources and the overall environment. Water cycle disruption. Changes in land use alter natural water infiltration and runoff patterns, affecting groundwater recharge and increasing the risk of floods and droughts. Developmental displacement. An estimated 50 million people have been displaced due to development projects in India over 50 years. Displacement includes projects such as dams, mines, industrial development, and the creation of wildlife sanctuaries and national parks. Loss of livelihood. Land use change leads to the loss of access to agricultural lands, forest areas, and grazing lands, impacting livelihoods and quality of life. Examples include the Parsa East Keep Pisan coal mine in Chhattisgarh, which involves a land use change of 2,711.034 hectares and affects the livelihoods of tribal and traditional forest dwellers. Climate change. Deforestation and land conversion for agriculture and urban development release significant amounts of carbon dioxide, CO2, and other greenhouse gases. Causes environmental degradation and pollution. Land use change results in a decline in agricultural productivity, groundwater contamination, and other environmental impacts. These effects have long-lasting consequences on health, the economy, and social well-being. Changing trends in land use pattern in India. Land use in a region, to a large extent, is influenced by the nature of economic activities carried out in that region. However, while economic activities change over time, land, like many other natural resources, is fixed in terms of its area. There are three types of changes that an economy undergoes, which affect land use. 1. The size of the economy grows over time as a result of increasing population, change in income levels, available technology, and associated factors. As a result, the pressure on land will increase with time and marginal lands would come under use. 2. Composition of economy. The secondary and the tertiary sectors usually grow much faster than the primary sector, specifically the agricultural sector. 3. Dependency of a particular sector like agriculture. Though the contribution of agricultural activities reduces over time, the pressure on land for agricultural activities does not decline. Land use classification. Land can be classified on the basis of ownership as private land and community land. 1. Private land is owned by individuals. 2. Community land is owned by the community for common uses like a collection of fodder, fruits, nuts, or medicinal herbs. These community lands are also called common property resources. Different types of land use. Classification: forests. This includes all lands classed as forest under any legal enactment dealing with forests or administered as forests, whether state-owned or private, and whether wooded or maintained as potential forest land. The area of crops raised in the forest and grazing lands or areas open for grazing within the forest should remain included under the forest area. Land under miscellaneous tree crops, etc. This includes all cultivable land which is not included in net area sown, but is put to some agricultural uses. Lands under casuarina trees, thatching grasses, bamboo bushes, and other growths for fuel, etc., which are not included under orchards, should be classed under this category. Net area sown. This represents the total area sown with crops and orchards. Area sown more than once in the same year is counted only once. How does changes in land use pattern occur and what is its impact? Causes impact. Urbanization, conversion of agricultural or natural land into residential, commercial, and industrial areas. Agricultural expansion, driven by the need to increase food production to meet the demands of a growing population. Biodiversity loss, fragmentation of habitats makes it difficult for species to survive and reproduce. Soil degradation, degraded soils impact agricultural productivity and increase the risk of desertification. Water cycle disruption, urbanization and deforestation reduce the land's ability to retain and filter water. Industrialization requires large tracts of land and often leads to the displacement of existing land uses. Infrastructure development, construction of roads, highways, railways, and other infrastructure to support urbanization and economic activities. Deforestation, often driven by economic incentives and the need for land for agriculture and development. Climate change, land use changes exacerbate climate change impacts such as temperature rise and extreme weather events. Reduced agricultural productivity, unsustainable practices degrade soil health, reducing crop yields and threatening food security. Link between land use change and climate change, impact of land use change on GHG emissions. Large-scale land use changes, such as deforestation, urbanization, or changes in cropping patterns, directly impact overall greenhouse gas emissions. Shift in land use and zoonoses. The UN Convention to Combat Desertification, UNCCD, has advised reversing land use changes to prevent zoonotic diseases like COVID-19. By preserving natural ecosystems and maintaining a balance between human activities and wildlife habitats, the risk of zoonotic disease transmission can be reduced. Land as a source and sink of carbon. Land acts as both a source and a sink of carbon in the global carbon cycle. Conversely, soil, trees, plantations, and forests absorb carbon dioxide through photosynthesis, acting as carbon sinks and reducing atmospheric carbon dioxide content. Emission of GHGs. Greenhouse gases, GHGs, such as carbon dioxide, CO2, methane, CH4, and nitrous oxide, and 20, are released or absorbed through land use activities. Activities like agriculture and cattle rearing are major sources of methane and nitrous oxide emissions, which are potent greenhouse gases. Feedback loops and climate feedbacks. Land use change can initiate feedback loops that amplify climate change. For example, as temperatures rise due to greenhouse gas emissions, it can lead to changes in land cover and vegetation patterns, such as increased forest fires, dieback of forests, or shifts in vegetation zones. These changes further release carbon into the atmosphere, exacerbating climate change. IPCC's Special Report on Land and Climate Change, Land Use a Tool Against Global Warming Sustainable Practices, Implementing Climate-Smart Agricultural Practices, Improving Cropland and Livestock Management, Adopting Agroforestry, and Increasing Soil Organic Carbon Content contribute to ecosystem conservation and land restoration. Creation of green walls and dams, afforestation, tree planting, and ecosystem restoration programs can create windbreaks that reduce dust and sandstorms, protecting land from degradation. Prevention and reversal. Avoiding, reducing, and reversing desertification improves soil fertility, increases carbon storage in soils and biomass, and enhances agricultural productivity and food security. Grassland development. Examples like the Bani region in Gujarat show that land restoration can be achieved by developing grasslands, supporting pastoral activities, and promoting indigenous techniques in degraded areas. Biodiversity protection. Land is crucial for biodiversity, emphasizing the need to urgently address land use change to preserve diverse ecosystems. Responsible land governance. Implementing responsible land governance creates an enabling environment for ecosystem restoration, biodiversity protection, land use-based adaptation, and improving small-scale farmers' livelihoods. Wasteland management. Proper management of wastelands, including control of mining activities and appropriate discharge and disposal of industrial effluents and waste after treatment, Reduces land and water degradation in industrial and suburban areas. Why ahead? Sustainable land management. Promote sustainable land management practices that aim to conserve and restore ecosystems, minimize land degradation, and enhance soil health. Implement measures such as agroforestry, conservation agriculture, and precision farming techniques to reduce the environmental footprint of agricultural activities. Land use planning and regulation. Implement effective land use zoning, land use change assessment, and environmental impact assessment processes to guide land development decisions. International cooperation. Support initiatives such as the United Nations Framework Convention on Climate Change, UNFCCC, the United Nations Convention to Combat Desertification, UNCCD, and the Convention on Biological Diversity, CBD, to coordinate efforts and share best practices. Desertification. According to the UNCCD, desertification is defined as land degradation in arid, semi-arid and dry subhumid areas resulting from various factors, including climatic variations and human activities. It refers to the process by which fertile land becomes degraded, leading to a decline in productivity and the loss of vegetation cover. Desertification can result from factors such as drought, deforestation, overgrazing, improper agricultural practices, and climate change, among others. Causes. Climate change. Changes in climate patterns, including prolonged droughts and reduced rainfall, can accelerate the process of desertification by drying out the soil and vegetation. Deforestation. The removal of trees and vegetation cover, often for agricultural expansion, logging, or fuelwood collection, contributes to soil erosion, reduces moisture retention, and increases the vulnerability of land to desertification. Overgrazing. Excessive grazing of livestock beyond the carrying capacity of the land can lead to the degradation of vegetation, soil compaction, and erosion, making the land more susceptible to desertification. Unsustainable agricultural practices. Poor land management practices, such as inappropriate irrigation techniques, excessive use of chemical fertilizers and pesticides, monocropping, and improper soil conservation measures, can degrade the soil and contribute to desertification. Land mismanagement. Improper land use planning, inadequate land tenure systems, lack of land use regulations, and uncontrolled land development can all contribute to land degradation and desertification. Mining and extractive industries. Unregulated mining activities, especially in arid and semi-arid regions, can lead to soil disturbance, contamination, and loss of vegetation, exacerbating desertification. Poverty and population pressure. Poverty, population growth, and the resulting demand for resources can lead to unsustainable practices such as overexploitation of natural resources, encroachment into marginal lands, and conversion of forests and grasslands into agriculture or settlements. Achieving the dual objectives of safeguarding both human well-being and the environment will be unattainable unless developed nations assume the primary responsibility for significantly reducing emissions. This is because their historical and ongoing contribution to global warming is the most substantial. Additionally, landscape restoration goes beyond mere tree planting. It necessitates recognizing the value of indigenous and local wisdom in conjunction with scientific and technological advancements, while also integrating the needs of local communities. India and UNCCD. Established in 1994, the United Nations Convention to Combat Desertification, UNCCD, is a legally binding international agreement that uniquely connects the environment and development to promote sustainable land management. It is the only convention that originated from a direct recommendation of the Rio Conference's Agenda 21. India ratified the Convention to Combat Desertification in December 1996. The nodal ministry for the convention in India is the Ministry of Environment, Forest, and Climate Change. India faces a huge desertification problem. A 2016 ISR report stated that 29% of the land in India was degraded. Keywords: efficient land use change and forestry, LULUCF. Land degradation neutrality, LDN. Regulate usage of land. Modern land use goals. Optimize use of scarce land. Sustainable land management. Life on land. Displacement and dispossession. Diversion of forest land. Community land. Culturable wasteland. Deforestation and land erosion and degradation. Unregulated human interference. Conclusion: the analysis of land use patterns and their evolving trends highlights the dynamic nature of human-environment interactions. Rapid urbanization, agricultural expansion, and industrial development are primary drivers of change, often leading to significant environmental impacts. Understanding these patterns is crucial for sustainable land management and planning. Effective policies and innovative approaches are needed to balance development with conservation, ensuring that land use changes meet the needs of growing populations while preserving ecological integrity. The ongoing study of land use trends will be essential in adapting to future challenges and fostering resilient, sustainable communities. Previous your question. The effective management of land and water resources will drastically reduce human miseries. Explain 2018. Mention the advantages of the cultivation of pulse, because of which the year 2016 was declared the International Year of Pulses by the United Nations. 2017. The states of Jammu and Kashmir, Himachal Pradesh, and Uttarakhand reached the limits of their ecological carrying capacity due to tourism. Critically evaluate. 2015. Interlinking of current and static topics. Latest data and facts enrichment. Set of 14 booklets. Concise M-oriented notes. Integrated PYQs. Keyword focus for quality answers. Carol Bagh Mukherjee Nagar OQQQQQ. M. Lucknow Patna. 0992-061-3613 OnlyIAS. Com8 location of primary, secondary, and tertiary sector according to Section 2(j) of the Industrial Disputes Act of 1947. Industry is defined as any business, trade, undertaking, manufacture, or calling of employers, as well as any calling, service, employment, handicraft, or industrial profession or hobby of workers. The industrial sector of the economy is concerned with the manufacture of final products, vehicles, processed foods, and intermediate items, iron, steel, machinery. Manufacturing processes are the core part of the industrial sector, transforming the natural material endowment primary commodities of utility through processing, assembling, and repairing. Sector-wise GDP in India, 2023-24. Public administration, defense, and other services, 12.77%. Agriculture, forestry, and fishing, 14.45%. Trade, hotels, transport, communication, and services related to broadcasting, 18.68%. Financial, real estate, and SERVs, 23.28%. Mining and quarrying, 2.15%. Manufacturing, 17.17%. Electricity, gas, water supply, and other utility services, 236%. Construction, 9.13%. Base year 2011 to 2012. At 2011-12 prices, the agriculture and allied, industry, and services sector's composition is 14.45%, 30.82%, and 54.73%, respectively. Primary activities. Primary sector refers to that sector of the economy which uses natural resources to produce goods. The primary sector dominates in underdeveloped countries. Facts. The Indian economy's primary sector accounts for 18.2% of the GDP. About 48.9% of the workforce is employed in the primary sector. Overall status in India, according to the 20th Livestock Census. India is the world's highest livestock owner at about 535.78 million, first in the total buffalo population in the world, 109.85 million buffaloes, second in the population of goats, 148.88 million goats, second largest poultry market in the world, the second largest producer of fish, and also the second largest aquaculture nation in the world, third in the population of sheep, 74.26 million, fifth in the population of ducks and chickens, 851.81 million, 10th in camel population in the world, 2.5 lakhs. Compared to an average of 14% for all rural households, livestock makes up around 16% of the revenue of small farm households. Additionally, it employs roughly 8.8% of the Indian population. India has abundant livestock resources, and the industry makes up 25.6% of all agriculture GDP and contributes 4.11% to the overall GDP. Pastoralism, domestication for subsistence. Pastoralism undertakes the domestication of animals for subsistence. People living in different climatic conditions selected and domesticated animals found in those regions. Status of practice. Depending on geographical factors and technological development, animal rearing today is practiced either at the subsistence or at the commercial level. Nomadic herding or pastoral nomadism is a primitive subsistence activity in which the herders rely on animals for food, clothing, shelter, tools, and transport. Geographical regions. In mountain regions, such as the Himalayas, Gujars, Bakarwals, Gaddis, and Bhotias migrate from plains to the mountains in summer and to the plains from the high-altitude pastures in winter. Such seasonal migration is known as transhumance. Hunting and gathering. This economic activity depends on their immediate environment for their sustenance. Hunters and gatherers subsist on animals which they hunted. The edible plants gathered from forests in the vicinity. Geographical regions. Tribal belt of central India and hilly regions of northeast and eastern India. In India, largely tribal groups, particularly PVEGs, are engaged in hunting and gathering, e.g. Anjas, Jarawas, Shampan of Andaman and Nicobar, Bondas of Odisha, Kotkaris of Maharashtra. Commercial opportunities. In modern times, some gathering is market-oriented and has become commercial. Trift. The institution is working to provide remunerative prices for the products gathered by tribes. Commercial livestock rearing. In rural India, raising animals is regarded as a business related to agriculture. Animal husbandry is a crucial part of Indian agriculture and provides a living for over 55% of rural residents. Products. Important animals include sheep, cattle, goats, and horses. Products such as meat, wool, hides and skin are processed and packed scientifically and exported to different world markets. Major countries: New Zealand, Australia, and the United States of America are important countries where commercial livestock rearing is practiced. Agriculture sector in India, Economic Survey 2022-23. The Indian agriculture sector has been growing at an average annual growth rate of 4.6% during the last 6 years. It grew by 3% in 2021-22 compared to 3.3% in 2020-21. Of all the veggies, India is the one that produces the most potatoes, ginger, okra, onions, brinjal, etc. In addition, India is the world's top producer of jute, cashews, papaya, spices, coconut, mango, bananas, and other products. The largest cotton exporter in the world is India. In India, animal husbandry is a significant component of the agricultural industry. It is responsible for over 32% of the output. Types of agriculture. Subsistence agriculture is one in which the farming areas consume all, or nearly so, of the products locally grown. It can be grouped into two categories: primitive subsistence agriculture and intensive subsistence agriculture. Primitive subsistence agriculture. Primitive subsistence agriculture, or shifting cultivation, is widely practiced by many tribes in the tropics, especially in Africa, South and Central America, and Southeast Asia, e.g. Juming and Northeastern. Plantation agriculture was introduced by the Europeans in colonies situated in the tropics. Some of the important plantation crops are tea, coffee, cocoa, rubber, cotton, oil palm, sugarcane, bananas, and pineapples. It is a type of commercial farming where monoculture is practiced, having strong linkages with industries. Geographical areas. They are largely confined to tropical areas. In India, plantation agriculture has developed in hilly areas of the northeast, e.g. plantation, Nilgiri, Annamalai, Bababudan, and Cardamom Hills, etc., having plantation of coffee, rubber, etc. Challenges. Mixed farming. This form of agriculture is found in the highly developed parts of the world, e.g. Northwestern Europe, Eastern North America, parts of Eurasia, and the temperate latitudes of southern continents. Mixed farms are moderate in size, and usually the crops associated with them are wheat, barley, oats, rye, maize, fodder, and root crops. Components. Fodder crops are an important component of mixed farming. Crop rotation and intercropping play an important role in maintaining soil fertility. Cooperative farming in India. States of India, Milpa in Central America and Mexico, and Ladang in Indonesia and Malaysia. Intensive subsistence agriculture. Due to small landholding and huge population density, around 80% of farmers hold small and marginal lands. Hence, they are engaged in intensive subsistence agriculture. In this type of agriculture, the yield per unit area is high, but per labor productivity is low. Monoculture, inefficient policies. The sector is suffering from distorted policies and a lack of long-term vision. Lack of mechanization, impact of climate change, a lack of value addition. Plantation agriculture is leading to deforestation. Equal emphasis is laid on crop cultivation and animal husbandry. Animals like cattle, sheep, pigs, and poultry provide the main income along with crops. Case study. Farmers in the Hassan district of Karnataka have taken up dairy farming in their coconut farms, which have shown that tending to livestock also leads to an increase in revenue from coconut trees. It is an organization of farmers where farming is done collectively, however each member remains the owner of his land individually. They share their profit in the ratio of their land holdings. Cooperative movement in India started during British rule, however it gained strength due to reforms after independence and favorable policies. Significance. Institutionalizing principle of mutual help. According to the Planning Commission, cooperatives represent the institutionalization of the principle and mutual aid. Economies of scale. In India, 80% of farmers are small and marginal. Land pooling enables the mechanization of farming and precision irrigation, thus improving the overall productivity of land. This increases the per capita output of the members. Combination of outputs. It provides a platform where farmers can come together and share efficient and scientific methodologies, thus modern practices can be implemented. Such complementary exchange of ideas, capital, labor, and livestock would help to reap the maximum output from farming. Access to credit. The availability of credit to cooperatives is easy due to the combined creditworthiness of the members. Doubling farmers' income. Effective organization of cooperatives would help to realize the doubling of small farmers' income. Challenges. Cooperative farming failed to make a frontal attack on the prevailing inequality in the economic structure, as the traditional status distinction of landowners, landless laborers, and sharecroppers are still being maintained. Mechanization of agriculture through cooperative farming will squeeze the scope of employment and is likely to make workers redundant in rural areas. Cooperative farming is not the only method to raise agricultural productivity. There is the availability of better alternatives like the adoption of HYV seeds, fertilizers, implements, etc. for raising the productivity of agriculture. Way forward. Success of cooperative movement has been restricted to a few states like Maharashtra and Gujarat. At all Indian levels, cooperatives have failed to put a positive impact. due to political control and corruption in the cooperative institutions. FPC, it is a hybrid between cooperatives and private limited companies registered under the Companies Act. It will plug the structural vulnerabilities of the agriculture sector. FPCs would increase farmers' control over the company under statutory provisions, thus removing flaws of cooperative organization. Success story of the largest FPC, Sayadri Farms, can be replicated throughout the country. Rising share of agricultural employment. Fact-wise. Periodic Labor Force Survey, PLFS, Report 2021-22. The share of agriculture in the total workforce has fallen from 64.6% in 1993 to 94 to 45.5% in 2018 to 19. Women make up over 63% of the workforce in the agriculture industry on a national basis, compared to 11.8% of female workers in manufacturing. Major constraints in Indian agriculture. Structural constraints, operational holdings. According to the 2010-11 agriculture census, the average operational holding size of Indian farmers is 1.15 hectares and 85% are in marginal and small farm categories of less than 2 hectares. Subsistence agriculture. Indian agriculture is largely subsistence-oriented, which deprives economies of scale due to small holdings and inability to practice mechanized farming. Forward and backward linkages. Due to a lack of forward linkages, value addition and primary processing to farm products is very low as compared to developed countries. Financial constraints. Lack of credit. Poor access to credit and farmers trapped under the clutches of unorganized creditors forces them to distress sale with low remuneration. Ineffective flow of funds. According to the Indian Council for Research on International Economic Relations Organization for Economic Cooperation and Development, ICRI OECD, report, despite the abundance of programs implemented to assist and subsidize Indian farmers, regressive marketing policies has resulted in the loss of funds. Infrastructural constraints. Lack of irrigation. Lack of irrigation and erratic monsoon makes farming unsecured, which pushes the young generation with their vigor and entrepreneurship away from the sector. Poor infrastructure. A lack of basic infrastructure for storage, transportation, and other purposes led to net losses for Indian farmers, who were consequently not taxed. Selective procurement. Only wheat and paddy, rice, which must be purchased in substantial numbers to meet the Public Distribution Systems (PDS) requirements of 65 million tons, are among the 23 crops for which the government declares MSP. Stagnant MSP rates. The government's declared minimum support prices don't rise in line with increases in production costs. Unfair access. Not all farmers and all crops receive the advantages of this program. Many areas of the nation, such as the northeastern region, have inadequate implementation. Non-scientific agricultural practices. MSP results in non-scientific agricultural practices that stress the soil and water to the point where the groundwater table deteriorates and the soil becomes salinized. Other constraints. Small holdings of farmers, primary and secondary processing, supply chain, the infrastructure supporting the efficient use of resources and marketing, reducing intermediaries in the market. Changing trends in agriculture modernization. Future scope for agriculture sector. Precision agriculture utilizes GPS, lot sensors, and data analytics to optimize field-level management. Automation and robotics. Introduction of autonomous tractors, drones, and robotic harvesters. Genetically modified crops, GMOs, development of crops with enhanced traits such as pest resistance, drought tolerance, and higher nutritional value. Diverse climatic zones. According to the ICAR, India has a lot of arable land divided into 15 agroclimatic zones. A variety of crops can be grown in such varied fruitful environments. Urbanization. India's growing population, urbanization, average income, and consequences of globalization will raise demand for a greater variety, quantity, and quality of food. Water management technologies. Implementation of advanced irrigation systems such as drip and sprinkler irrigation. Biopesticides and biofertilizers. Shift towards using natural pest control methods and organic fertilizers. Climate-smart agriculture. Adoption of practices that make agriculture resilient to climate change. Smart irrigation systems. Integration of sensors and smart controllers to optimize irrigation schedules. Biotechnology advances. Use of CRISPR and other gene editing technologies for crop improvement. Industry 4.0. In addition, the use of IoT, AI, and ML in agriculture, private investments in R&D, government initiatives to revive the cooperative movement to address the issues of small holdings and small producers, and other factors are altering the face of agriculture in India. Biotechnology. Because modern biotechnology products are economically viable, they can enhance both agriculture and the food industry, which will increase the income of subsistence farmers. Many startups in agriculture by professionals. It conveys admiration for the enormous possibility of investing time and money in this field. Government initiatives. Pradhan Mantri Kisan Samman Nidhi, PM Kisan, under the scheme, financial benefit of Rs. 6,000 per year is transferred in 3 equal 4 monthly installments into the bank accounts of farmers' families across the country through direct benefit transfer (DBT) mode. Pradhan Mantri Fasal Bima Yojana PMFY was launched in 2016 in order to provide a simple and affordable crop insurance product to ensure comprehensive risk cover for crops to farmers against all non-preventable natural risks from pre-sowing to post-harvest and to provide adequate claim amount. Agriculture Infrastructure Fund, AIF under the scheme, Rs. 1 lakh crore will be provided by banks and financial institutions as loans with interest subvention of 3% per annum and credit guarantee coverage under CGTMSE for loans up to Rs. 2 crores, formation and promotion of new 10,000 FPOs. The Government of India launched the Central Sector Scheme, CSS, for formation and promotion of 10,000 farmer-producer organizations, FPOs, in the year 2020. Dairy sector in India contribution to the economy. It is the single largest agricultural commodity contributing 5% of the national economy and employing more than 8 crore farmers directly. India is ranked first in milk production, contributing 23% of global milk production. According to Niti Aayog, in 2033 India's milk production would rise to 330 MMT while its milk demand would be 292 MMT. Thus, India is likely to be a milk surplus country by 2033. Operation Flood. Due to Operation Flood after the 1960s, India's contribution to world milk production rose from 5% in 1970 to 23% in 2021. Today, India is largely self-sufficient in milk production. Government initiatives, Rashtriya Gokul Mission. It was launched in 2014 under a national program for bovine breeding and dairy development, for the development of indigenous breeds and to improve their genetic makeup. Nationwide AI, Artificial Insemination, program. It is aimed at enhancing annual milk productivity up to 3,000 animal. KCC, the dairy farmers have been included in the Kisan Credit Card, KCC, program. It ensures adequate and timely credit support for the farmers. Nrega, dairying was brought under MGNREGA to compensate farmers for the income loss due to COVID-19. One Health Mission. The implementation of the One Health Mission with almost 60% enhancement in fund allocation for livestock health and disease control for 2022 to 23 over the previous year will ensure healthier livestock and a healthier India. Significance of dairy sector. Challenges faced by the dairy sector. Diversification of income. The dairy sector has augmented the income of the farmers, and during distress periods of drought and flood it has. Unorganized sector. The majority of milk producers are unorganized and thus fail to advocate their organized demands. Ensured livelihood security through steady income. Nutritional support. Milk products are a vital part of a diet to reduce malnutrition and undernutrition. The inclusion of milk products under the midday meal scheme would help to reduce stunting and wasting in children. Women empowerment. It is a labor-intensive sector in India, and the female population comprises around 69% of the sector's workforce. Hence, the dairy sector's development directly promotes women's empowerment. Fragmented supply chain. Milk is a highly perishable product, so it requires immediate disposal at the customer's end. Cattle feed prices. Due to the lack of sustained availability of cattle feed and its high prices, the profit margin of the business reduces. Poor return to farmers. The fat-based pricing policy results in 20 to 30% less money to farmers compared to market prices. Hygiene conditions. Many cattle owners do not provide proper shelter to their cattle, leaving them exposed to extreme climatic conditions, which further leads to mastitis conditions. Way forward. Cooperatives should strengthen their voice by uniting together. Government should provide the basic needs of the sector, i.e. availability of cheap cattle feed, upgradation of the supply chain network and cold storage by boosting private investment under the PPP model. Use of ICT technologies and promotion of startups assisted by government schemes would create new employment opportunities and retain new generations in this sector. Milk processing industry is a sunrise industry, so cooperatives must venture into cheese, yogurt, and ice cream products to realize untapped demand and provide more returns to the farmers. Agro-based and agro-processing industries. Agro-based companies are those that source their basic materials from the agricultural production of both plants and animals. Additionally, they increase the value of agricultural output by processing it and creating goods that can be sold and used. India's textile, sugar, vegetable oil, tea, coffee, and leather goods sectors are a few examples of agro-based businesses. Present status. Even though India is the second largest producer of fruits and vegetables in the world, after China, just 2% of the crop is processed. India has the largest livestock population in the world, with 50% of buffaloes and 20% of cattle, yet just 1% of the country's total meat production is turned into items with value added. Although there is a sizable manufacturing base, the processing is little, less than 10%. About 2% of fruits and vegetables, 8% of marine goods, 35% of milk, and 6% of poultry are processed. Sunrise industry. Niti Aayog has identified food processing industries as the sunrise industry, having huge domestic demand, which has the ability to uplift the unorganized sector. Contribution to GDP. The food processing sector's contribution to India's GDP is less than 2%. Thus need private investment and new startups to exploit its true potential. Significance. Government initiatives. Income diversification. These industries also provide profitable diversification in the rural areas, which ensures all-round industrial growth in the rural areas. Employment. The annual industrial survey 2016-17 showed that the agro-industries contribute about 36% of the industrial employment. Policies. Agro-processing cluster. Through a well-equipped supply chain and cutting-edge infrastructure, it aims to connect groups of producers or farmers to the processors and marketplaces. Mega Food Park. The program intends to create modern infrastructure and shared amenities to attract forward and backward linkages. Development of these linkages in post-harvest management, warehouses, cold storages, logistics facilities, etc. would shift surplus labor from the farming sector to more productive industrial activities. Reduce food waste. According to the UN, 40% of the production is lost. The annual post-harvest losses were also estimated by Niti Aayog to be close to 90,000 rupees. Curbing food inflation. Food processing extends the shelf life of the food, which helps to keep supplies in line with demand and reduce food inflation. For instance, frozen safel peas are offered all year long. Boosts trade and earns foreign exchange. It serves as a significant source of foreign exchange. For instance, Middle Eastern nations have a high demand for Indian basmati rice. Business groupings to establish food processing units using a clustering method. Creation expansion of food processing preservation capacities. Unit scheme. The primary goal of the scheme is to build processing and preservation capacity and expand existing food processing units with the intention of raising processing levels and adding value, which will reduce waste. Institutional setups. Ministry of Agriculture. It deals with bakeries, cold storage, sugar mills, oil mills, and mills for rice. Khadi and Village Industries Board. Agro-Industries Development Corporation. Each state's Agro-Industries Development Corporation primarily provides farmers with agricultural equipment, inputs, and consultancy services. Small Industry Development Organization. This organization works with small agro-industries such as hosiery, beverage processing, food and fruit preservation, and agricultural tool manufacturing. Way forward. Enhance agriculture marketing framework to increase farmers' price realization through policy changes. Direct marketing through farmer-producer organizations can be promoted. Formulate an integrated agriculture export mission to scale up food processing and exports by increasing value addition from 10% to 50%. Integrated approach. An integrated strategy is required, with a focus on creating backward and forward connections, which are essential for increasing the sector's economic viability. PPP. Encourage the private sector to participate more actively in the industry's overall development by providing a well-developed framework for risk-sharing and financial incentives for building infrastructure for logistics, storage, and processing. Uniform implementation of APMC Act. Make sure that the APMC Act is implemented uniformly to enhance private sector participation, and that the GST tax structure is harmonized to prevent significant variances in prices. According to the Economic Survey 2022-23, Indian agriculture has to be reoriented in view of a number of issues, including the negative effects of climate change, fragmented landholdings, inadequate farm mechanization, low productivity, covert unemployment, growing input costs, etc. For the nation's economy to thrive and create jobs, the agriculture sector's performance must continue to be strong. Mining sector in India. The mining sector in India is termed to be one of the core industries of the Indian economy, for it provides basic raw materials to many important industries. Mining is the process of extracting valuable geological components from the planet and other celestial bodies. Status of Indian mining, MOSBI. Contribution to economy. Despite only varying between 2.2% and 2.5% of the industrial sector's GDP, the mining sector's GDP contribution ranges from 10% to 11%. Employment. The mining industry, which also employs over 5.5 crore people, directly and indirectly employs roughly 1.1 crore people. Revenue. India's GDP from mining rose from 645.94 billion in the third quarter of 2022 to 787.32 Indian rupees billion in the fourth quarter. It is planned to raise mining's contribution to 8 rupees lakh crore by FY 24-25. The legislative framework of mining sector in India. Central list. The central government is required to own the minerals located within India's EZ by the entry at Serial No. 54 of List I. Central list. The Mines and Minerals, Development and Regulation, MMDR, Act of 1957 was created in response to this. State list. The state government is required to own the minerals found within its borders under the entry at Serial No. 23 of List II. State list of the Indian Constitution. International Seabed Authority. Exploration and mining of minerals are governed by the International Seabed Authority, ISA. It is governed by a UN treaty, to which India is a party. India has been granted the sole right to explore polymetallic nodules spread across 75,000 square kilometers in the central Indian Ocean basin. Significance. Growth. According to the government's own assessment, 1 percentage point growth in mining pushes up the growth rate of industrial production by 1.2 to 1.4 percentage points. Employment. One direct job in the sector creates 10 indirect jobs. It is a labor-intensive industry which provides employment opportunities largely to unskilled laborers. Production. India is the world's second-largest coal producer and being the fifth-largest country in terms of coal deposits. It is a net exporter of finished steel and has the potential to become a champion in certain grades of steel. Gross value addition. The mining and quarrying industry's contribution at current prices to GVA accounted for about 2.4% in the year 2021 to 22. As per 2019 data, the mineral sector's contribution to the GDP is 1.75%. National Mineral Policy 2019 it envisages increasing the production of major minerals by 200% and reducing the trade deficit in the mineral sector by 50% in 7 years. The policy aims to attract private investment through concessions like a financial package, right of first refusal at the time of auction, etc. Features. Revenue sharing model. It adopted a revenue sharing model to encourage the private sector to explore. Transfer of mining leases. The policy has provision for the transfer of mining leases and the creation of dedicated mineral corridors to boost private sector mining areas. Export-import policy. It provides emphasis on a long-term export-import policy for the mineral sector to give stability for investing in large-scale commercial mining activity. Exclusive mining zones. Policy has introduced the concept of exclusive mines which will come with in principle statutory clearances for the grant of mining lease. Easy clearance. The policy would simplify the process of clearance and would make it a time-bound process for mineral development and commencement of mining operations. No-go areas. Certain areas would be declared as no-go areas or inviolate areas considering the fragility of the ecosystem. District Mineral Fund. The policy emphasizes on proper utilization of the District Mineral Fund to ensure the welfare of mining-affected people by providing rehabilitation and resettlement to affected people. Intergenerational equity. The policy has introduced the concept of intergenerational equity in mineral resource exploitation. Government initiative. FDI up to 100%. Under the automatic route is allowed with certain clauses. PLI scheme. GI has given approval to introduce the production-linked incentive PLI scheme in specialty steel for enhancing India's manufacturing capabilities and enhancing exports. Mission Purvodaya. It emphasized unlocking the potential of the Eastern India region to fuel the next wave of national growth. District Mineral Foundation Fund. It has been established for the well-being of mining-affected people. CABIL. To ensure the supply of critical and strategic minerals to Indian industries. PM Khanaj Kshatriya Kalyan Yojana, 2015 to ensure the well-being of those who are impacted by mining in the environment, carried out by DMF. National Mineral Exploration Trust, NMET, 2004, for regional and detailed exploration of minerals. Mines and Minerals, Regulation and Development, Amendment Act, 2021. Removal of restriction on end use of minerals, removing the restriction on the final use of minerals. According to the bill, no mine would be restricted for a specific final use. Sale of minerals by captive mines. Captive miners may sell up to 50% off their yearly mineral production on the open market after meeting their own needs, according to the bill, excluding atomic minerals. Auction by the central government in certain cases. In some circumstances, the central government may conduct an auction. If so, the bill gives it the authority to do so after consulting with the state government. Transfer of statutory clearances. According to the bill, transferred statutory clearances will remain in effect for the entirety of the new lessee's lease term. Allocation of mines with expired leases. Mines with expired leases may be assigned to a government business in certain circumstances, according to the bill, provided that the mines are either coal, lignite, or atomic minerals. Way forward. Proper rehabilitation of mining project affected displaced persons and utilization of district mineral funds for their welfare is mandatory to gain the trust of these people. It will restrict them from supporting left-wing extremism activities. Effective implementation of National Mineral Policy 2019 and transparency in mineral block allocation must be maintained. Effective conduct of Environment Impact Assessment, EIA, and Social Impact Assessment, SIA, must be ensured before allocation of any project. NGT guidelines must also be followed for the protection of ecologically sensitive areas. E.g., recently NGT has ordered the UP government to take remedial actions to curb illegal sand mining. Single window and time-bound environment. Forest clearance will be key to the timely allocation of blocks and meeting the demands of industrial sectors. Conclusion. India has huge mineral potential, but the explored area is very minimal compared to the actual potential, which has caused a huge minerals import bill. Sustainable and regular supply of minerals is key to the uninterrupted functioning of the industrial sector, which is the growth engine of any economy. India has no room to miss its mineral sector objectives, hence effective functioning providing expected output must maintain a growth rate of 8 to 9% per year. Secondary sector. Secondary sector includes the industrial sector, which processes natural raw materials and converts them into finished products. Secondary sector is the backbone of the economy, which provides employment to people who moved from the primary sector and have gathered certain skills. One of the important sectors of the Indian economy, the secondary sector accounts for 14% of all employment in the country. Furthermore, the secondary sector contributes almost a quarter of the GDP. Transportation and industry are the two best illustrations of this industry. Importance of the industrial sector in the Indian context, economic. Provide employment. The industrial sector has made a significant contribution to creating jobs. Employment opportunities grow as industries mature. By giving jobs to 11 crore employees in India, industries like MSMEs played a significant part in absorbing a semi-skilled workforce. Trickle-down effect. Growth in the industrial sector activates growth in other sectors like development of agriculture, development of science and technology, self-sustained growth. The booming capital goods sector encourages the expansion of the transportation, agricultural, and communication sectors. It also ends our reliance on foreign nations for the supply of necessities. Data. Index of Industrial Production. India's Index of Industrial Production, IP, increased by 5.7% in February, up from 3.8% in January. According to data from the Ministry of Statistics and Program Implementation, MOSPI. December 2023 saw a 4.2% IP growth. Power generation rose by 7.5% year-on-year, YOY, in February, compared to 6.9% in January. Political. Increased international clout. The promotion of trade is aided by industrialization, which has a significant impact on global trade. Trade benefits developed countries more than it does less industrially developed nations. Stability. An economy with fast economic growth is less vulnerable to social pressures like civil war, thus increasing political stability. Social. Poverty alleviation. This sectoral transformation to the industrial sector is a precondition for the eradication of unemployment and poverty. According to the UNDP report, India has pulled around 25 crore people out of poverty, raising job standards in industrial sectors. Equitable growth. It was also aimed at bringing down regional disparities by establishing industries in tribal and backward areas. E.g., promotion industries in backward areas have helped in distributing fruits of development in remote areas as well. Development of Vidarbha region of Maharashtra. Demographic dividend. India is going to witness the largest demographic dividend in the coming decade. The manufacturing sector is vital as it can create labor-intensive jobs and can promote an improved standard of living for the future generation. E.g., textile, automobile sectors have huge demand and potential to create new jobs. Technological. Innovation and collaboration. An increase in R&D strengthens industries and promotes plug-and-play technology through partnerships with higher education institutions. Industry 4.0. With the emergence of Industry 4.0, it has opened the scope for the use of technology in other social sectors, thus making a spillover effect. Security. Increased national security. Our ability to produce defense machinery and equipment domestically has allowed us to avoid paying expensive foreign exchange to import it, thanks to the growth of our businesses. Economic security. It makes us non-dependent on Western countries which use various tools to exploit developing countries. For example, the USPL, for 80 program. Types. Find USTRIS. Manufacturing industries can be classified based on various grounds. The following are some basic classifications of the industries. Depending on the strength of labor, size. Large scale. Businesses that employ numerous workers in each unit are referred to as large-scale businesses. Large-scale enterprises include the cotton and jute textile industries. Medium scale. Medium-scale industries are defined as those that neither employ a very large nor a very small number of workers. Examples of medium-sized enterprises are the bicycle, radio, and television industries. Small scale. Individually owned and operated businesses that only hire a few workers are referred to as small-scale businesses. Depending on raw material and finished goods. Heavy. The term heavy industries refers to those that manufacture goods from the same type of heavy and bulky raw materials. Heavy industries are well represented by the iron and steel sector. Light. Light industries create light finished goods and utilize light raw materials. Light industries include sewing machines and electric fans. Depending on the source of the raw material. Agro-based. Industries that rely on agriculture as a source of raw materials are known as agro-based industries. Sugar, vegetable oil, jute textile, cotton textile, and cotton textile are examples of agro-based industries. Depending on the ownership. Private sector. Industries located in Jamshedpur that are owned by people or companies like Bajaj Auto or Tisco are referred to as private sector industries. Mineral-based. This group includes businesses like iron and steel, aluminum, and cement that principally rely on minerals for their raw materials. Based on pastoral agriculture, these sectors rely on animals as a source of raw materials. Some pastoral-based industries include those that produce shoes, dairy, hides, skins, bones, horns, and so on. Forest-based industries. They include those that produce paper, cardboard, lac, rayon, resin, tan leather, wooden tools, and baskets. Public sector. Companies like Bharat Heavy Electricals Ltd. and Durgapur Steel Plant that are owned by the government. Joint sector. Businesses like Gujarat Alkalis Ltd. and Oil India Ltd. which are jointly owned by the state and/or its agencies, are examples of joint sector businesses. Cooperative. These are jointly owned and operated by a group of individuals who typically provide the raw materials for a certain industry, such as a sugar mill that is jointly owned and operated by farmers, are referred to as cooperative sector businesses. Multinational. A multinational corporation, MNC, has locations and additional assets in at least one nation aside from its own. Factors influencing location of industries. There are a range of factors influencing the location of the industry, which can be divided into two broad categories: geographical factors and non-geographical factors. Geographical, non-geographical. Power. A consistent power supply is a requirement for the localization of industries. Raw materials. Raw material has been the most fundamental deciding factor of industrial location. Labor. Unless there are compelling arguments to the contrary, nobody can dispute that the presence of a labor force in the past is appealing to industry. Market. The entire process of manufacturing is useless until the finished goods reach the market. Transport. The assembly of raw materials and the sale of finished goods both require transportation by land or water. Water. Industries like textile, chemical, and iron steel require huge amounts of water for their functioning, hence proximity to water resources is beneficial for these industries. E.g., the jute industry in Bengal is benefited due to the closeness of the Hooghly River. Capital. Capital-intensive modern industries demand substantial investments. Government policies, e.g. Gujarat's industrial policy has attracted the nano plant of Tata from West Bengal due to favorable government policies and incentives. Access to agglomeration economies. Benefits are derived from the linkages which exist between different industries. Industrial inertia. Industries tend to develop at the place of their original establishment due to inertia of the region, e.g. lock industry at Aligarh. Historical factors. Mumbai, Kolkata, and Chennai locations are greatly influenced by our colonial past. Banking and credit facilities. The development of industry necessitates the daily exchange of millions of rupees, which is only made feasible by banking facilities. Industrial corridors. IC. In India, the National Industrial Corridor Development Corporation, NICC, is a special purpose vehicle with the goal of establishing, fostering, and facilitating the implementation of the National Industrial Corridor Development Program. Objectives. These are envisaged along the main transport routes, giving special thrust to industrial development. It involves multiple projects targeted towards an increase in exports, employment generation, environment management, etc. Present status. The government has sanctioned and approved 8 projects under the National Industrial Corridor Development and Implementation Trust, NICTIT. Completed project. The major trunk infrastructure works for 4 of the 8 projects have been finished. The Integrated Industrial Township in Greater Noida, Uttar Pradesh. The Dollar Special Investment Region in Gujarat. The Shindrabikan Industrial Area in Maharashtra. And the Integrated Industrial Township Vikram Udyapuri in Madhya Pradesh. Projects in process. The other 4 approved projects are in various stages of implementation development. The status of Tumkuru Node in Karnataka under C. Copyright in TERNATONALAIRPORTS. Pound MA Joe RPORTS. And ATONALNVESTMENT and MANUFACTURNGZONES. Influ ENCEREGIONOFPROPOSED INDUS TRIA LCO RID ORS and DIA. DEDICATEDFREIGHTCO RID OR. PROPOSED and DUS TRIA LCO RID ORS. Projects is given as below. Lee Bengaluru Industrial Corridor, CBC. Krishnapatnam Node in Andhra Pradesh under CBC. Integrated Multimodal Logistics Hub at Nungal Chaudhary in Haryana under Delhi Mumbai Industrial Corridor, DM1C. Multimodal Logistics Transport Hub at Dadri in Uttar Pradesh under DMIC. Significance of industrial corridors. It includes 4 key components: transport, warehousing, forwarding, and value-added logistics. Economic growth. Industrial corridors are meant to provide world-class transportation facilities connecting industrial clusters. High-capacity dedicated freight corridors would act as a backbone for creating a global manufacturing and investment destination. Logistic improvement. IC will help to facilitate the multimodal movement of cargo on par with global logistics standards. It will decrease the cost of logistics and improve the competitiveness of Indian goods. Ease of doing business. IC would facilitate faster clearance to start a business, deal with construction permits, and register property. It will attract more business and investment. Employment creation. IC provides both forward and backward linkages to the industries and hence has wide potential to create employment across the logistics sector and warehousing sector. It would boost infrastructure development, creating jobs and associated sectors. Strategy of regional resource-based manufacturing and management industries which are located near raw material utilizes local inputs and transforms them into final material. This also helps in the creation of employment and overall regional development. This strategy helps in backward area development and the promotion of equitable development. It promotes local products and artifacts and tries to convert them into national and global brands. Under this strategy, industries are attracted based on the availability of natural resources and provided with other facilities like transportation, electricity, etc. Government initiatives to harness regional potential. Impact of regional resource-based manufacturing. Odisha Industrial Development Plan, Vision 2025. It focuses on 5 industries with the aim of luring Rs. 2.5 lakh crore in investments and generating 30 lakh direct and indirect jobs. Products with GI tags. They can be produced locally and sold internationally in various states and areas. One Station, One Product. On March 25, 2022, this program was introduced at 19 Indian railway stations. Functional specialization. People with specialist skill sets are required to work in industries where one type of resource is the main focus. Establishing auxiliary industries. When a particular type of industry is founded with a given resource, numerous subsidiary enterprises in the form of MSMEs, secondary employment. In addition, there are side industries that support the primary industry as well as secondary jobs. Develop supply chain. The establishment of a supply chain in the region opens up more employment chances. Challenges. One district, one product scheme of the UP government strives to promote regional traditional industries. Northeast Industrial Development Scheme incentivizes industries to set up in the Northeast region. Mission Purvodaya. It was launched in 2020 for the accelerated development of Eastern India through the establishment of an integrated steel hub. Decrease transportation cost. The proximity of production facilities and raw supplies will lower transportation expenses. Diversity in demand. There would be a greater and more varied demand for consumer goods. This starts a cycle that could lead to expansion in the production, distribution, and support of the secondary and tertiary sectors. Lack of infrastructure. Resource-rich regions like Jharkhand, Chhattisgarh, Northeast region fail to attract industries due to lack of complementary infrastructure. Lack of skills and modernization. Local craftsmen fail to modify local artifacts as per global demands due to a lack of modern equipment. Lack of vision in policy formulation. Due to poor development of local skills and poor marketing, regional products have failed to transform into recognized brands. By 2022, the national manufacturing policy had aimed for manufacturing to account for 25% of the nation's GDP. However, it has been seen that some areas experience extraordinarily quick development because of their favorable geographic position and high level of industrialization, while other regions lag behind. In this sense, regional manufacturing becomes very important. Textile industries. The domestic apparel and textile industry in India contributes approximate 2.3% to the country's GDP, 13% to industrial production employment. Being the second largest employer in India after agriculture, the industry is crucial to the country's economy. Additionally, it directly and indirectly employs about 10.5 crore people. Export. India is also the world's second largest producer and exporter of textiles and apparel, accounting for 5% of all international trade. In 2018-19, it made up 12% of all exports from India. Market. The 2 biggest export markets for Indian textiles are the US and the EU, followed by a number of Asian nations and the Middle East. Valuation. The Indian textile and apparel market size is estimated around $165 billion in 2022, with domestic market constituting $125 billion and exports contributing $40 billion. The market size of the industry is projected to grow at a 10% CAGR to reach $350 billion by 2030. The government is dedicated to boosting India's textile exports from the current $44.4 billion to $100 billion over the following 5 years. Cotton textile industry. Climatic condition. Frost-free climates, temperatures between 20 and 30 degrees Celsius, and little annual precipitation, black soil or alluvial soil. Area under cultivation. Additionally, it cultivates the most cotton, accounting for nearly 25% of all agricultural land worldwide. The largest cotton-producing states in India include Gujarat, Maharashtra, Andhra Pradesh, Haryana, Punjab, Madhya Pradesh, Rajasthan, Karnataka, and Tamil Nadu. India's cotton basket, which is made up of the states of Maharashtra, Gujarat, Andhra Pradesh, and Telangana, produces over 2/3 of the country's cotton. Share. Power looms account for the largest share, around 80%, in cotton textile production, followed by handlooms and mills. It is an agro-based industry depending upon pure raw materials. Factors responsible for growth of cotton industry. Historical factor. The Industrial Revolution and later the First and Second World Wars, the Swadeshi movement, and the grant of fiscal protection rapidly propelled the growth of this industry. Locational factors. Post-independence, the industry also tended to shift from areas of high labor cost to those with low labor cost. The labor cost factor played a crucial role in establishing this industry at Madurai, Tirunelveli, and Coimbatore. Important centers: Mumbai, Ahmedabad, Coimbatore, Indore, Kanpur, etc. Backbone of Indian employment problems. Contribution to economy. The domestic apparel and textile industry in India contributes approximate 2.3% to the country's GDP, 13% to industrial production, and 12% to exports. India has a 4% share of the global trade in textiles and apparel. Second largest employer is the second largest employer after agriculture. Employment number. According to government statistics, the industry directly employs about 4.5 crore people and indirectly supports another 6 crore jobs. Women make up the majority of the workforce, making up between 60% and 70% of the entire labor force. Rural areas. The textile industry is also one of the most important sources of employment for rural residents. PLI scheme, the Production-Linked Incentive PLI scheme, which was authorized in September 2021 for the textile sector and is anticipated to add about 7.5 lakh new jobs directly and a few lakhs more through supporting activities. Obsolete equipment. Only 18 to 20% of looms in India are automatic, compared to 83 to 76% in Norway, 70 to 70% in Australia, 60% in Pakistan, and 45 to 50% in China. Scarcity of raw cotton. Raw cotton is scarce and has never been enough to meet demand. Low labor productivity. A worker in India typically manages 2 looms, compared to 30 in Japan and 60 in the USA. Strikes. Labor disputes are prevalent in the industrial sector, but the cotton textile industry suffers greatly as a result of regular worker strikes. Rising cotton prices. MSP of cotton has been fixed at Rs. 60.80 per quintal for medium staple and at Rs. 63.80 per quintal for long staple for 2022 to 23 season. Growing importance in global trade government initiatives. Extensive network. Due to its extensive network of both small and major manufacturers, exporters, and traders, the Indian textile sector is quite competitive. Stimulate local manufacture. The Make in India, Atmanirbhar Bharat, and performance-linked incentives (PLI) initiatives, which seek to stimulate local manufacturing and increase exports, have also helped the industry. Enhanced quality. Additionally, India is now able to create high-quality textiles that satisfy international standards because of its highly skilled workforce and technical breakthroughs. Diverse goods. The sector exports a wide variety of goods, including ready-to-wear clothing and textiles manufactured of cotton. Brand India. The business community is dedicated to marketing Brand India on a variety of international forums, emphasizing its advantages in labor standards, sustainability, circularity, ethical sourcing, and manufacturing. Extension for RoSCTL. In order to increase the competitiveness of the Indian textile industry on the global market, the RoSCTL scheme has been extended for exports of apparel garments and made-ups. PM Mitra scheme. The establishment of 7 Pradhan Mantri Mega Integrated Textile Region and Apparel PM Mitra Parks. A TUFS, Amended Technology Upgradation Fund Scheme. It was launched in 2015 for technology upgradation of the textile industry. SITP, Scheme for Integrated Textile Parks, to provide world-class state-of-art infrastructure facilities to small and medium units with a cluster approach. SUMERTH, Scheme for Capacity Building in the Textile Sector. The scheme is aimed at addressing the shortage of skilled laborers in the textile sector. PLS, Production-Linked Incentive Scheme. The scheme is aimed at promoting industries that invest in the production of man-made fiber apparel, man-made fiber fabrics, and technical textile segments. Why ahead for textile sector? Capacity building. Higher disposable income is the result of strong economic growth. A vast domestic market has been created as a result of the increase in product demand. Building the skills and capabilities of employees and business owners is essential and necessary. Investment in value-added services. A requirement for the sector to grow is investment in value-added services, such as marketing, warehouse rentals, shipping, courier, and other product fulfillment costs. Modernization. It is necessary to boost output, save costs, rationalize manpower and multiple tasks, lower maintenance, and improve the energy efficiency of the sector. Research and development. Government R&D organizations and academic institutions ought to work more closely with businesses and engage in R&D that is more pertinent to the changing demands of the cotton textile industry. Revamping the MSP scheme. The government would spend less money and cotton farmers would receive the same amount of relief if a plan could be developed for the direct transfer of subsidies to the extent of the difference between market prices and MSPs whenever market rates fall below MSPs. Market-related strategy. The cotton sector must set high prices, target specialized products and markets, and redesign products for greater value-added markets. For sustained development, it also has to concentrate on regional and cluster subsidies, technology upgrades, and talent development subsidies. Conclusion. Programs like Skill India, Make in India, and Atmanirbhar Bharat, as well as the continued development and growth of management consulting firms in India for foreign companies, are assisting in the growth of the Indian textile industry. The textile industry would become competitive in the global market if it had access to skilled manpower and a good market for its products. With proper market entry strategies in place for global behemoths, the Indian textile industry's future looks bright, buoyed by both strong domestic and export demand. Jute industry. Climatic condition. It is best to grow jute in hot, humid areas. high humidity levels of 80 to 90%, significant precipitation of 120 to 150 centimeters, and temperatures between 24 and 35 degrees Celsius are necessary. Production. India is the largest producer of jute products. However, in terms of acreage and trade, Bangladesh takes the lead, accounting for 3/4 of the global jute exports in comparison to India's 7%. Employment. This company supports around 40 lakh farming families and directly employs 1.4 lakh tertiary workers and 2.6 lakh manufacturing workers. Process of production. The jute industry's production process includes a number of phases, such as the preparation of jute fibers, spinning, weaving, bleaching, dyeing, finishing, and marketing of both the raw material and its finished products. The majority of jute mills and output, more than 80% of total production, are located in West Bengal. With 10% of the whole industry in Andhra Pradesh and the remainder in Uttar Pradesh and Bihar, the sector has spread westward. The majority of jute mills are restricted to a small, 100-kilometer-long belt along the Hooghly River within a 64-kilometer radius of Calcutta. This belt is only 3 kilometers wide. In addition to West Bengal, jute mills are located in Purnia, Kuddahar, Samastipur, Darbhanga, and Gaya in Bihar, Raigarh and Chhattisgarh, Cuttack in Orissa, and Guntur, Visakhapatnam, Nellamarla, Chelavelsa, Eburu, and Onal in Andhra Pradesh. There is one jute mill each in Tripura and Assam. Favorable condition for West Bengal. Temperature. Jute demands a warm, humid climate with temperatures between 25 and 35 degrees Celsius. Rainfall. West Bengal receives an average annual rainfall of about 150 to 250 centimeters, which is adequate for the growth of the crop. Adequate rainfall is essential for jute production. Soil. Jute thrives on fertile, alluvial soil that is high in organic matter and has a good ability to retain water. Land. Jute needs terrain that is level or gently sloping, well-drained, and has a high water retention capacity. The state of West Bengal has an extensive network of canals and reservoirs that make irrigation possible, and its deltaic plains are well adapted for the cultivation of jute. Labor. A lot of labor is required for jute farming, especially during harvest and processing. India's jute economy is faltering while Bangladesh's is flourishing, according to a 2021 report by the Commission for Agricultural Costs and Prices, CCP, between 2000 to 2001 and 2009 to 10. The average area in the nation under jute was 0.82 million hectares. Between 2010 to 11 and 2019 to 20, this decreased to 0.73 million hectares. Government initiatives. Indian case, Bangladesh case. Falling prices. It dropped to 25,000 rupees a ton in 2010 to 2011 from 30,000 to 40,000 rupee per ton in the late 2000s. This barely covered the expense of the input. Central procurement. 90% of the jute bags are given to the Food Corporation of India and state procurement organizations, while the remaining 10% are exported or sold directly. India's share. According to the CCP research, India also accounts for barely 7% of global jute exports, compared to approximately 75% for Bangladesh. Decreasing area under cultivation. In 2019 to 20, this decreased to 0.73 million hectares. Advantageous position. Low cost of production, which is fueled by lower salaries, favorable power rates, cash subsidies for export, and improved fiber quality. Better quality. India's jute production has struggled, especially with quality. India's jute industry suffers from inadequate retting infrastructure, which is a step after crop harvesting. Various subsidies. Bangladesh has 3 to 4 various types of subsidies, which helps it do well in the export market. Diversification. Another factor in the nation's success is its capture of the market for diverse jute products, which has a sizable market. Challenge faced by jute industry. Raw material. Most of the jute-producing areas went to Bangladesh, resulting in an acute shortage of raw material. Hence the availability of quality raw jute and shrinking acreage, obsolete machinery. Most of the mills are old with obsolete machinery, which results in low productivity and inferior quality and insufficient efforts of modernizing technology. Newly established jute mills with advanced technology in Bangladesh produce better quality jute products at a cheaper rate compared to Indian jute products. Infrastructural bottlenecks. Power, transportation, and capital also pose several threats to the sustainability of the jute industry. High prices. Mills are procuring raw jute at prices higher than what they are selling them at after processing. Poor quality of jute fibers. Natural disasters such as Cyclone Amphan. Floods cause waterlogging in the fields. Due to this, farmers harvest the crops prematurely. Anti-dumping duty. In 2017, India introduced a protectionist anti-dumping duty to protect its local jute industry. Jute Smart. It provides a platform for the procurement of jute products and promotes transparency in the jute sector. Jute Eye Care. It helps farmers by providing them with certified seeds, nail weeders for periodic wettings, and seed drills to facilitate line sowing. Government has made mandatory packaging of 100% food grains and 20% sugar in jute bags. MSP. Jute is included into the MSP regime to incentivize farmers for jute cultivation. Jute Geotextiles, JGT. It has been included under the Technical Textiles mission. JGT is one of the most important diversified jute products. It can be applied in many fields like civil engineering, soil erosion control, road pavement construction, and protection of riverbanks. Jute business sprouts new shoots as global demand for green. Context. According to the Indian Jute Mills Association, big brands buy shopping bags worth more than 1,000 rupees crore each year. Quantum jump. The value of India's jute bag exports was approximately 350 rupees crore in 2016, but by the end of the recent fiscal year 2021, that amount has nearly tripled to 1,000 rupees crore. Note, a jute shopping bag's lifespan is 600 times longer than a plastic one. Sugar industry. The sugar business in India uses sugarcane, a bulky, low-value, perishable raw material. Any crop that produces sugar, such as sugar beet or sugarcane, can be used to make sugar. India's main source of sugar, on the other hand, is sugarcane. After the cotton textile industry, this is the second largest agricultural sector in the world. Fact-wise. Production. India has emerged as the world's largest producer and consumer of sugar as well as the world's 2nd largest exporter of sugar after Brazil, in sugar season, October-Sep. 2021-22. Consumption. The domestic demand is roughly 27 million tons per year. Sugarcane is also used to create ethanol in addition to sugar. Employment. The sugar industry is a significant agro-based business with 50 million sugarcane farmers and around 5 lakh directly employed workers in sugar mills. Locational factors. Geographical distribution. Geographical conditions for the sugar production. Temperature, between 21 to 27 degrees Celsius. Climate, hot and humid climate. Rainfall, approximate 75 to 100 centimeters. Soil, deep rich loamy soil. Top sugarcane producing states, Maharashtra, Uttar Pradesh, Karnataka. Sugar industry has 2 major areas of concentration. North, Uttar Pradesh, Bihar, Haryana. South, Maharashtra, Karnataka, Tamil Nadu. Maharashtra, it has progressed to the top position surpassing up. Important centers are Ahmednagar and Kolhapur. Uttar Pradesh, it has more sugar mills than Maharashtra, but they are smaller in size, hence production is lesser than in Maharashtra. Important centers are Meerut and Gorakhpur. Tamil Nadu, it has shown high productivity per acre of sugarcane, higher sucrose content, a high recovery rate, and a long crushing season which enabled it to obtain the highest yield in India. Important centers are Coimbatore, Karur. Maharashtra overtook Uttar Pradesh to re-emerge as top sugar producer. Factors driving Maharashtra's massive sugar production. Reason for reduced sugar production in Uttar Pradesh. Abundant water supply. Sugarcane is a crop that requires a lot of water, which Maharashtrian farmers were successfully obtaining through rainfall, water reservoirs, a system of canals, and groundwater. Cane production is underreported. The information provided about the state of Maharashtra's real sugarcane production was not entirely correct. In the end, this led to an increase in the area used for sugarcane cultivation, from 11.42 lakh to 12.4 lakh hectares. Diversion for ethanol. Because a significant portion of Uttar Pradesh's sugarcane crop was shifted to the ethanol industry, Uttar Pradesh has emerged as the nation's top producer of ethanol. Excessive rain. The state of Uttar Pradesh experienced major losses in sugarcane crops as a result of excessive rain and waterlogging issues. Using single variety. A single type of sugarcane, Co. 0238, is grown on the majority of the land in Uttar Pradesh's sugarcane region, 87%. This sugarcane variety doesn't have a large yield. Fungal disease. The adverse effects of the fungus red rot on the sugarcane crop are a major factor in Uttar Pradesh's declining sugarcane production. Significance of the sugar industry. Problems and challenges in industry. Multiple links. From cane cultivation to the production of sugar and alcohol, the sugar industry relies heavily on labor. It is the primary source of employment in numerous districts in Uttar Pradesh, Maharashtra, Tamil Nadu, Karnataka, and several other states. Low yield. India has the largest area under sugarcane cultivation, but the yield per hectare is very low. Short crushing seasons. Sugar manufacturing is a seasonal phenomenon varying from 4 to 7 months in a year. High cost of production. The production cost of sugarcane is one of the highest in the world. The byproducts. Using sugarcane as a primary raw material, producers can now produce sugar, ethanol, paper, energy, etc. For livestock feeding. Due to its great nutritional value, sugarcane molasses is utilized for both cattle feeding and the manufacturing of alcohol. Biofuel. Sugarcane molasses, a byproduct of sugar production, is used to make the vast majority of the ethanol consumed in India. Bagasse. The primary use of bagasse is still as a fuel. However, it also makes a good raw material for the paper industry. Production costs can be reduced by utilizing byproducts like bagasse and molasses. Old and obsolete machinery. Particularly North Indian mills use old machinery having poor productivity. It has led to poor productivity of mills and reduced production. Government policies. Sector is suffering from the government's control and populist policies. Unviable sugarcane pricing caused the sugar cycle to oscillate between surplus and severe shortage. The Rangarajan Committee formula. It was established in 2012 to make suggestions for regulating the sugar business. Elimination of quantitative controls on sugar import and export. Their replacement with suitable tariffs. States should change their laws to enable mills to use biogas-generated energy. The committee has suggested a formula to fix the cane price factoring in the price of sugar and other byproducts. If the formula-based cane price drops below what the government considers as a reasonable payment, then the government can bridge the gap by making a dedicated fund through cess levies. A minimum radial distance of 15 kilometers must exist between any two sugar mills, according to the national government. Based on the findings, the Commission on Agricultural Costs and Prices, CCP, recommended a hybrid strategy for sugarcane price fixing that includes a fair and remunerative price, FRP. Government initiatives, encouragement of ethanol production. To help sugar mills maintain their operations, the government has urged them to shift excess sugar to ethanol production and export the remaining sugar. Ethanol blending with petrol, EBP program. According to the National Policy on Biofuels 2018, the ethanol blended petrol, EBP program suggested target for ethanol blending is 20% by 2025. Fair and remunerative price, FRP. In order to assist sugar farmers and pay off their outstanding cane debts, the union government has agreed to raise the minimum selling price, MSP, of sugar from Rs. 29 to Rs. 31 for the 2019-20 fiscal year. State-advised price. State governments have the ability to determine a state-advised price that a sugar mill must pay to the farmers even though the central government sets the FRP. Karnataka HC. Ethanol manufacturing unit cannot be established within a 15 kilometers radius of a sugar factory. As a result of legislative changes, a factory producing only ethanol is now also referred to as a sugar factory, and the law's prohibition on building another sugar factory within 15 kilometers of an already existing one still applies to such establishments, according to the High Court of Karnataka. After examining the terms of the sugarcane control order between 1966 and 2021, the court determined that starting in 2021, just the production of either sugar or ethanol was required to qualify as a factory or sugar factory for the purposes of this statute. Way forward, sugarcane mapping. Despite the importance of sugarcane in the water, food, and energy sectors in India, there are no reliable sugarcane maps for recent years and in time series. Thus, there is a need to deploy remote sensing technologies to map sugarcane areas. Innovation, research and development in sugarcane can help address the issues like low yield and low sugar recovery rates. For example, in 2016-17, a new variety of sugarcane, CO238, was developed for use in Uttar Pradesh, UP. The ethanol option. If the ethanol option, blending ethanol with petrol for use as auto fuel, is implemented properly, it will offer the required cash flow to sugar mills, ensure better prices for farmers, enhance India's energy security, and reduce pollution. Sugar pricing. In this context, the Rangarajan Committee has suggested a revenue-sharing formula to fix cane prices by factoring in the price of sugar and other byproducts. Ethanol blending program. Significance. Challenges. Energy security. India is the third largest consumer of energy in the world after China and the US. Ethanol will ensure energy self-dependency to some extent. Support for the agricultural sector. It will help the sugar mill owner to pay farmers their pending FRP for sugarcane. Ecological benefit. This fuel has the potential to reduce the harmful greenhouse gases from the atmosphere. Entrepreneurial opportunity. India is expected to need 10 billion liters of ethanol annually to meet the 20% blending target in 2030 if petrol consumption continues to grow at the current pace. Effective waste management. Bioethanol can be produced from fruit and vegetable waste, crop residues, wood pulp, animal waste, or garbage in general. Increasing farmer income. Ethanol production can diversify the source of income for the farmers. Fuel efficiency. Fossil fuels produce more energy than some of the biofuels. Unregulated emissions. The unregulated carbonyl emissions, such as acetaldehyde emission, were higher with E10 and E20 compared to normal petrol. Water use. Massive quantities of water are required for proper irrigation of sugarcane crops. Expensive. These fuels, although are cleaner, but have higher evaporative emissions from fuel tanks and dispensing equipment, thereby making them costly. Regulatory clearance. At present, ethanol production plants distilleries fall under the red category and require environmental clearance under the Air and Water Acts for new and expansion projects. Grain availability. Competition between the distilleries and the public distribution system for subsidized food grains could have adverse consequences. Facts. In the last 10 years, sugar mills have earned revenue of more than 94,000 crores from sale of ethanol, which has added to the bottom line of sugar mills. Production of ethanol has led to proportionate reduction in the import of petroleum or crude oil, which has resulted in saving of foreign exchange for India. In 2022-23, with production of about 502 crore liters of ethanol, India has saved about 24,300 crores of foreign exchange and improved India's energy security. Way forward, making vehicle manufacturers future-ready. The industry and petrol pump should be made ready for the next pushes like E85 and E100 refocus on ethanol made from waste. India has a real opportunity here to become a global leader in sustainable biofuels policy if it chooses to refocus on ethanol made from waste. Water-friendly crops. The new ethanol policy should ensure that it doesn't drive farmers toward water-intensive crops and create a water crisis in a country where its shortage is already acute. Government has aimed to double the growth rate of the manufacturing sector by 2022, which requires foreign investment, promotion of the latest technologies like Industry 4.0, and effective implementation of government schemes. India is bestowed with a potential demographic dividend. Structural reforms in economy and infrastructure development accompanied by skilled human capital would form a win-win situation to accomplish the goal of Atmanirbhar Bharat. Tertiary sector. Tertiary activities are related to the service sector. The majority of tertiary tasks are carried out by consultants, professionals with formal training, and a skilled workforce. The tertiary sector offers a wide range of services, including travel, banking, insurance, education, trade, transportation, and communication. Instead of dealing with raw resources, it deals with finished and final commodities. Facts. India is the 15th largest country in the world in terms of services output. Employment. This sector provides employment to 23% of the workforce and is the fastest growing sector, with a growth rate of 7.5% in 1991 to 2000. Tertiary sector depends on scientific research and innovative developments to increase productivity. Developed countries employ more than 80% of the services sector. Service sector accounts for around 60% of the total size of the economy, about 38% of total exports and 2/3 of the total FDI inflows into India. The services sector is the largest sector of India. Gross value added, GVA, at current prices for the services sector is estimated at 146.35 lakh crore INR in 2023 to 24. The services sector accounts for 54.86% of India's GVA of 266.78 lakh crore Indian rupees. With GVA of Rs. 73.50 lakh crore, the industry sector contributes 27.55%. Global exports. Share of the Indian service sector in global services exports is expected to increase from 3.3% to 4.2% for 2022. Significance of Indian services sector challenges. Robust demand. India has emerged as an export hub for software services. The Indian software industry is expected to reach $1 trillion by 2030. Employment. It provides employment opportunities to 25% of the labor force of India. Tourism, healthcare, education. E.g. healthcare tourism and yoga tourism are attracting global tourists due to increased recognition of Ayurveda, Hatha Yoga, Vipassana, etc. competitive advantage. India's highly skilled manpower and demographic dividend available at low cost has attracted BPO, KPO, business processing industries India. Policy support. Government efforts on focusing Make in India, Digital India initiatives, and expanding India's entrepreneurship across all service sectors. Communication. Emerging edtech companies like BYGU's Unacademy benefited from revolution in communication services are seen as sunrise industries. Skill gaps and workforce development. There is a significant gap between the skills possessed by the workforce and the skills demanded by the service sector. Infrastructure deficiencies. While there is progress, many areas still lack robust digital infrastructure, affecting sectors like IT, e-commerce, and telecommunication. Regulatory and policy hurdles. Navigating through India's regulatory framework can be cumbersome, with complex and often changing laws impacting businesses. Competition and market saturation. Sectors like IT and retail face intense competition, both domestically and globally, putting pressure on prices and margins. Technological disruption. Rapid technological changes. Constant advancements in technology require service providers to continuously innovate and adapt, which can be resource-intensive. Quaternary sector knowledge-based industries knowledge-based and requiring particular knowledge and technical abilities. This area of the service sector is knowledge-oriented. Significance challenges. Innovation. The knowledge-based industry uses modern information and communication technologies principles, innovation and research, specialized skills to create, disseminate, and apply knowledge. At Industry 4.0, with the advent of newer and advanced technologies like artificial intelligence, AI, machine learning ML, and Internet of Things, I0T, conventional manual jobs would easily get replaced. Labor-intensive. The Indian economy is still a labor-intensive economy. India has a huge amount of unskilled laborers and untrained workers. The knowledge industries will need education and skill impartation to the majority of people. Lack of skilled professional. Due to discrepancies in the Indian education system, the newer jobs requiring specialized skills will be created. IT sector. India, with the onset of globalization, having a youth population and massive growth in the IT sector makes it a strong candidate to usher in the knowledge-based industry. Enhancing income. With increase of knowledge-based industry share in the economy, India is likely to rise over the problems of middle income trap and income inequality. Knowledge industry doesn't have the right amount of highly skilled professionals mainly because of lack of skill-based training and academics focused on rote learning rather than thinking abilities and innovation. Problem of unemployment. Knowledge-based industries are likely to cause problems like unemployment as it would only create high-skilled jobs. Quinary sector. It includes creation, rearrangement, and interpretation of ideas, data interpretation, business analysis, critical thinking, evaluation, and upgradation of new technologies. The term gold collar is frequently used to describe senior company executives, government officials, research scientists, financial and legal experts, and other professionals in this group. Sector includes senior business personnel, CEOs, MDs, scientists, higher government officials, financial and legal experts, etc. Way forward. Significant challenges. Employment. Though the share of employment in the Canary sector is low, the growth of this sector ensures employment generation in other sectors which are skilled, semi-skilled, or unskilled. E.G. Growth of entrepreneurs would create more enterprises creating new jobs. The sector ensures the pace of technological advancement, which directs the economic growth of the nation. High share in GDP. The sector provides employment to highly skilled professionals, thus share in employment generation is very low at the same time contributing to GDP is very high due to the high value and specialized services provided by them. Knowledge house. The sector includes highly qualified and intellectual professionals. Their guidance and knowledge sharing helps to reap dividends from newer generations. E.g. knowledge transfer from veteran doctors helps their juniors to bring out the best doctors. In developed countries, the Canary sector is highly evolved and engaged in research and innovation. E.g. Design and development of electric cars. Poor education. The quality of education in the country decides the quality of the Canary sector in the country. Poor quality of higher education. It compels much of the talent visiting foreign universities. They carry out their research works outside of India. Such exports of Indian talent must be retained in the country. E.g. many MNCs in the world have Indian CEOs. Sundar Pichai is CEO of Alphabet Inc. Poor innovation. The research and development ecosystem in India is very poor and the quality of innovation is secondary to global innovations. Entrepreneurship efforts. In India, entrepreneurship efforts are only concentrated in the IES sector. Agriculture, automobile, electronic sectors are not explored by new entrepreneurs. These sectors are lagging behind in achieving their real potential. Policy absence. Government efforts are not targeted to boost this sector. The national policy to promote the Canary sector has not been formulated yet. Increasing budgetary allocation to the education system. There is a need to bring change in the attitude of students. They must be inspired to create jobs rather than finding a job. Promotion of innovation culture since early education. Promotion of PhD and R&D by providing stipends and provision of advanced laboratories and world-class instruments. Diversification of entrepreneurship through incentives to other areas, agriculture, electronics, etc. Conclusion. The various sectors of the economy, primary, secondary, tertiary, quaternary, and canary, play distinct but interconnected roles in shaping the economic landscape. Understanding these sectors helps in comprehending how resources are extracted, transformed, and utilized to provide goods and services. It also highlights the evolving nature of economies as they transition from primary-based activities to more advanced, service-oriented, and information-driven processes. Analyzing these sectors provides valuable insights into economic development, employment trends, and global trade patterns, enabling better policymaking and strategic planning for sustainable growth and development. Keywords: primitive subsistence agriculture, intensive subsistence agriculture, plantation agriculture, mixed farming, climate-resilient practices, climate-resilient agriculture, climate-smart agriculture, cooperative farming, organic farming, zero-budget natural farming, collective farming, feminization of agriculture, red-collar jobs, hidden unemployment, disguised unemployment, etc. Previous year question. Discuss the factors for localization of agro-based food processing industries of Northwest India. 2019. What is the significance of industrial corridors in India? Identify industrial corridors. Explain their main characteristics. 2018. Why did the Green Revolution in India virtually bypass the eastern region despite fertile soil and good availability of water? 2014. Do you agree that there is a growing trend of opening new sugar mills in the southern states of India? Discuss with justification. 2013. Analyze the factors for highly decentralized cotton textile industry in India. 2013. Q&A Bank. General Studies 2. 1,000 plus UPSC PYQ-based questions. Topic: Why subject compilations. Comprehensive answers with model approach. Mains Wallah 9 minerals, and energy resources. Minerals are naturally occurring inorganic substances found in the Earth's crust. They possess a distinct chemical composition and a highly ordered atomic arrangement, resulting in a crystalline structure. These substances can consist of single or multiple elements and exhibit a wide range of forms, colors, and hardness levels. Minerals are characterized by their unique physical and chemical properties, making them invaluable in various industries and daily life. For example, quartz is widely used in electronics and watches, while gypsum is a key ingredient in construction materials. Recent advancements in mineral extraction and processing technologies continue to enhance their applications, driving innovation and economic growth. Fact-wise, as of 2024, the mining sector in India continues to contribute around 2.2% to 2.5% to the country's gross domestic product, GDP. When considering the total industrial sector's GDP, the mining industry contributes around 10% to 11%. Types of mineral resources. Ferrous minerals. Iron ore. India has the largest reserve of iron ore in Asia. The two main types of ore found in India are hematite and magnetite. About 95% of the total reserves of iron ore is located in the states of Odisha, Jharkhand, Chhattisgarh, Karnataka, Goa, etc. The total value of metallic minerals produced in FY23 reached approximately 132,747 Indian rupees crore. Manganese. Manganese deposits are found in various geological formations and are primarily associated with the Dharwar system. Leading producers of manganese are Odisha, Karnataka, Telangana, Goa, and Jharkhand. The production of manganese, ore at 2.70 million tons in 2021 to 22, decreased by about 0.27% compared to that in the previous year. Non-ferrous minerals. Bauxite. India ranks fourth in the world in terms of bauxite reserves. It is mainly found in tertiary deposits and associated with laterite rocks. Major producers of bauxite are Odisha, Jharkhand, Gujarat, and Chhattisgarh. The production of bauxite at 22.49 million tons in 2021 to 22 decreased by 10.37% compared to the previous year. Copper. Copper deposits are mainly found in Jharkhand, Madhya Pradesh, and Rajasthan. Copper is essential in the electrical industry for manufacturing wires, motors, transformers, and generators. The production of copper concentrate at 114.42 thousand tons in 2021 to 22 increased by about 5.25% as compared to the previous year. Non-metallic minerals. The value of production of non-metallic minerals at 10,606 rupees crore during 2021 to 22 increased by 14.83% as compared to the previous year. Mica. Mica is an important non-metallic mineral used in the electrical and electronic industries. It is found in states like Jharkhand, Andhra Pradesh, Telangana, etc. Other non-metallic minerals. Limestone, dolomite, and phosphate are minerals in India. Distribution of key mineral resources in India. Mineral belts in India. India is geologically rich and has several mineral belts across the country. These mineral belts are regions that are known for their significant mineral deposits. Belts. Area region potentials. The Northeastern Peninsular Belt. This mineral belt extends from the Aravalli Range in Rajasthan in the west to the Chotanagpur Plateau in Jharkhand and Odisha in the east. It is known for its rich deposits of coal, iron ore, copper, lead, and zinc. Coal. The region has extensive coal reserves, providing a significant source of energy for power generation and industrial use. Iron ore. The belt has substantial iron ore deposits, contributing to India's iron and steel industry. Copper, lead, and zinc. These metals have economic potential and can be extracted for various industrial applications. The Southwestern Belt. Located in the states of Karnataka, Goa, and parts of Maharashtra. This belt is known for its abundant reserves of iron ore, manganese, limestone, and bauxite. Iron ore. The region is known for its high-grade iron ore deposits, making it a crucial source for the iron and steel industry. Manganese. The belt has significant manganese reserves, which are essential for steel production and various other industries. Bauxite. The presence of bauxite ore offers opportunities for aluminium production. The Northwestern Belt. This mineral belt is spread across Rajasthan and Gujarat. It is known for its deposits of limestone, marble, gypsum, rock phosphate, lignite, and bentonite. Limestone and marble. The belt has abundant reserves of limestone and marble, which are used extensively in the construction industry and cement manufacturing. Gypsum. The region has gypsum deposits, which find applications in construction materials, agriculture, and manufacturing sectors. Bentonite. Bentonite deposits have the potential for various industrial uses, such as in drilling fluids, foundry molds, and environmental applications. The Central Belt. This belt is located in Chhattisgarh and Madhya Pradesh. It is known for its significant coal reserves, as well as deposits of iron ore, bauxite, limestone, and dolomite. Coal. The region has substantial coal reserves, contributing to India's energy needs. Iron ore. The belt has iron ore deposits, supporting the iron and steel industry. Bauxite, limestone, and dolomite. These minerals have the potential for industrial use, including aluminium production, cement manufacturing, and construction materials. The Southern Belt. Located in Tamil Nadu, Andhra Pradesh, and Karnataka. This belt is known for its rich deposits of iron ore, bauxite, and limestone. Iron ore. The region has iron ore deposits that are used for steel production. Bauxite and limestone. These minerals are utilized in aluminium production, cement manufacturing, and construction materials. The Eastern Belt. This mineral belt extends through Odisha, West Bengal, and parts of Jharkhand. It is known for its vast reserves of iron ore, coal, manganese, and chromite. Iron ore. The region has extensive iron ore deposits, supporting the iron and steel industry. Coal. The belt has significant coal reserves, contributing to India's energy requirements. Manganese and chromite. These minerals have the potential for steel production, ferroalloy manufacturing, and various industrial applications. The Western Belt. Located in Maharashtra and Gujarat. This belt is known for its deposits of manganese, bauxite, limestone, and gypsum. Manganese. The belt has manganese reserves, which are essential for steel production and other industries. Bauxite. The region offers opportunities for bauxite extraction for aluminium production. Limestone and gypsum. These minerals have potential for construction materials, cement manufacturing, and other industrial applications. Share in percent. 4.36, 13.24, 14.10, 1.45, 2.96, 2.44. Odisha, Karnataka, Maharashtra, Chhattisgarh, Jharkhand. Remaining states. Rajasthan, Madhya Pradesh. Production of minerals. During the year 2023 to 24, mineral production was reported from 19 states. Notably, around 97.04% of the total value of mineral production was concentrated in just 7 states, highlighting their significant contribution to the sector. Coal. India is one of the largest producers of coal globally. It has significant coal reserves and produces various types of coal, including bituminous, subbituminous, and lignite. Coal is primarily used for power generation, industrial processes, and as fuel in households. Iron ore. The iron ore production in India increased by -14% to an all-time high of 282 million tons, MNT, in 2023 as against 248 MNT in 2022. Bauxite. India has significant bauxite reserves and is one of the major producers of bauxite ore, which is the primary or used for aluminium production. The major bauxite-producing states in India are Odisha, Gujarat, and Jharkhand. Odisha is particularly notable for having some of the largest bauxite deposits in the country. Manganese. India is a significant producer of manganese ore, which is mainly used in the steel industry for the production of ferroalloys. Major manganese-producing states include Odisha, Maharashtra, Madhya Pradesh, and Karnataka. Limestone. India is among the top producers of limestone, which is primarily used in the cement industry. States like Rajasthan, share of states in value of mineral production 2021 to 22. Madhya Pradesh, Andhra Pradesh, and Gujarat have abundant limestone deposits. Chromite. India is one of the largest producers of chromite, which is a key source of chromium used in various industries, such as metallurgy, chemicals, and refractories. Odisha and Karnataka are the primary chromite-producing states. Scope. Revenue generation. Mineral extraction generates government revenue through royalties, taxes, and lease payments. These funds can be used for infrastructure, social welfare, and economic development. Infrastructure development. Mineral belts necessitate infrastructure development like roads, railways, ports, and power supply, facilitating efficient mineral transportation and fostering regional development. Research and exploration. Mineral belts provide research opportunities to identify new deposits, assess existing ones, and expand the mining sector through exploration and geological surveys. Mining operations. Mineral belts offer favorable geological conditions and abundant deposits, attracting mining companies to extract minerals like coal, iron ore, limestone, bauxite, manganese, and chromite. 17.34 Industrial development. Mineral deposits in the belt spur industrial development and value addition for industries like steel, cement, aluminium, power generation, and chemicals. Employment generation. Mining operations in mineral belts create employment opportunities, benefiting local communities. Skilled miners, engineers, support staff, and service providers contribute to job creation and economic growth in the region. Sustainable development. Mineral belts can support sustainable mining practices, ensuring environmental protection, community engagement, and social responsibility for long-term development while minimizing negative impacts. Challenges: environmental concerns like deforestation, soil erosion, water pollution, and habitat destruction. Regulatory framework: complying with complex regulations, obtaining permits, and meeting legal requirements is a challenge for mining companies due to the intricate regulatory framework governing the mining sector in India. A land acquisition and community displacement, infrastructure development, poses logistical and operational challenges for developing the necessary transportation networks and power supply. Technological advancements, availability and adoption of modern technologies pose challenges for smaller mining companies in remote areas in maximizing mineral extraction, minimizing environmental impacts, and adopting advanced mining technologies and equipment. Way forward: sustainable mining practices through strict environmental regulations, responsible techniques, and advanced technologies to minimize environmental impacts and prioritize community engagement and social responsibility. Strengthen regulatory framework. Streamline the mining sector's regulatory framework by integrating regulations, reducing bureaucracy, and providing clear compliance guidelines. Infrastructure development. Prioritize infrastructure development in mineral belts, including transportation, power supply, and water management. A research and development. Focus on enhancing exploration techniques, resource recovery, and developing innovative technologies for the sector's technological advancements. Capacity building and skill development. To ensure a skilled workforce adept at adopting advanced technologies, implementing sustainable practices, and promoting responsible mining. Stakeholder collaboration. This can facilitate a holistic and inclusive approach to address challenges, find common solutions, and promote sustainable development in mineral belts. India is well endowed with natural resources, particularly minerals. They serve as raw material for many industries, paving a path for rapid industrialization and infrastructural development. It, in turn, will facilitate the economy's growth to a path of sustained growth and a $5 trillion economy. It ensures the sustainable growth of the economy. Energy resources. According to the International Energy Agency, IA, energy is defined as the ability to do work or the capacity to cause change and perform tasks. Energy manifests in various forms, including kinetic energy, related to motion, potential energy, related to an object's position or state, thermal energy, related to temperature, chemical energy, released or absorbed during chemical reactions, and electrical energy, associated with the flow of electric charges. These diverse forms of energy are fundamental to numerous processes and systems in our daily lives in the broader environment. Sources of energy. Non-conventional AI sources. Conventional sources. Commercial coal, petroleum, natural gas. Non-commercial firewood, straw, dry dung. Bioenergy, solar energy, wind energy, tidal energy, energy from urban waste. Fact-wise. Energy consumption. According to the Central Electricity Authority (CEA) of India, the total energy consumption in India during the fiscal year 2023-2024 is 1,550 billion units (BU). This includes electricity consumption as well as other forms of energy like oil, coal, and natural gas. Energy mix. In terms of electricity generation, the energy mix in India includes various sources. As of 2024, the major contributors to India's electricity generation were coal, about 69%, renewable energy sources, about 26%, hydroelectric power, about 3%, and nuclear power, about 2%, according to the Ministry of Power. Renewable energy capacity. India has been actively promoting renewable energy sources. As of April 2024, India's installed renewable energy capacity reached around 144.75 gigawatts (GW), which includes solar power, 82.64 gigawatts, wind power, 46.16 gigawatts, biomass, and small hydropower, as reported by the Ministry of New and Renewable Energy (MNRE). Renewable energy sources, including large hydropower, have a combined installed capacity of 191.67 gigawatts. Sources of energy. Parameters: conventional sources of energy, non-conventional sources of energy. Definition: conventional sources of energy refer to the traditional and widely used sources for energy generation that have been in use for a long time. Non-conventional sources of energy, also known as renewable or alternative sources, are derived from natural resources that are replenished and have a minimal impact on the environment. Examples: conventional sources include fossil fuels, such as coal, oil, and natural gas, as well as conventional nuclear power. Non-conventional sources include solar energy, wind energy, hydropower, biomass, geothermal energy, and tidal energy. Major sources of power generation in India. Thermal power, generated using oil and coal. Thermal power is an important source of electricity in India. In 2023, India's coal consumption reached an estimated 23.1 exajoules, making a significant increase from previous years. Hydroelectric power. Hydroelectric power harnesses the energy of moving water to generate electricity and is a form of renewable energy. As of 2024, India's hydropower potential remains significant, with an estimated capacity of around 148,701 megawatts at a 60% load factor. Underutilized potential. India ranks 4th globally in terms of underutilized hydropower potential. Nuclear power. Nuclear power is the 5th largest source of electricity in India, following coal, gas, hydroelectricity, and wind power. As of 2024, India now operates 22 nuclear reactors with a total installed capacity of approximately 7,480 megawatts. Problems with India's power sector. Insufficient power supply. India still experiences frequent shortages and blackouts in many regions, affects industrial productivity, and hampers citizens' quality of life. Inadequate grid infrastructure. Outdated and inadequate power grid infrastructure in India leads to high transmission and distribution losses, causing inefficiencies and wastage of power. Dependency on fossil fuels. India's reliance on coal and other fossil fuels for power generation contributes to air pollution, greenhouse gas emissions, and climate change. Financial viability of power distribution companies. DISCOM's power distribution companies in India face financial distress due to transmission losses, inefficient billing systems. Pricing and tariff issues. Regional tariff disparities, cross-subsidization, and subsidies, leading to financial imbalances and hindering sector sustainability. Energy access in rural areas. Many remote villages still lack electricity connections, which hampers socio-economic development and quality of life for rural communities. Initiatives taken to resolve challenges. National Infrastructure Pipeline. The government of India has allocated Rs. 111 lakh crore, $1.4 trillion under the National Infrastructure Pipeline for FY 2019 to 25. Automatic approval of 100% foreign direct investment. Ultra-mega solar power. Ultra-mega solar power projects in Rajasthan, Gujarat, Tamil Nadu, and Ladakh and J&K have been announced. Ujjwal Discom's Assurance Yojana, UDY, was launched by the government to encourage operational and financial turnaround of state-owned power distribution companies, DISCOMs, with an aim to reduce aggregate technical and commercial (AT&C) losses to 15% by FY19. Saubhagya Scheme, to achieve universal household electrification in the country. It provides free electricity connections to households below the poverty line and subsidizes connections. National Smart Grid Mission. NSGM. It aims to develop smart grids that enable efficient and reliable electricity transmission and distribution, along with integrating renewable energy sources and promoting demand response mechanisms. Energy efficiency programs, to promote energy conservation and efficiency in industries, buildings, and appliances. E.g. Perform, Achieve, and Trade (PAT) scheme in the Energy Conservation Building Code (ECBC). Green energy corridors, to facilitate the evacuation and transmission of renewable energy from resource-rich regions to consumption centers. Way forward, future prospects. The Central Electricity Authority (CEA) projects India will reach 267 gigawatts of coal-fired capacity by 2030. Promote renewable energy. Increase deployment of renewable energy sources. Upgrade grid infrastructure. Modernize power grid infrastructure to accommodate renewable energy and reduce losses. Strengthen distribution systems, reduce losses and improve billing and collection systems. Enhance regulatory framework. Implement tariff reforms and ensure financial sustainability. Focus on rural electrification. Prioritize electrification of rural areas for inclusive growth. Public awareness and education. Promote energy conservation and responsible energy consumption. Non-conventional sources of energy naturally replenished and have a significantly lower environmental impact compared to conventional fossil fuels. These sources harness energy from natural processes or phenomena and convert it into usable forms of energy without depleting finite resources or emitting large amounts of greenhouse gases. Solar power. According to the International Renewable Energy Agency, IRENA, solar power refers to the conversion of sunlight into electricity or heat using solar photovoltaic (PV) or solar thermal technologies. Fact-wise. Installed solar capacity. As of 2024, India's cumulative installed solar power capacity has reached approximately 82.46 gigawatts (GW). Solar park development. As of 2022, over 50 solar parks with a combined capacity of more than 40 GW were in various stages of development. Solar rooftop installations. As of 2024, the cumulative installed capacity of solar rooftops in India was around 11.9 gigawatts. Largest solar power plant. The Badla Solar Park in Rajasthan is one of the largest solar power plants in India. It has a total installed capacity of 2.25 gigawatts. Solar PV systems use solar panels made up of semiconductor materials to directly convert sunlight into electricity. Advantages of solar power: renewable and sustainable. Solar power relies on sunlight, is abundant, and doesn't deplete resources or produce emissions. Reduced carbon footprint. Solar power minimizes greenhouse gas emissions, combating climate change. Energy cost savings. Installing solar panels leads to significant savings on electricity bills, reducing reliance on traditional utilities. Job creation and economic growth. Solar industry creates employment opportunities and contributes to local economies. Energy independence and security. Diversifying energy sources reduces dependence on fossil fuels, enhancing security. Off-grid power supply. Solar provides electricity in remote areas without traditional grid access. Disadvantages of solar power. Intermittency. Solar power relies on sunlight availability, making it variable and requiring energy storage or backup systems for continuous supply. High initial costs. The upfront investment for solar panels and equipment can be prohibitive, potentially deterring adoption. Land and space requirements. Solar power systems need significant space, posing challenges in densely populated areas or where land is limited. Dependency on sunlight. Solar power is highly reliant on sunlight, making it unsuitable for regions with limited sun or prolonged overcast weather. Energy storage challenges. Storing excess solar energy for later use requires additional equipment, like batteries, increasing overall costs. Transmission and distribution challenges. Integration into existing grids may demand upgrades to accommodate the decentralized nature of solar power. Solar thermal systems use mirrors or lenses to concentrate sunlight and generate heat for various applications, including electricity generation, heating, and cooling. Way forward. Advancements in energy storage, research and development in battery storage and innovative solutions to address solar power intermittency. Cost reduction, technological advancements, economies of scale, and supportive policies to make solar power more affordable and accessible. Grid integration and infrastructure upgrades, smart grid technologies and transmission distribution enhancements for seamless integration of solar power. Supportive policies and incentives, government initiatives like feed-in tariffs, tax credits, and streamlined permitting processes to encourage solar adoption. Continued research and development, investment in innovation to overcome disadvantages and improve the efficiency, reliability, and widespread use of solar power. Tidal energy. Tidal energy is a form of renewable energy that harnesses the power of tidal movements in oceans and seas to generate electricity. It involves the use of tidal turbines or barges, which capture the kinetic energy of tidal currents and convert it into usable electrical energy. Fact-wise. Tidal energy potential. India has an estimated tidal energy potential of about 12,455 megawatts, MW, along its coastline. Gulf of Kutch. The Gulf of Kutch in Gujarat is considered one of the most promising sites for tidal energy development in India. Advantages of tidal power. Disadvantages of tidal power: clean and renewable, no pollution, and doesn't take up much physical space when compared to other renewable energy systems. Predictable and reliable. Most areas experience 2 high tides and 2 low tides per day. This cycle is. Environmental impact. The systems require turbulent water to power them, and a large foundation needs to be built. This type of underwater construction can result in habitat destruction. Easily predicted and isn't subject to unexpected changes, unlike many other renewable resources. Long-lasting equipment. The average estimate for most tidal systems is 75 to 100 years of working use. In comparison, a solar panel usually degrades after an average of 25 to 30 years. Effective at low speeds. Tidal energy systems can produce energy even when the water passing over or through them is moving relatively slowly. High construction costs. Building structures strong enough to withstand the turbulent, corrosive nature of seawater is by no means a cheap undertaking. Scarcity of suitable locations. Not every seascape near a shore is suitable for a tidal energy facility. It can be very inconsistent. Engineering flaws and technical errors like excessive turbine failure rates, failures in generating electricity during low water conditions, and strong currents are preventing turbines from operating properly. It is also inconsistent because it relies on the tide. Hydrogen-based energy. India launched National Green Hydrogen Mission. Objectives of the mission area: making India a leading producer and supplier of green hydrogen in the world. Creation of export opportunities for green hydrogen and its derivatives. Reduction in dependence on imported fossil fuels and feedstock. Development of indigenous manufacturing capabilities. Attracting investment and business opportunities for the industry. Creating opportunities for employment and economic development. Supporting R&D projects. The mission outcomes projected by 2030 are: the colors of hydrogen: green. Hydrogen produced by electrolysis of water, using electricity from renewable sources like wind or solar. 0 CO emissions are produced. Purple, pink. Hydrogen produced by electrolysis using nuclear power. Blue. Hydrogen produced from fossil fuels. LE, gray, black, or brown hydrogen, where CO is captured and either stored or repurposed. Turquoise. Hydrogen produced by thermal splitting of methane pyrolysis. Instead of CO, solid carbon is produced. Gray. Hydrogen extracted from natural gas using steam methane reforming. This is the most common form of hydrogen production in the world today. Brown-black. Hydrogen extracted from coal using gasification. Yellow-white. Hydrogen produced by electrolysis using grid electricity from various sources, LE, renewables, and fossil fuels. Hydrogen produced as a byproduct of industrial processes. Also refers to hydrogen occurring in its rare, natural form. O. Development of green hydrogen production capacity of at least 5 MMT, million metric ton, per annum with an associated renewable energy capacity addition of about 125 GW in the country. O over RS. 8,000,000 crore in total investments. O creation of over 6 lakh jobs. O cumulative reduction in fossil fuel imports over RS. 1,000,000 crore. O abatement of nearly 50 MMT of annual greenhouse gas emissions. Hybrid renewable energy. Hybrid renewable energy refers to the integration of two or more renewable energy sources to generate electricity. It combines different renewable energy technologies such as solar, wind, hydro, biomass, or geothermal in a complementary manner to maximize energy production, improve system reliability, and optimize resource utilization. Advantages. Disadvantages. Continuous power supply. The hybrid renewable systems provide power continuously, without any interruption, as the seasonality of solar energy can be compensated by wind power generation. Utilize renewable sources in the best way, as the batteries are connected to the system to store the energy. There is no waste of the excess energy generated on bright sunny days and days of high wind speed. Complicated controlling process. With different types of energy sources in use, the systems require some knowledge. The operation of different energy sources, their interaction and coordination must be controlled, and it can become complicated. High installation cost. The maintenance cost is low, but the initial investment for the installation of the systems is high as compared to a solar system. Less battery life. The batteries connected to the system may have a lower life as they are often exposed to natural elements like heat, rain, etc. Low maintenance cost. The maintenance cost of the hybrid renewable energy systems is low as compared to the traditional generators which use diesel as fuel. High efficiency. Hybrid solar energy systems work more efficiently than traditional generators which waste the fuel under certain conditions. The number of instruments connectable is limited. The number of devices that can be connected to a hybrid solar energy system is limited. Gas-based economy. The concept of a gas-based economy refers to an economic model that relies heavily on natural gas as a primary energy source for production, distribution, and consumption. This model encompasses the use of natural gas across various sectors, including power generation, industrial processes, transportation, and residential applications. Natural gas in India. Currently, natural gas accounts for only 6% of India's energy mix, which is significantly lower than the global average of 23%. Increasing share and future growth. The Indian government has set an ambitious target to increase the share of natural gas in the energy mix to 15% by 2030. Although India's current natural gas consumption is about one-third of the global average, it is projected to grow substantially in the coming years. Imports. India imports 55% of its natural gas in the form of liquefied natural gas, LNG, underscoring the need for enhanced domestic production and diversification of supply sources. Administration. In India, 80% of the natural gas produced by ONGC and Oil India Limited is subject to the Administered Price Mechanism (APM), meaning its price is regulated by the government. Abundance and availability. Natural gas is abundant and widely available from natural reserves. It is a key component in the transition towards cleaner energy sources due to its relatively lower carbon emissions compared to coal and oil. Properties of natural gas. Flammability. Natural gas is highly flammable, primarily due to its high methane content. Physical characteristics. It is colorless, tasteless, and odorless. An odorant is usually added to natural gas for leak detection. Density. Natural gas is less dense than air, allowing it to dissipate quickly in the event of a leak, which reduces the risk of hazardous accumulation. Corrosiveness. Due to its high methane and low carbon composition, natural gas is less corrosive than other fossil fuels. Advantages of natural gas. Disadvantages of natural gas. Natural gas is environmentally clean because, unlike other gases, natural gas emits very less byproducts into the atmosphere as pollutants. It is economical. It is not as expensive as other burning fuels. It is convenient for cooking or electric purposes. It can be directly connected to the consumer's house with the help of pipelines. Natural gas is safe to use. Natural gas is lighter than air. In case of a leakage, it dissipates quickly into the air, avoiding fire. It is available abundantly. As per the study, the amount of natural gas available is more than crude oil or other such products. Natural gas is easy to deliver. Considering the current mode of delivery of gas to homes in India, a lot of metal cylinders changing hands. To deliver natural gas, there is a need for a network of pipes. Limited quantities. India does not have vast reserves of natural gas. Most of the natural gas that is consumed by the country has to be imported from other countries. Natural gas is highly combustible. As natural gas is odorless, it is difficult to detect leakage as well. Natural gas is a non-renewable source of energy. Experts state that natural gas will be depleted in the future, and we will have to import it from other nations. Natural gas emits carbon dioxide. It emits carbon dioxide, which is bad for our atmosphere. The constant introduction of carbon dioxide into the atmosphere will lead to climate change and also global warming. Long processing process. As natural gas has other components that have to be removed before using it for residential or commercial purposes, it takes a lot of time and manpower to process it. Leakage. Even though it is lighter than air and can disperse easily, a big danger with natural gas is that since it is colorless, odorless, and tasteless, should it start leaking, detection of the leak is very hard. Agriculture 12%. Bricks 6.51%. Imation 8.72%. Roads and embankments 13.02%. Others 15.84%. Fly ash utilization. Mine filling 6.76%. Despite all these disadvantages, natural gas is one of the cheapest and easily available fossil fuels in this world. It can be considered that natural gas can serve as a viable alternative to other fossil fuels till such time as something more efficient can be found. Fly ash. Advantages. Fly ash is an unwanted unburnt residue of coal combustion in a coal thermal power plant. It is emitted along with flue gases during the burning of coal in a furnace and collected using the electrostatic precipitators. The fly ash collected with the help of precipitators is converted into a wet slurry to minimize fugitive dust emissions. It is then transported to the scientifically designed ash ponds through slurry pipelines. Fly ash is an unwanted unburnt residue of coal combustion in a coal thermal power plant. It is emitted along with flue gases during the burning of coal in a furnace and collected using the electrostatic precipitators. The fly ash collected with the help of precipitators is converted into a wet slurry to minimize fugitive dust emissions. It is then transported to the scientifically designed ash ponds through slurry pipelines. In terms of usability in concrete and cement, it provides higher ultimate strength, increased durability, improved workability, etc. In terms of usage as fly ash bricks, it reduces excavation of clay, low cost of brick as compared to clay brick of same quality, etc. Other benefits of using fly ash. O reduces soil erosion by replacing topsoil as ingredients for most construction mixes. O reduces pollution measures by reuse of wastes. O reduces the amount of greenhouse gases being added to the atmosphere. O hydrophobic nature helps in the proper draining off of water from roads and structures. Environmental problems. Groundwater contamination. Fly ash obtained after the combustion of coal that resulted in enhanced concentrations of elements, such as arsenic, barium, beryllium, etc. Ecology. Fly ash dust can be deposited on topsoil, increasing the pH and affecting the plants and animals in the surrounding ecosystem. Health hazard. Fly ash contains trace concentrations of heavy metals, such as cadmium, barium, chromium, copper, lead, mercury, etc., that are detrimental to health. Lithium reserves. According to the researchers at the Atomic Minerals Directorate for Exploration and Research, AMD, Department of Atomic Energy, Government of India, potential lithium reserves have been found in the Mandya district, Karnataka. The discovery is significant since the reserve is being touted as the country's single largest source of lithium, an element that is increasingly finding applications in battery technology used in electric vehicles. Previously, India has discovered substantial lithium reserves in the Risi district of Jammu and Kashmir, amounting to approximately 5.9 million tons. Challenged with lithium mining. Impact on the fragile Himalayan ecosystem. The Himalayas, being a fragile and eco-sensitive region, are susceptible to long-term negative effects resulting from unplanned development activities. Biodiversity loss. Mining operations in the Himalayan region, including the area between J and K, can lead to significant biodiversity loss. The unique ecological diversity of the region could be adversely affected by mining activities. Adverse environmental impact. Extraction of lithium from its or leads to environmental consequences, including water, soil, and air pollution. The extraction process is highly water-intensive, requiring approximately 2.2 million liters of water per ton of lithium. Effect on river systems. The Himalayas serve as the origin for numerous rivers, making any mining activity a potential threat to the entire riparian ecosystem. The pollution resulting from mining operations can have far-reaching consequences on the river systems. Food security concerns. Mining and processing of lithium can pose risks to food security due to high carbon emissions, water consumption, and land use methods. Countries like Chile, where large amounts of water are required to yield 1 ton of lithium, highlight the potential impact on water resources. Offshore wind energy. Offshore wind energy involves the installation of wind farms in bodies of water, typically the ocean. These farms harness the strong, consistent sea winds to generate electricity. Offshore wind farms can employ either fixed foundation turbines anchored to the seabed or floating wind turbines, which are suitable for deeper waters. This technology takes advantage of the vast wind resources over open water to produce renewable energy, contributing significantly to the reduction of greenhouse gas emissions and the diversification of energy sources. Benefits. Offshore wind energy. Limited availability of land. In India, where land is limited and the population is increasing, large wind farms positioned over water bodies will be vital. Efficiency. Wind speed over water bodies is high and consistent in direction. As a result, offshore wind farms generate more electricity per installed capacity. Consistent energy generation. As the offshore wind is stronger during the daytime, it ensures a more consistent and efficient electricity generation when consumer demand is at its highest. Long operating hours. Offshore wind power allows for longer operating hours due to its higher capacity utilization factor, CUF, than that of onshore wind farms. Energy security and diversification. Developing offshore wind power helps diversify India's energy mix, reducing dependence on fossil fuels and enhancing energy security. It provides a reliable and indigenous source of electricity, reducing reliance on imported fuels. Infrastructure development. Offshore wind projects necessitate the establishment of infrastructure such as ports, transmission networks, and grid interconnections. Challenges of offshore wind energy. High cost of generation. Offshore wind tariffs in India are likely to range between 7 to 9 rupees per unit as compared to Rs 2.8 to 2.9 per unit for onshore wind. Offshore wind farms require high maintenance costs due to the damaging action of waves and even high winds. Lack of supporting infrastructure like local substructure manufacturers, installations vessels, and trained workers. Higher installation cost of offshore wind turbines due to the requirement of stronger structures and foundations than onshore wind farms. Recommendations on offshore wind energy development in India. Renewable purchase obligation. Government-specified obligated entities such as power distribution companies. Open access consumers and captive users can purchase clean energy as part of their total electricity consumption through a renewable purchase obligation. Lower taxes. In India, the GST law exempts electricity and power sales from GST. In contrast, wind power generation companies cannot claim input tax credits when they pay GST to purchase goods and/or services for setting up the project. Feed-in tariff. Discoms can adopt feed-in tariff (FIT) regulations and make it mandatory to procure offshore wind power. Offshore wind power in the early stages of development can be promoted through FIT until it becomes economically viable. Deemed generation provision. Offshore wind projects need protection against curtailment concerns due to the inability of state load dispatch centers (SLDCs) to absorb possibly generated large quantities of power. For this, the offshore wind can be given a deemed generation provision. Frame a visionary policy, articulate clear objectives to reduce costs and ensure long-term security regarding off-taker risks. Keywords: conventional and non-conventional sources of energy. Energy basket. Gas-based economy. Electric power. Thermal power. Waste to wealth. High and low ash content. Hydroelectric power. Underutilized potential. Alternative system of storage. Nuclear power. Transmission and distribution losses, etc. Previous your question. Comment on the resource potentials of the long coastline of India and highlight the status of natural hazard preparedness in these areas. 2023. Discuss the natural resource potential of the Deccan Trap. 2022. Examine the potential of wind energy in India and explain the reasons for its limited spatial spread. 2022. Discuss the multidimensional implications of the uneven distribution of mineral oil in the world. 2021. Despite India being one of the countries of the Gondwana land, its mining industry contributes much less to its gross domestic product, GDP, in percentage. Discuss. 2021. Account for the present location of iron and steel industries away from the source of raw material by giving examples. 2020. India has immense potential for solar energy, though there are regional variations in its developments. Elaborate. 2020. Why is India taking a keen interest in the resources of the Arctic region? 2018. How does India see its place in the economic space of rising natural resource-rich Africa? 2015. Account for the change in the spatial pattern of the iron and steel industry in the world. 2014. With the growing scarcity of fossil fuels, atomic energy is gaining more and more significance in India. Discuss the availability of raw materials required for the generation of atomic energy in India and in the world. 2013. It is said that India has substantial reserves of shale oil and gas, which can feed the needs of the country for a quarter century. However, tapping the resources doesn't appear to be high on the agenda. Discuss critically the availability and issues involved. 2013 UPSC Offline Foundation Course, based on CTR model. GS classes, optional classes, *CSAT classes, *24/7 library. Many other relevant features. With 3 years validity. PW0AS 500. For extra discount. Starts from 947-200. Apply coupon code. Our offline centers. Ethics and Essay Crash Course 2024, 60+ hours. Ethics discussion and questionnaires or Form AT. 2 ethics and 2 essay full-length tests W with evaluation. K. Theme-wise essay coverage, age evaluation by faculty. Coverage of 150+ ethics and 50+ essay questions. ONE doubt sessions W with faculty. Batch starts 24th June for extra discount. 992-061-3613 OnlyIAS. Com10 water resources and their management in India. India, home to 18% of the world's population, has access to only 4% of the global freshwater resources. The primary source of freshwater is the monsoon, which delivers an average annual rainfall of 4,000 billion cubic meters, BCM, or approximately 1,170 millimeters. Monsoon dependency: the majority of Indian states are heavily reliant on the monsoon season to meet their water needs. Regional disparities: while some northern states enjoy an abundance of water resources, others, such as Rajasthan, Maharashtra, and Tamil Nadu, face significant water deficits. These disparities highlight the critical need for effective water management and distribution strategies across the country to ensure sustainable access to this vital resource. Constitutional provision: 7th Schedule. Central List. Entry 56 of List I. Regulation and development of interstate rivers are under the competence of the Union and are deemed necessary in the public interest by Parliament through legislation. State List. Entry 17 of List 2. It adds water to the state list, along with water sources, canals for irrigation, drainage systems, water storage, and water power. Water Scarcity Falkenmark Index. According to it, if a nation's annual renewable water use per person is water stress, the country is reportedly experiencing water stress if the volume is under 1,700 cubic meters. Water shortage. It is believed to have a water shortage below 1,000 cubic meters. Water scarcity. Below 500 cubic meters, there is water scarcity. Day 0. The day when a city's taps dry out and people have to stand in line to collect a daily quota of water. International case: South Africa and Cape Town. The prospect of Day 0, or the day the water will run out, existed between 2016 and 2018. Indian case: Chennai, one of India's major cities facing an acute, unprecedented water shortage and witnessing urban floods alternately. Water Resource Management, WRM. The World Bank defines WRM as the process of planning, developing, and managing water resources in terms of both water quantity and quality across all water uses. It includes the institutions, infrastructure, incentives, and information systems that support and guide water management. It also entails managing water-related risks, including floods, drought, and contamination. Fact-wise, water availability per person in India was 5,177 cubic meters in 1951, but it has since fallen to 1,545 cubic meters in 2011 and is predicted to fall even lower to 1,300 cubic meters by 2030. According to NITI Aayog, a government think tank, 20 more cities, including Bengaluru, Delhi, and Hyderabad, would run out of groundwater in the next years if strategies for water conservation in India were not followed. SDG 6. Ensure access to water and sanitation for all. Access to safe water, sanitation, and hygiene is the most basic human need for health and well-being. Need of water management in India, NITI Aayog. In June 2018, NITI Aayog released a report titled Composite Water Management Index, CWMI. Close to 600 million people were experiencing high to extreme water stress. 200,000 people were dying annually as a result of insufficient access to safe water. About 70% of its water being contaminated. India was ranked 120th out of 122 nations in terms of water quality. Central Groundwater Board. According to the most recent Central Groundwater Board data from 2017, as many as 256 of India's 700 districts have declared critical or overexploited groundwater levels. Uneven distribution. Large portions of India continue to lack rain and groundwater due to the uneven distribution of water. Demand for urban areas. In cities, there is a greater need for water than there is supply. Additionally, conserving water will guarantee that there will be clean water for future generations. Social and political conflicts. Water scarcity is leading to social and political conflicts at different levels of the government. Internal water crises are also a national security concern. Skewed priorities. Diversion of water towards an urban megacity at the cost of the millions living in semi-urban and rural communities in the GJ 03 surrounding regions has been a routine practice in India. Contaminated water resources. Regardless of improvements to drinking water, many other water sources are contaminated with both bio and chemical pollutants, and over 21% of the country's diseases are water-related. Cyclical rainfall. Since India's rainfall is largely cyclical, irrigation of crops requires water. Water safeguards wildlife and the ecology. Energy saving. The requirement for power supply and water-based power generation has increased along with the demand for water to a significant degree. Traditional water management practices in India. Inanati Rapat T Baris Jaloras Tobas TTT. Traditional water harvesting methods: 1 par 1 talab 1 saza kuvajohad 1 pat. Modern methods of water management. Rainwater harvesting. Collecting rainwater is a very efficient way to replenish the groundwater table and save natural water. Pressure-reducing valves. In a hydraulic system, a pressure-reducing valve essentially regulates the amount of pressure. These valves guarantee that the water level to be used is predetermined. Water metering. Installing water meters to track water usage in both residential and business buildings is another effective technique to reduce water waste. It can aid in leak detection. Gray water recycling. It is a technique for reusing used and wastewater from showers, washing machines, and kitchen sinks for things like flushing toilets and watering plants. Water-efficient accessories. New developments are pushing the limits of water saving without compromising usage patterns, such as altered spray patterns in taps and showers and enhanced flush pressure in toilets. Integrated Urban Water Management System, IUWM. IUWM is a process which ensures water supply, used water management. Sanitation and stormwater management can be planned in line with economic development and land use. Water use efficiency. It is defined as the amount of carbon assimilated as biomass or grain produced per unit of water used by the crop. It is about careful management of water supply sources, use of water-serving technologies, reduction of excessive demand, and other actions. There can be the following methods to increase water use efficiency. Micro-irrigation, water utilization efficiency. It is guaranteed by micro-irrigation to the extent of 50 to 90%. Potential. The potential for drip irrigation in India is thought to total 27 million hectares, according to the Task Force on Micro-Irrigation in India, 2004. Sprinkler irrigation. It is a method of applying water like rain. It is suited for most row, field, and tree crops. Water can be sprayed over or under the crop canopy. The sprinkler breaks up the water into droplets sized 0.5 to 4 millimeters. Drip irrigation. It has the potential to save water and nutrients by allowing water to drip slowly to the roots of plants, either from above the soil surface or buried below the surface. The goal is to place water directly into the root zone and minimize evaporation. In the drip irrigation process, water and nutrients are delivered across the field in pipes called dripper lines featuring smaller units known as drippers. Subsurface irrigation. This irrigation technique irrigates plants with water that is delivered from below the soil's surface. This micro-irrigation is effective and advantageous. It only needs a little water pressure to work correctly. Bubbler irrigation. It disperses water at a rate of about 230 liters per hour through little streams and fountains. It is preferred in circumstances where a lot of water needs to be applied quickly. Advantages of micro-irrigation. Helps in saving of water. Micro-irrigation can reduce water usage by 25 to 40% as compared to overhead systems and 45 to 60% as compared to surface irrigation. Uniform water application. Higher uniformity results in efficient irrigation, thereby causing less wastage of water, power, and fertilizers. Helps in saving electricity. Usually, delivery pipes and micro-irrigation systems operate at low pressure, 2 to 4 bar. Therefore, these require less energy for pumping. Improves chemical application. Micro-irrigation systems can apply chemicals to plants through fertigation units. Reduces weeds and diseases. They compete with the crops for nutrients, moisture, and sunlight, which can reduce the crop quality and the yield. Success story of Israel. A desert nation with water scarcity has become a water surplus nation because it adopted micro-irrigation practices, especially drip irrigation that saves almost 3/4 of the water used for irrigation done through open canals. Micro-irrigation in India. As of 2024, India has an average penetration of micro-irrigation, 22%, substantially lower than many other nations. Only 4 Indian states, Sikkim, Andhra Pradesh, Karnataka, and Maharashtra, have more than 50% off-tier net cultivable land covered by micro-irrigation at the moment. The remaining states have less than 15%. Even though Uttar Pradesh produces the most sugarcane, a crop that requires a lot of water, it only has 1.5%, and Punjab only has 1.2% of its area under micro-irrigation. Over the next 5 years, the government wants to cover 100 lakh acres of land with micro-irrigation. Micro-watershed development and management. A watershed is a geohydrological land unit that gathers water and empties it through a central location. The main goal of watershed management is to store and replenish groundwater using a variety of techniques, including percolation tanks, recharge wells, and artificial ponds. It's one of the most efficient methods of conserving water and managing scarce water resources with a decentralized approach. Size of the micro-watershed ranges from 100 to 1,000 hect. So, it gives scope for adopting area-specific approaches for better water resource management. Integration of technologies. Watershed management is the integration of technologies within the natural boundaries of a drainage area for the optimum development of land, water, and plant resources to meet the basic needs of the people and animals in a sustained manner. Classification of watershed, based on size. O macro watershed, greater than 50,000 hect. O subwatershed, 10,000 to 50,000 hect. O milli watershed, 1,000 to o hect. O micro watershed, 100 to 1,000 hect. O mini watershed, 1 to 100 hect. Benefits of micro-watershed management. Increased water use efficiency for agriculture with methods like drip irrigation and sprinkler irrigation. Prevention of soil erosion. It also helps in preventing soil erosion, planting trees in the wastelands, groundwater reaching, and conservation of soil moisture. Improves quality of life. Micro-watershed management helps in improving the quality of life of the drought-prone region by the increased availability of water both for drinking and irrigation purposes, e.g., women and girls will not have to trudge longer distances for fetching water. Corresponding development in vegetation. Increasing the vegetation occurs in semi-arid regions by rational utilization of water resources. For drought-prone areas, sort out the problem of water scarcity and drought. Micro-watershed projects can prevent unwanted evaporation by increasing the biomass component of the area. Restoration of natural water resources, like ponds, lakes, etc. Infrastructure development. It leads to the development of infrastructures like tanks, artificial ponds, check dams, etc. to store the rainwater and increase the moisture level of the soil. Government steps for water resource management. Jal Shakti Ministry, formed in 2019 by integrating earlier two water-related ministries for water management in the country. Swajal scheme. It is designed as a demand-driven and community-centered program to provide sustainable access to drinking water to people in rural areas. It encourages partnership between village communities, NGOs, and the government as the facilitator. Jal Jeevan Mission, 2019, to provide piped potable water to every rural household by 2024. In the past year, the Jal Jeevan Mission Interlinking of Rivers project, to ensure greater equity in the distribution of water by enhancing the availability of water in drought-prone and rain-fed areas. Atal Bhujal Yojana, ABHY, launched in 2019 to improve the management of groundwater resources in selected states. PM Krishi Sinchay Yojana, to improve farm productivity and ensure better utilization of the resources in the country, i.e., per drop, more crop. National Water Mission, to ensure integrated water resource management, helping to conserve water, minimize wastage, and ensure more equitable distribution both across and within states. Case study, Anmol Jeevan Abhiyan. The Anmol Jeevan Abhiyan Precious Life Campaign is a recent project in Barmer, Rajasthan that has inspired rural panchayats and property owners to upgrade tanka structure by adding hand pumps and locking lids. It has pushed house owners and village panchayats to structurally upgrade their tankas with hand pumps and locking coverings. International initiatives. Initiatives about UN Water Conference and worldwide gathering called the UN Water Gathering tries to better coordinate government, business, nonprofit, and funding initiatives around a few key water sector concerns. It provides a platform for nations to invest, transfer technology, and learn from the mistakes of others. Universal Declaration of the Rights of Rivers. The Declaration is a civil society project to outline the fundamental rights to which all rivers are entitled. A significant change away from an extractive worldview and towards one in which conservation safeguards are being extended to nature is being heralded by the global trend of providing rights to nature. Why ahead for water resource management, Arth Ganga model. New government model for the river's sustainable development. The Arth Ganga model's fundamental goal is to connect people with the river through the economy. It aims to provide at least 3% of the GDP from within the Ganga basin. Interventions made as part of the Arth Ganga project are in line with India's commitments to the Unsustainable Development Goals. Water management needs a hydrosocial approach. The relationship between social vulnerability and changes to water systems was underlined in the IPCC's Fourth Assessment Report, 2007. Globally, it is predicted that if current trends continue, the difference between freshwater demand and supply might increase to 40% by 2030. The right valuation of water is stressed in the UN World Water Development Report, 2021, which takes 5 viewpoints into account. Holistic water management system. Water consumption has grown significantly as cities have expanded quickly. Water scarcity and depletion are major problems that will soon confront people, even as desires drive people to move to metropolitan areas. In order to assure that the majority of metropolitan areas can be self-sufficient in the future, water management needs to undergo a revolution. India's Water Vision Roadmap for a Sustainable Future. A government program called India's Water Vision aims to provide all Indians with access to clean, safe water. The initiative also emphasizes water resource preservation and the advancement of sustainable water practices. River Cities Alliance. It provides the member cities with a platform to discuss and exchange information on aspects that are vital for sustainable management of urban rivers. Draft Water Policy. This national water policy, and WP, strive for a multidisciplinary, multi-stakeholder approach to water management. Objectives. It aims to promote a circular economy of water through the development of the City Water Balance Plan for each city, focusing on recycling, reuse of treated sewage, rejuvenation of water bodies, and water conservation. It focuses on making the cities self-reliant and water secure. Mission targets the provision of 2.68 crore tap connections to achieve the intended outcomes. Need of new water policy. Increasing demand. Recent estimates suggest that if the current pattern of demand continues, about half of the national demand for water will remain unmet by 2030. Declining water availability by 2050. Water availability is set to worsen, with the average annual per capita water availability estimated to fall by 37% by 2050. Water stress scenario. India is the largest extractor of groundwater in the world. Nearly 600 million Indians face high to extreme water stress, falling water table, and deteriorating water quality. This has made the need of the hour to shift towards a water management approach. Salient features of policy. Supply-centric approach. The policy emphasizes a shift away from a supply-centric approach to the management of demands. For example, crop diversification. Reduce, recycle, reuse approach. This approach has been proposed for the integrated urban water supply and decentralized wastewater management, with the treatment of sewage and eco-restoration of urban river stretches. Channelizing of supply-side options. By utilizing water stored in big dams, the irrigated area could be greatly expanded at a very low cost by deploying pressurized closed conveyance pipelines, combined with supervisory control and data acquisition, SCADA, systems, and pressurized microirrigation. Nature-based solutions. The policy focuses on the supply of water through nature-based solutions, such as the rejuvenation of catchment areas, to be incentivized through compensation for ecosystem services. National Water Commission. Creation of a unified multidisciplinary, multi-stakeholder National Water Commission, NWC, which would become an exemplar for states to follow. Use of indigenous knowledge. Techniques of water management of our people is an invaluable intellectual resource that must be fully leveraged. Dam Safety Act, 2021. The Dam Safety Act of 2021 mandates comprehensive surveillance, inspection, operation, and maintenance protocols for all specified dams across India to ensure their safe and effective functioning. The legislation aims to mitigate risks associated with dam failures, enhance structural integrity, and protect downstream communities by implementing stringent safety measures and regular monitoring procedures. Features: National Dam Safety Authority, NDSA. It provides for the formation of an NDSA, which will be responsible for implementing the policies of the NCDS and will resolve issues between state dam safety organizations, or SDSOs, and dam owners. State Dam Safety Organizations, SDSOs. The Act will also result in the establishment of SDSOs and State Committees on Dam Safety, SCDSs. The jurisdiction of the SDSOs will extend to all dams in that specific state. National Committee on Dam Safety. The Act provides for the constitution of a National Committee on Dam Safety, NCDS, which is to be chaired by the Central Water Commissioner, CWC. Surveillance Offims. It provides for the surveillance, inspection, operation, and maintenance of all specified dams across the country. Provision for penalty. The Act provides for stringent penalties in case of violations, including 2 years of jail term. Significance of the Act brings uniformity. The government wants that there should be a uniformity of procedures which is followed by all dam owners for a particular type of large dam. Provide strict guidelines. Water is a state subject, and the Act has also provided authority to the state. The Act provides guidelines and a mechanism to ensure that the guidelines are followed. Ensure quality. The Act provides a mechanism where accreditation of the people who are really going to take part in the construction and maintenance has to be taken care of. Security. Dams are prone to damage, and therefore their safety is very important. The Act provides for the formulation of dam safety standards. Conclusion. It is necessary to come up with new ideas for improved urban water management because population expansion and climate change are increasing water usage. The difficulties need to be made more widely known to more people in various local contexts. Similar adjustments are necessary for organizations like regional departments that have a significant impact. In order to address water challenges, comprehensive and systemic solutions must be put into practice. Keywords: unprecedented water shortage, water scarcity, floods and droughts, depletion of groundwater, impact of water scarcity, water pollution, pesticides use, polluted rivers, unscientific cropping pattern, destruction of wetlands and lakes, groundwater contamination, water resource management, judicious allocation of water, preventing unsustainable exploitation, need for behavioral change, water as a common pool, developing water protection zones, etc. Previous your question. Why is the world today confronted with a crisis of availability of and access to freshwater resources? 2023. What are the environmental implications of the reclamation of the water bodies into urban land use? Explain with examples. 2021. The interlinking of rivers can provide viable solutions to the multidimensional interrelated problems of droughts, floods, and interrupted navigation. Critically examine. 2020. How will the melting of Himalayan glaciers have a far-reaching impact on the water resources of India? 2020. What is water stress? How and why does it differ regionally in India? 2019. The ideal solution of depleting groundwater resources in India is water harvesting system. How can it be made effective in urban areas? 2018. What is water use efficiency? Describe the role of microirrigation in increasing their use efficiency. 2016. Enumerate the problems and prospects of inland water transport in India. 2016. In what way do micro-watershed development projects help in water conservation in drought-prone and semi-arid regions of India? 2015. What is the economic significance of the discovery of oil in the Arctic Sea and its possible environmental consequences? 2015. India is well endowed with freshwater resources. Critically examine why it still suffers from water scarcity. 2015. Bring out the relationship between the shrinking Himalayan glaciers and the symptoms of climate change in the Indian subcontinent. 2013. Transport and communication in India. Transportation in India is a complex and diverse system that plays a vital role in the country's economy and daily life, encompassing road, rail, air, and water transport. India's aviation industry has experienced significant growth in the past 9 years. The number of operational airports in the country has doubled from 74 in 2014 to 148, including 137 airports, 2 water aerodromes, and 9 heliports in April 2023. For the fiscal year 2023 to 24, the total air passenger traffic in India is estimated to have surpassed 190 million. The number of domestic air passengers in India is expected to surge to 300 million annually by 2030. Utility of transportation in improving industrial growth, moving inputs and outputs. Transportation enables the movement of raw materials and labor to industries and delivers the final product to the consumers. Market access enables industries to tap into new markets, expanding their reach and boosting sales and revenue potential, thus driving industrial growth. Access to remote areas, for e.g. gas pipelines enable establishment of petrochemical complexes in Burani and Mathura, and taps the market in remote areas. Industrial clusters and SEZs. Strong transport infrastructure is vital for successful industrial clusters and SEZs, enabling efficient supply chains, resource sharing, and collaboration for optimal growth. Economic growth. A good transportation system is vital to attract development, which would create employment and spur economic growth. E.g., lack of transportation facilities is the main reason behind poor industrial development in resource-rich northeastern regions. Employment generation. Surface, water, and aviation sector provides employment opportunities to millions of people. Trade and export opportunities. Well-connected transport networks enable industries to access global markets, engage in international trade, and drive economic growth through increased exports and market exposure. Railway transport system. The Indian Railways is the lifeline of India. With its vast network across the length and breadth of India, it is not just a mere transporter of passengers and goods, but also a social welfare organization. India has the 4th largest railway system in the world, behind only US, Russia, and China. The Indian Railways consist of a total track length of 126,366 kilometers with 7,335 stations spanning over 68,000 kilometers. 5,243 kilometers of track length was achieved during 2022 to 23 as compared to 2,909 kilometers during 2021 to 22. By early 2024, 9,910 kilometers of new track length were commissioned out of a planned 29,147 kilometers of railway infrastructure projects. Indian Railway runs 9,000 freight trains daily, which carry around 3.05 million tons of freight. The Indian Railways has loaded 1,512 metric tons during 2022 to 23 as compared to 1,418 metric tons during FY 2021 to 22. Need for robust railway infrastructure, economic growth. Railways play a vital role in facilitating economic growth by providing an efficient and cost-effective mode of transportation for goods and passengers. Connectivity. Railways can enable people to travel easily, fostering social and cultural exchange while enhancing access to education, healthcare, and employment opportunities. Mass transportation. With a large population, India heavily relies on railways for mass transportation. A robust railway infrastructure ensures safe, comfortable, and affordable travel options for millions of people, reducing congestion on roads and highways. Freight movement. It helps in reducing logistics costs, enhancing supply chain efficiency, and supporting industries such as agriculture, manufacturing, and mining. Environmental benefits. By promoting rail travel and freight transport, India can reduce carbon emissions, alleviate air pollution, and contribute to sustainable development and environmental conservation. National Rail Plan Vision 2030. The Indian Railways has prepared a National Rail Plan, NRP, for India 2030, with the vision of creating a future-ready railway system by 2030. The key objectives of the National Rail Plan are as follows. Increase modal share of railways and freight. Formulate strategies to increase the railway's modal share in freight to 45% through operational capacities and commercial policy initiatives. Reduce transit time of freight. Substantially reduce the transit time of freight by increasing the average speed of freight trains to 50 km/h. Dedicated freight corridors. Identify new dedicated freight corridors to facilitate efficient movement of freight. High-speed rail corridors. Identify new high-speed rail corridors to enhance passenger connectivity. Rolling stock and locomotive assessment. Assess the rolling stock requirement for passenger traffic and wagon requirement for freight, as well as the locomotive requirement to meet the objectives of 100% electrification and increasing the modal share of freight. Private sector involvement in operations and ownership of rolling stock, development of freight and passenger terminals, and development operations of track infrastructure. National Rail Plan Vision 2024. As part of the National Rail Plan Vision 2024 has been launched for accelerated implementation of critical projects by 2024, including 100% electrification, multi-tracking of congested routes, speed upgradation to 160 km/h on Delhi-Howrah and Delhi-Mumbai routes, speed upgradation to 130 km/h on other Golden Quadrilateral Golden Diagonal (GQGD) routes, elimination of all level crossings on GUGD routes. Challenges of the Indian Railways passenger transport, cross-subsidization burden, and high operating ratio have prevented Indian Railways from providing high-quality services and safety features. Average speed. Average speed of railways is very low compared to railways of developed nations. Because of these reasons, the passenger crowd is shifting towards road and aviation transport. The average speed of the semi-high-speed train was 81.38 km per hour in 2022-23, whereas freight trains run at an average speed of 46.71 km per hour. Freight transport. High competition from road transport due to cheaper rates and destination-based delivery. Capacity constraints. Limited track and terminal availability hampers accommodating increasing demand, leading to full trains and reduced frequencies. Safety concerns. Accidents due to human error, track defects, and equipment failures remain a significant challenge. For instance, the Amritsar train accident in 2018. High operating cost. Indian Railways faces revenue challenges while grappling with increasing staff management expenditures, including salaries, pensions, and medical facilities, leading to financial strain. Congestion. Indian Railways faces congestion at major junctions like Mumbai and Howrah, causing delays and reduced efficiency. Government initiatives Amrit Bharat Station Scheme, 2022. It envisages the development of 1,000 small stations on a continuous basis with a long-term vision. One Nation One Card System, 2019. One Nation One Card simplifies payments and enhances convenience for travelers by enabling a single card for multiple modes of transport including trains, buses, and metro services. Kavach. India has been developing its own train collision avoidance system, TCAS, since 2012, now known as Kavach or Armor. National Rail Plan. NRP. The NRP aims to create a future-ready railway system by 2030. It includes the construction of dedicated freight corridors, e.g., Eastern and Western dedicated freight corridors, and high-speed rail corridors, e.g., Mumbai-Ahmedabad Bullet Train Project. Rail India Development Fund, RIDF, 2017. The establishment of RIDF to mobilize funds for critical railway projects, providing financial support for infrastructure development, capacity expansion, and modernization of the railway network. Dedicated Freight Corridors, DFCs. The construction of the Eastern Dedicated Freight Corridor, EDFC, and Western Dedicated Freight Corridor, WDFC, is aimed at improving freight transportation efficiency and reducing congestion on existing railway lines. Way Forward. Recommendations of Bibek-Debrode Committee on Railway Modernization, 2015, Modernization and Upgradation. Invest in modern technologies, signaling systems, and rolling stock to improve operational efficiency, safety, and passenger experience. Infrastructure expansion. Continue the development of new railway lines, dedicated freight corridors, and high-speed rail networks to enhance connectivity, reduce congestion, and support economic growth across regions. Make in India and self-reliance. Promote indigenous manufacturing and R&D capabilities in the railway sector to reduce dependence on imports. Enhancing customer experience. The report highlights the importance of improving passenger amenities, cleanliness, and overall customer experience. Roll-on roll-off model for freight transport. Implementing the roll-on roll-off model on dedicated freight corridors, DFCs, to transport loaded trucks on the rail, enhancing revenue generation and reducing carbon footprint. Commercialization and outsourcing. Exploring opportunities to commercialize railway production units and outsource medical services to streamline operations and improve efficiency. The Indian railway system plays a crucial role in the country's transportation infrastructure, with significant improvements, digitalization, skill development, and safety enhancements, while facing challenges of revenue, expenditure, and fossil fuel dependence, which are being addressed through initiatives such as the National Rail Plan, public-private partnerships, and sustainable practices. Road transport. With a vast network of roads, India has one of the largest road networks in the world, connecting rural and urban areas, facilitating trade and commerce, and enabling the mobility of people and goods. Road transport plays a vital role in India's transportation system, serving as a lifeline for both passenger and freight movement across the country. Date and facts on roads in India. Total length of the roads. India has about 66.71 lakh km of road network, which is the second largest in the world after US. Contribution to GVA. Road transport is the dominant segment in India's transport sector and contributed 3.06% to gross value added, GVA, in the year 2023-24. There are approximately 323 million registered motor vehicles in India by end of 2023. National highways, the length stands at approximately 146,145 kilometers, reflecting a 60% increase from 91,287 kilometers in 2014. Maharashtra has the largest network of national highways with 18,459 kilometers, 13.4%, followed by Uttar Pradesh and Rajasthan with 13,248 kilometers, 8.9%, and 12,000 kilometers, 7.8%, respectively, as of January 2024. State highways, as of early 2024, the total length of state highways in India stands at approximately 183,011 kilometers. Rural roads constitute 71.4% of the total road network in the country. As of January 2024, the length of rural roads was 63.45 for 03 km. The 5 states of Maharashtra, Assam, Bihar, Uttar Pradesh, and Madhya Pradesh account for 42.4% of the total rural roads in the country. Challenges: road congestion, insufficient road capacity, and inadequate traffic management contribute to congestion, leading to increased travel time, fuel consumption, and air pollution. 3 cities in India ranked in the top 10 in global traffic congestion. Poor road infrastructure. Despite the extensive road network, many roads suffer from poor quality, inadequate maintenance, and lack of proper signage and lighting. This hampers road safety, increases vehicle maintenance costs, and affects the overall efficiency of transportation. Road safety. As per annual report on road accidents in India, 2022 during the calendar year 2022, which claimed 168 for 91 lives and caused injuries to 443, 366 persons. Road user behavior, non-compliance with traffic rules, including overspeeding, improper lane usage, and disregard for pedestrian safety, adds to the challenges of road transport. Road connectivity in hilly and remote areas. Establishing road connectivity in hilly terrains, challenging geographical regions, and remote areas with difficult terrain poses unique challenges. Environmental impact. Road transport contributes to air and noise pollution, impacting both human health and the environment. Integration of transport modes. Efficient integration of different modes of transport, such as road, rail, and waterways, is essential for a seamless and multimodal transportation system. Bharatmala Pariyojana, 2017. It aims to generate employment opportunities and connect 550 districts across the country through national highway linkages. Also optimize the efficiency of freight and passenger movement in India through various interventions. The key features and components of the project include economic corridors, construction and development of around 26,200 kilometers of economic corridors to ensure seamless and speedy travel for heavy freight traffic. Feeder routes or intercorridors, development of 6,000 kilometers of feeder routes or intercorridors to address infrastructure asymmetry and improve connectivity. National corridor efficiency improvement, focus on improving the efficiency of the national corridor, including the Golden Quadrilateral and North-South and East-West corridors, through the construction of elevated corridors, bypasses, ring roads, lane expansion, and logistics parks. And under this, 800 km of national highway length was planned for development under Phase I of Bharatmala Pariyojana. PM Gati Shakti 2021. 6 pillars of the plan. 1. Comprehensiveness. Centralized portal for all existing and planned initiatives, providing critical data for comprehensive planning and execution. 2. Prioritization. Cross-sectoral interactions to help different departments prioritize projects. 3. Optimization. National master plan to identify critical gaps and select the most optimal routes for transportation. 4. Synchronization. Holistic coordination and synchronization of activities among ministries and departments to avoid delays and improve implementation. 5. Analytical. GIS-based spatial planning and analytical tools with multiple layers for better visibility and monitoring. 6. Dynamic. Real-time progress monitoring and periodic updates of cross-sectoral projects through satellite imagery. Project Parvatmala 2022. Project Parvatmala, part of the National Ropeways Development Program, aims to enhance connectivity in hilly areas using ecologically sustainable ropeway systems. Key points. It will be implemented through the PPP, Public-Private Partnership, mode. It also offers an environmentally friendly alternative to conventional roads in challenging terrains. Focuses on improving connectivity, convenience for commuters, and promoting tourism. Targeted areas. Initial focus on regions like Uttarakhand, Himachal Pradesh, Manipur, Jammu and Kashmir, and other northeastern states. Last-mile connectivity. Ropeway systems, especially those utilizing 3S, a kind of cable car system, or similar technologies, improve last-mile connectivity in hilly areas. Can transport a significant number of passengers per hour. Civil aviation. Civil aviation refers to the operation, regulation, and development of aviation activities within the country. Civil aviation in India is a rapidly growing sector, playing a crucial role in the country's transportation infrastructure and economic development. Data-wise, The Indian aviation industry contributes 5% to GDP, provides 4 million jobs, and supports 7 million jobs through tourism. In the fiscal year 2023 to 24, India's aviation passenger traffic reached approximately 190 million passengers. India ranks as the seventh largest civil aviation market globally and is projected to become the third largest by 2024. By 2036, India's total passenger traffic is expected to reach 480 million, surpassing the combined traffic of Japan and Germany. Challenges in civil aviation in India: funding and investment, mobilizing adequate funding, attracting private investment, and ensuring sustainable financial models for airport development and expansion remain challenges. Air traffic congestion. With increasing air traffic, congestion at major airports and airspace becomes a concern. This leads to delays, increased fuel consumption, and higher costs. Skill shortage. Meeting the growing demand for skilled aviation professionals, such as pilots, air traffic controllers, and maintenance engineers, remains a challenge. Safety and security. Strengthening security protocols, implementing advanced technologies, and enhancing coordination among various stakeholders are ongoing challenges. Regional connectivity. Promoting regional connectivity and accessibility to remote areas requires overcoming geographical challenges, developing smaller airports, and addressing logistical constraints. Cost structure. Managing operational costs, including fuel prices, taxes, and airport charges, is critical for the financial sustainability of airlines. Environmental impact. Aviation's environmental impact, including carbon emissions, noise pollution, and land use, necessitates sustainable practices and mitigation measures. Competition and market dynamics. Managing competition, ensuring fair practices, and facilitating a level playing field pose challenges for regulatory authorities. Government initiatives. UDN scheme. The Udesh Ka Aam Nagrik (UDN) scheme promotes affordable regional air connectivity by offering financial incentives to airlines and improving airport infrastructure. Regional Connectivity Scheme (RCS). The government launched RCS to enhance regional connectivity by reviving airstrips airports as no-frills airports and offering affordable airfare. National Civil Aviation Policy. The government introduced the National Civil Aviation Policy in 2016, aiming to promote tourism, employment, and balanced regional growth. Open Sky Agreements. The government entered into open sky agreements with SAARC countries and countries beyond 5,000 kilometers from Delhi, promoting international air connectivity. Skill development initiatives. The government supports T organizations for skill development and provides budgetary support for the type rating of pilots. Make in India. The Make in India initiative encourages domestic manufacturing and assembly of aircraft, aircraft components, and maintenance, repair, and overhaul (MRO) facilities. Krishi Udaan. The government launched the Krishi Udaan scheme in 2019 to boost agricultural exports by providing air transportation for perishable agricultural products from small towns to international markets. Green initiatives. The government promotes eco-friendly practices in aviation, including incentives for MRO activities, land allocation for MRO service providers, and VAT zero rating on MRO activities. Reforms under Atmanirbhar Bharat Abhiyan. Efficient airspace management for civil aviation. The Indian government plans to ease restrictions on the utilization of airspace to enhance the efficiency of civilian flying. The expected benefits include an estimated annual gain of about 1,000 rupees crore for the aviation sector. The optimization of airspace will lead to reduced fuel consumption, decreased flight time, and positive environmental impacts. India's global hub for aircraft maintenance, repair, and overhaul, MRO. The tax regime for the MRO ecosystem has been rationalized to promote growth. Over the next 3 years, there is an expected increase in aircraft component repairs and airframe maintenance from Rs. 800 crore to Rs. 2,000 crore. Major engine manufacturers worldwide are anticipated to establish engine repair facilities in India. Additionally, efforts will be made to create a convergence between the defense sector and civil MROs to achieve economies of scale and reduce maintenance costs for airlines. Shipping and inland waterways. Shipping and inland waterways play a vital role in India's transportation network, facilitating the movement of goods and passengers. The Inland Waterways Authority of India (IWA) is responsible for regulating and developing these waterways, ensuring navigability for vessels and improving transportation efficiency. Data-wise, around 90% of India's external trade by volume and 70% by value are handled by ports. Inland water transport (IWT) is an economical mode for bulk cargo but currently represents only 2% of India's modal mix. The government aims to increase its share to 5% by 2030 through the Maritime India Vision (MIV-2030). The target for cargo movement on national waterways by 2030 is 200 MMT as per the Maritime India Vision (MIV-2030). India boasts an extensive network of inland waterways that spans over 20,000 kilometers, encompassing rivers, canals, and backwaters. With 111 inland waterways declared as national waterways via National Waterways Act, 2016. Benefits of waterways transport: cost-effective. The cost of IWD is nearly 0.25 rs/km, of rail is 1.5 rs/km, while that of road transport is 2.5 rs/km. Fuel efficient. Inland transport consumes less fuel as compared to rail or roadways. According to the World Bank, 1 liter of fuel moves 105 ton-km by inland waterways, but only 85 ton-km by rail and 24 ton-km by road. Fewer emissions. CO2 emissions from container vessels range much lesser than road transport vehicles. Decongestion. It will decongest our choked highways and overburdened railways. There will be fewer accidents also. Navigable. In India, around 14,500 kilometers of river channels are navigable, but only 2,000 kilometers is used. Accessibility. Waterways provide access to remote areas and connect inland regions to coastal ports. Bulk cargo transportation. Water transport efficiently moves large quantities of bulk commodities. Tourism and recreation. Waterways offer opportunities for tourism, boosting local economies. Growth. It will promote export and import as it reduces the logistics cost of moving cargo between ports in the hinterland. Challenges. Intermodal connectivity. Effective intermodal connectivity between waterways, road, and rail networks is crucial for seamless transportation. Transshipment port. Due to the absence of a transshipment port in India, a large share of containers in India are currently transshipped through other ports like Colombo and Singapore. Competitiveness. Waterways transport faces competition from other modes of transport, such as road and rail, which may offer greater flexibility and faster delivery. Lack of standardized regulations. Harmonization of regulations across different states and regions can be challenging, leading to inconsistencies and complexities in operations. Limited coverage. Waterways may not be available in all regions, limiting their accessibility and applicability. Maintenance and dredging. Regular maintenance and dredging of waterways are necessary to ensure. National waterways. Arabian Sea, 1.620 kilometers. NW-2. Brahmaputra Debri Tosadia 891 kin. Toth length 4.503 kilometers. T0T 1 stage 15. Mandovi. Zuri River and Cumber, IM Canal. NW 3. West Coast Canal Column TOK on APURAM 205 kilometers SDTSHVD, Kerala. NWL. Ganga Halima Toalathabat. Navigability, but these activities require continuous investment and can be affected by environmental concerns. Limited market integration. Integrating waterways transport into existing supply chains and logistics networks can be complex, requiring coordination among various stakeholders and systems. Advantages of waterways to environment and society. Environmental benefits. Reduced carbon emissions. Waterway transport is generally more energy efficient and produces fewer carbon emissions compared to other modes of transportation, such as road or air transport. Congestion and road traffic reduction. Waterways transport helps alleviate road congestion by providing an alternative means of transporting goods. Less wildlife and habitat disruption. Construction of canals or the deepening of river channels can reduce disruption natural habitats and impact wildlife. Socioeconomic benefits. Economic growth. Waterways play a vital role in facilitating trade and commerce. It provides a cost-effective means of transporting goods, particularly bulk or heavy cargo. Employment opportunities. Waterways transport creates job opportunities in various sectors. It involves shipbuilding, port operations, logistics, and maintenance, providing employment for a diverse range of skilled and unskilled workers. Regional development. Waterways transport can stimulate regional development by connecting inland areas to coastal regions and international markets. Transportation efficiency. Waterways transport offers an efficient mode of transportation, particularly for large quantities of cargo. Accessibility and connectivity. It provides a reliable transportation option for remote communities, facilitating access to goods, services, and healthcare. Efforts taken by the government. The Inland Waterways Authority of India Act, 1985. The Act provides for the establishment of an authority for the regulation and development of inland waterways for shipping and navigation and matters related to it. Accordingly, the Inland Waterways Authority of India, IWAI, was formed in 1986. National Waterways Act 2016. The Act declared 111 rivers or river stretches, creeks, estuaries as national, inland, waterways. It allows the central government to regulate these waterways for development with respect to shipping, navigation, and transport by means of mechanically propelled vessels. Jalmard Vikas Project, JMP 2015. It seeks to improve the navigational capacity of National Waterway 1 and W1. The project is being implemented by the Government of India with technical assistance and investment assistance of the World Bank. Sagarmala Project 2015. The Sagarmala program focuses on modernizing and developing ports, improving port connectivity, promoting port-led industrialization, and supporting coastal communities. It aims to reduce logistics costs for domestic and international trade and increase the share of water transportation in the overall modal mix. It seeks to minimize the logistics costs by increasing the share of domestic waterways in the modal mix from the current 6%. Central Road and Infrastructure Fund, CRF. The fund was amended in 2019 to include inland waterways as one of the infrastructure subsectors eligible for funding. This allows the utilization of the fund for the development and maintenance of inland waterway infrastructure. Maritime India Vision, MIV, 2030, Maritime India Vision 2030, MIV 2030, is a blueprint formulated by the Ministry of Ports, Shipping, and Waterways to propel India to the forefront of the global maritime sector. It aims to ensure coordinated and accelerated growth of India's maritime sector in the next decade. MIV 2030 has been developed through consultations with over 350 public and private sector stakeholders, including ports, shipyards, inland waterways, trade bodies, and industry experts. Indian maritime sector highlights. India has 12 major ports and over 200 non-major ports along its 7,500 kilometers coastline, playing a crucial role in trade and growth. 95% of the country's trade volume and 65% of the trade value are undertaken through maritime transport. Inland water transport has witnessed significant growth, with a modal share of cargo increasing from 0.5% to 2% in the last 5 years. India ranks 3rd globally in ship recycling and 21st in shipbuilding. The country is among the top 5 countries supplying trained manpower for the maritime industry. Way forward, infrastructure development. Invest in the development of ports, inland waterways, and related infrastructure to improve connectivity and accessibility. This includes modernizing existing ports, constructing new ports, and expanding the network of inland waterways. Public-private partnerships. Foster collaborations between the government and private sector to leverage expertise, resources, and investments. Promote awareness and demand. Create awareness among businesses and consumers about the benefits of water transportation, such as cost-effectiveness, reduced congestion, and environmental advantages. Integration with multimodal transport. Enhance coordination and integration between different modes of transport, such as road, rail, and air, to facilitate seamless movement of goods and passengers. Maritime India Vision 2030 150+ initiatives identified across ports, shipping, and waterways. Ports. World-class port infrastructure. Atmanirbhar in shipbuilding, repair and recycling. Smart ports * to improve EODB. Reducing logistics cost and enabling multimodal shift. Institutional, regulatory, and legislative reforms. Safe, sustainable, and green maritime sector. One waterways. Reforming shipping policy and institutional framework. Enhancing India's global stature. Ocean, coastal, and island cruise hub. World-class maritime research, education, and training. Promoting cargo movement. Regional connectivity. Multimodality. Coastal integration. River cruise tourism. Urban water transport, environmental sustainability. Encourage the use of cleaner fuels, implement waste management systems, and adopt eco-friendly technologies to ensure sustainable operations. Monitoring and evaluation. Establish a robust monitoring and evaluation framework to track the progress and impact of initiatives undertaken in the water transportation sector. Interlinking of rivers. The National River Linking Project, NRLP. The National River Linking Project, NRLP, is an ambitious project aimed at addressing water scarcity and flooding issues in India by interlinking 37 rivers through a network of approximately 3,000 storage dams. This interlinking would create a vast South Asian water grid. National Water Development Agency, NWDA, is the nodal agency of the project. The linking of Godavari and Krishna was completed in 2015. The next project being taken up is the Kin-Betwa link. The project consists of 12 main components: the Himalayan component and the peninsular component. The Himalayan component. The Himalayan component focuses on the rivers originating from the Himalayas and includes 14 proposed projects. It involves the construction of storage dams on the Ganga and Brahmaputra rivers, along with their tributaries. The peninsular component. The peninsular component of NRLP focuses on interlinking the rivers in southern India. It involves transferring surplus water from the Mahanadi and Godavari rivers to the Krishna, Kaveri, Pinnar, and Vaigai rivers. This component encompasses 4 subcomponent linkages, connecting the Mahanadi and Godavari river basins to the Kaveri, Krishna, and Vaigai river systems. Linking the Kin and Betwa rivers, as well as the Parbati and Kalasand rivers to the Chambal River. Connecting west-flowing rivers south of Tapi to those north of Bombay. The NRLP aims to address the challenges of water scarcity and flooding through the transfer of water from water-abundant basins to water-deficient basins, promoting better water resource management and meeting the increasing water demands of various regions in India. Benefits: equitable water distribution. Interlinking rivers ensure fair sharing of water resources between regions, addressing water scarcity and promoting sustainable water use. Drought mitigation. By transferring water from water-abundant areas, interlinking rivers help combat droughts, supporting agriculture and livelihoods in water-deficient regions. Flood control. Interlinking rivers regulates water flow, reducing the risk of floods and minimizing damage to lives, property, and infrastructure. Irrigation and agriculture. River interlinking enhances irrigation capabilities, expanding cultivable areas and boosting agricultural productivity. Hydropower generation. Interconnected rivers provide opportunities for clean energy production through hydropower, contributing to the country's energy needs. Logistics cost. This project would enhance the infrastructure for logistics and movement of freight and decrease logistics costs. Clean transport mode. The development of a cleaner, low-carbon mode of transport would help in decreasing carbon footprints and would facilitate cheaper modes of transportation. Development of pipeline transport. Pipelines are the most convenient, efficient, and economical mode of transporting petroleum, petroleum products, natural gas, water, milk, etc. Solids can also be transported through pipelines after converting them into a slurry. Pipelines have relieved increasing pressure on the existing surface transport system. Advantages. Suitable mode. They are the most convenient mode of transporting liquids and gases. Transit losses are minimal through pipelines. Easy to lay. Pipelines are easy to place in difficult terrains and even underwater. Even they are not affected by seasonal variations like floods, snowfall, cyclones, etc. Low maintenance. Pipelines require very low energy and little maintenance. Environment friendly. Pipelines are safe, accident-free, and environment-friendly. Cheap transport. Transportation cost is very low compared to other modes of transportation. Industrial development. It brings industries in nearby regions, e.g. establishment of fertilizer industries near gas pipelines, Jagdishpur, Sawai Madhopur. Disadvantages. Lack of flexibility. Pipelines can't be laid everywhere. They can be utilized for a few destinations. Capacity. Its capacity is fixed and cannot be increased. Initial cost. Initial cost is very high and hence requires high capital investment. Security. They are vulnerable to attacks from non-state actors, e.g. destruction of the international Tapi pipeline by terrorist groups. Repair. Underground pipelines are difficult to repair and leakage detection is very difficult. Keywords. Dedicated freight corridors, rolling stock, train collision avoidance system, open sky agreements, maritime India vision. Previous your question underscore 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 underscore. How is efficient and affordable urban mass transport key to the rapid economic development of India? The interlinking of rivers can provide viable solutions to the multidimensional interrelated problems of droughts, floods, and interrupting navigation. Critically examine. 2020-2020. Wallah. Mains Wallah PYQs. PNLVIAJ. MISMI OHPYQS. Are offline centers. Carol Bagh Mukherjee Nagar. 992-061-3613 Puanlias. Com. General Studies 212 Geographical Perspective TO Disasters in India. According to the Disaster Management Act of 2005, a disaster is defined as a catastrophic event or severe occurrence in any area, caused by natural or man-made factors, accidents, or negligence. Such events result in substantial loss of life, human suffering, property damage, or environmental degradation and are of a magnitude that exceeds the affected community's ability to cope. According to the National Disaster Management Authority, due to its vulnerability to different kinds of disasters, it is said that India is a disaster-prone country. The reasons are: -85% of land vulnerable to single or multiple disasters. -59% of the land area is vulnerable to earthquakes. -12% is flood-prone. -8% is vulnerable to cyclones, and -70% of the land under cultivation is drought-prone. 57% of the area lies in high seismic zones. Fact-wise. According to a report produced by Delhi-based nonprofit Center for Science and Environment, CSE, India saw harsh weather conditions on 241 of the 273 days between January 1st and September 30th, 2022. Heat waves, cold waves, cyclones, lightning, torrential rain, floods, and landslides are a few of them. Hazard vis-a-vis disaster. Hazard disaster. A hazard is a dangerous physical condition or event that occurs in proximity. Small number of people are affected. It may cause injury, loss of life, or damage to property. Classification. Natural hazard. Earthquakes, cyclones, floods, and drought. Man-made hazard. Explosions. Release of hazardous waste. Dam failures. Air, water, and land pollution. Terrorism, civil unrest, and war. According to the United Nations, a disaster is the occurrence of a sudden or large calamity that affects the essential makeup and regular operations of a society or community. Classification. Tectonic occurrence, earthquakes, volcanoes, meteorological, hurricanes, cyclones, tornadoes, floods, droughts. Topographical occurrence, landslides, avalanches, O infestic, locust invasion of crops, epidemics, and O human, industrial accidents, nuclear bombs. Classification of disaster. Earthquake. Atmospheric, blizzards, thunderstorms, lightning, tornadoes, tropical cyclone, drought, hailstorm, frost, heat wave or Lu, cold waves, etc. Terrestrial, earthquakes, volcanic eruptions, landslides, avalanches, subsidence, soil erosion. Hydrological, floods, tidal waves, ocean currents, storm surge, tsunami, biological, plants and animals as colonizers, locusts, etc. Insect infestation, fungal, bacterial and viral. Diseases such as bird flu, dengue, etc. According to NDMA, an earthquake is a phenomenon that occurs without warning and involves violent shaking of the ground and everything over it. It results from the release of accumulated stress of the moving lithospheric or crustal plates. In the Indian context, the movement of the Indian plate is being constantly obstructed by the Eurasian plate, resulting in excessive accumulation of energy that ultimately leads to the sudden release of energy, causing earthquakes along the Himalayan arch. Fact-wise, Indian sharing globe. According to the seismic data, there were almost 1,300 earthquakes with a magnitude of 5 in the past year, with 40 of them occurring in India alone. Between September 2017 to August 2020, a total of 745 earthquakes have been recorded by the National Seismological Network. Indian case, about 60% of India's landmass, including all of its states, is vulnerable to earthquakes of various shaking intensities. According to government statistics, up to 59% of India's land area is vulnerable to earthquakes of various intensities. Nearly 11% of the nation is in Zone V, followed by 18% in Zone 4, 30% in Zone 3, and the remainder in Zone 2. India and earthquake. Recent earthquakes. Over the past 15 years, India has experienced 10 major earthquakes resulting in over 20,000 deaths. Himalayan vulnerability. The entire Himalayan belt is highly susceptible to major earthquakes with magnitudes exceeding 8.0. This is primarily due to the Indian plate moving towards the Eurasian plate at approximately 50 millimeters per year. Other prone regions. In addition to the Himalayan region and the Indo-Gangetic Plains, peninsular India is also prone to significant earthquakes, as evidenced by the Koina, 1967, Latur, 1993, and Jabalpur, 1997, earthquakes. Koina earthquake. The Koina earthquake was human-induced, triggered by the large Koina Dam completed in 1962. Such earthquakes can occur through a process known as reservoir-induced seismicity, RIS. Earthquake-prone areas. The Bureau of Indian Standards has classified regions in India into 4 seismic zones on the basis of historical seismic activity. These are Zones 2, 3, 4, and V. Among these, Zone V is the most seismically active region and Zone 2 is the least active. Reason for earthquake proneness of India, plate movement. The Indian plate is pushing into the Eurasian plate at a rate of about 47 mph, which is the primary cause of the high frequency and intensity of earthquakes in the region. Himalayan belt. The collision of the Java-Sumatra plate with the Indo-Australian plate, the Eurasian plate, and the Burmese plate strains the underlying rocks, releasing energy as earthquakes. Deccan Plateau. Some geologists propose that a fault line and energy buildup along the Bhima-Krishna. Seismic zone map of India, -2002. About 59% OT the land area of India is liable to seismic hazard damage. Zone intensity. Zone 4. Zone 3. Zone 2. Very high-risk zone AA lobby IO snaking and TERS LY9, ARD above. High-risk zone intensity 6. Moderate risk zone intensity 7. Low RTSK zone 6 and lower. Fault line near Latur and Usmanabad, Maharashtra, contribute to earthquakes in the region. Impact of earthquake, landslides. Earthquakes can trigger landslides and mudslides, especially in areas with water-soaked soils. E.g. Malin landslide, Maharashtra, Kedarnath landslide, Uttarakhand. Liquefaction. The shaking from an earthquake can turn loose soil into a liquid during an earthquake. Tsunamis. Large tsunamis which travel from the ocean floor to the surface are dangerous to human health, property, and infrastructure, e.g. 2004 Indian Ocean earthquake and tsunami. Fires. Earthquake fires start when electrical and gas lines are dislodged due to the earth shaking. Human loss. About 563 earthquakes, including related tsunamis, accounted for 56% of the total deaths or 747,234 lives lost between 1998 to 2017. Structural damage. According to the World Bank, 10% of damage occurs to infrastructure due to earthquakes. Economic impact. The total loss of public and private property was estimated at $4.97 billion according to the World Bank, and the percentage loss in terms of GDP was 1% of India's GDP of India. Earthquake swarm. Definition. An earthquake swarm is a series of small earthquakes occurring in a localized region over a period, with no identifiable main shock. Duration and frequency. Swarms can last for weeks and produce thousands of low-magnitude earthquakes within a relatively small area. Delhi, NCR 2021. In 2021, the Delhi NCR region experienced tremors on at least 5 occasions due to low-intensity quakes or aftershocks. Foreshocks. Swarms can act as foreshocks to a much larger main earthquake. Comparison with aftershocks. While swarms are often linked to geothermal activity, aftershocks result from the fault's readjustment process following a major slip, as noted by the USGS. Foreshocks. Aftershocks. Foreshocks are earthquakes that precede larger earthquakes in the same location. An earthquake cannot be identified as a foreshock until after a larger earthquake in the same area occurs. When an earthquake occurs, the state of stress around the earthquake dramatically changes. The Earth wants to get back to some type of equilibrium. Aftershocks become less frequent with time, although they can continue for days, weeks, months, or even years for a very large main shock. Way forward. Building codes. Reframing buildings codes, guidelines, manuals, and bylaws, and their strict implementation. Example: National Building Code of 2005. Community participation. Getting communities involved in the process of disaster mitigation through education and awareness. Networking of local NGOs working in the area of disaster management. Holistic approach. The Sendai framework for disaster risk reduction is a fairly all-encompassing approach to catastrophe management. Proper preparedness. In seismic zones with a very high risk of earthquakes, a specific department for earthquake management must be established. Research and development. Supporting R&D in various aspects of disaster mitigation, preparedness and prevention, and post-disaster management. Retrofitting. The NDMA released guidelines on seismic retrofitting along with specialists from several IITs and the necessary ministries. Example: under the Home Ministry, the National Retrofitting Program was introduced in 2014. Education. Evolving educational curriculum in architecture and engineering institutions and technical training in polytechnics and schools to include disaster-related topics. Mobile apps under National Retrofitting Program. India Quake, the mobile app, which was created by the National Center for Seismology, disseminates information about earthquakes in real time. Sagarvani, a smartphone app that distributes ocean-related information and alerts to the user community with the intention of serving coastal areas. Conclusion: it is not the disaster, but the lack of preparedness for the disaster that kills. The solution to minimizing the loss of lives and properties is the effective preparedness against the earthquake. Cyclones. According to a study published in the journal Nature Communications, a combination of global warming and a cyclical event called the Pacific Decadal Oscillation (PDO) could make tropical cyclones more frequent in the coming years. Fact-wise, the Indian subcontinent, which has an 8,041-kilometer-long coastline, is subject to around 10% of the tropical cyclones that occur worldwide. There are around 4 times as many cyclones in the Bay of Bengal as in the Arabian Sea. Occurrence of cyclones in India. Most of the cyclones occur in the post-monsoon season, i.e. from October to December, or in the pre-monsoon season from April to May. The lifespan of a cyclone is generally from 7 to 14 days. Initial conditions for the emergence of a tropical cyclone. Large sea surface with a temperature higher than 27 degrees Celsius. A pre-existing weak low-pressure area or low-level cyclonic circulation. Presence of the Coriolis force enough to create a cyclonic vortex. Small variations in the vertical wind speed. Upper divergence above the sea level system. Location: about 71% of this area is in 10 states: Gujarat, Maharashtra, Goa, Karnataka, Kerala, Tamil Nadu, Puducherry, Andhra Pradesh, Orissa, and West Bengal. Tropical cyclones are intense low-pressure areas confined to the area lying between 30 degrees north and 30 degrees south latitudes, in the atmosphere around which high-velocity winds blow. Reasons for increasing the frequency and intensity of tropical cyclone: climate change. Rising sea surface temperatures provide more energy to fuel cyclones, allowing them to intensify more quickly and become more powerful. For instance, there has been a 52% increase in the frequency of cyclonic storms during 2001 to 2019 in the Arabian Sea. Warmer ocean waters. As global temperatures rise, the Indian Ocean is warming, providing more heat and moisture to fuel cyclone development and intensification. For example, increasing sea surface temperature over Arabian Sea is providing ample supply of energy to intensify cyclones. For example, Cyclone Taukti. Sea level rise. Higher sea levels mean that storm surges can penetrate farther inland, causing more extensive coastal flooding and damage. For instance, Cyclone Nisarg originated in the Arabian Sea, caused severe damage, such as coastal inundation, erosion, and destruction of the vegetation on the western coast. Changing wind patterns. Changes in atmospheric circulation patterns can steer cyclones towards more vulnerable areas and also contribute to their intensification. Ocean heat content. Increased heat content can result in stronger cyclones. For example, ocean heat content anomaly has led to an intensification of the Kyar cyclone and Aki cyclone. Monsoon variability. The Indian Ocean Dipole and El Niño Southern Oscillation (ENSO) can affect monsoon patterns, which in turn can influence cyclone development. Impact of cyclones. Human loss. Cyclones, which are responsible for much loss of life, damage to property, and deterioration of day-to-day life. Economic impact. Impacts of cyclones cause direct economic losses such as loss in asset value and reduction in investments, which is a socio-economic impact of a disaster. Livelihood. Cyclones mostly affect coastal districts. Several people in coastal villages who depended only on fishing had lost access to food and clean drinking water as fishing was prohibited. Structural damage. Damage to infrastructures such as roads, bridges, and revetment results in loss to both the public and the government. Floods. Cyclones may result in heavy rainfall and floods, which is the next devastation to the environment. Agricultural damage. Devastation of crops may result in reduced income for farmers, increased prices for food. Sea level. Abnormal rise in sea level caused by cyclones is known as storm surge. Way forward. Capacity building. While the hazards due to tropical cyclones cannot be reduced, mitigation strategies to reduce their impacts can be devised. Improvement of onshore warning system. Early reliable warning is one of the important short-term mitigation measures that can reduce the severity of the cyclone-related disasters if acted upon timely. Construction of cyclone shelter. For multi-purpose use such as school buildings, community centers, or any other public utility buildings. Construction of canals and embankments for improved drainage. Besides improvement to minor drains in the coastal areas, a canal network in the coast is an effective tool of water management. Shelter belt plantation. Shelter belts are barriers of trees that are planted to reduce wind velocities and prevent wind erosion to protect human habitations and agricultural crops. Retrofitting of vital installations. Roads, culverts, bridges in the cyclone-prone areas need to be maintained well. Awareness generation for cyclone risk mitigation. The public awareness program with community involvement is an important component of disaster risk management. Conclusion. Cyclones description by Parjoy. Time: June 2023. Origin: Arabian Sea. Landfall: Gujarat. Mandis. Time: December 2022. Landfall: Andaman and Nicobar Island in Tamil Nadu. Sitrang. Time: October 2022. Origin: Bay of Bengal. Landfall: Odisha, West Bengal, Assam and ANN Islands. Asani. Time: May 2022. Origin: Bay of Bengal. Landfall: Andhra Pradesh, Tamil Nadu, Karnataka and Odisha. Takti. Time: May 2021. Origin: Arabian Sea. Landfall: Gujarat, Maharashtra and Karnataka. Yas. Time: May 2021. Origin: Bay of Bengal. Landfall: Odisha, Jharkhand and Bihar. Nisarg. Origin: Arabian Sea. In 2020. Landfall: Maharashtra. Tropical cyclones are natural phenomena which India faces frequently. Regardless of state support and administrative help, people themselves have to step up to create local solutions using their own practices. People's participation, cooperation, and awareness among all stakeholders will help to reduce the disaster. Drought. The India Meteorological Department, IMD, defines drought in any area when the rainfall deficiency in that area is greater than 26% of its long-term normal. According to the Union Agriculture and Cooperation Ministry's Drought Crisis Management Plan document, 68% of the country is prone to drought, with nearly 33% area having a chronic drought problem, while another 35% is drought-prone. Fact-wise, according to the Drought in Numbers Report, 2022, India is one of the nations that has been most severely hit by the drought. Between 2020 and 2022, approximately two-thirds of the nation experienced drought. Well, the report also noted that between 1998 and 2017, severe droughts in India caused a 2 to 5% decline in the gross domestic product, GDP. The Global Drought Vulnerability Index includes India. India is just as vulnerable to drought as sub-Saharan Africa. According to statistics, India's territory susceptible to drought has grown by 57% since 1997. Types of droughts. Meteorological drought. It is a situation when there is a prolonged period of inadequate rainfall marked with maldistribution of the same over time and space. Agricultural drought. It is also known as soil moisture drought, characterized by low soil moisture that is necessary to support the crops, thereby resulting in crop failures. Hydrological drought. It results when the availability of water in different storages and reservoirs like aquifers, lakes, reservoirs, etc., falls below what the precipitation can replenish. Ecological drought. When the productivity of a natural ecosystem fails due to shortage of water and as a consequence of ecological distress, damages are induced in the ecosystem. Causes of drought. Uneven distribution of rainfall over different parts of the country. Low average annual rainfall of 750 millimeters over 33% of cropped area heightens susceptibility to drought. Overexploitation of groundwater and suboptimum conservation of surface water, leading to inadequate water availability for irrigation. Limited irrigation coverage and poor irrigation techniques. Net irrigated area in the country is less than 50%. The impact of drought on account of complete dependence of agriculture in such areas on rainfall. Impact of drought. Hunger. Droughts cause scarcity of food and water. People die of hunger, malnutrition, and epidemics and impact the health of people. Economic. Agricultural contributions to the gross domestic product, GDP, dipped by 3.1% and agricultural income losses were estimated at 39,000 rupees crore. Agricultural. Crops fail due to scarcity of water. Severe droughts in rain-fed areas have reduced agricultural production by 20 to 40%. Environmental, lowers surface water levels, increased pollution of surface water, the drying out of wetlands and loss of biodiversity. Employment, farmers are deprived of their employment. Nearly 50% of the rural workforce is concentrated in drought-prone districts. Poverty, drought and poverty are interconnected with millions of very poor people living in drought-prone areas. Migration, people are forced to migrate from their area of residence in the pursuit of food, water, green fodder, and employment. Way forward, suitable farming methods for arid areas, like production of coarse and hardy cereals. Conservation of soil moisture by deep plowing, storing water behind small dams, collecting water in ponds and tanks, and use of sprinklers for irrigation. Sowing drought-resistant crops. By sowing drought-resistant crops of cotton, mung, pearl millet, wheat, etc., the impact of the drought could be mitigated to a certain extent. Rainwater harvesting. By making high bunds around the fields, adopting off-terrace cultivation, and planting trees on the bunds of fields, the use of rainwater can be maximized. Stricter government policies. They include raising taxes for non-compliance and regulating the amount of greenhouse gases that are released into the environment. Being environmentally conscious. It entails teaching the next generation about the need of preserving, improving, and protecting the environment, as well as recycling, reusing, and planting more trees. Conclusion. Government needs to invest in research and development projects to invent new techniques for effective water management in our country. Climate change will potentially be increasing the frequency of events like droughts. Effective implementation of medium and long-term solutions will help mitigate the impact of droughts. Landslides. Indian Institute of Technology, Delhi, has made the first high-resolution landslide susceptibility map for India, and the map data is available for free. About landslide susceptibility map. The team from IIT Delhi built a national landslide susceptibility map that uses the latest data in data collection and mapping techniques. High resolution. The map could plot the susceptibility at a resolution of 100 m. Identified region. The map acknowledged some high landslide susceptibility, like parts of the foothills of the Himalayas, the Assam-Meghalaya region, and the Western Ghats. New insight. It also revealed some previously unknown places with high risk, such as some areas of the Eastern Ghats, north of Andhra Pradesh. Leveraging ensemble machine learning technology. Ensemble machine learning is when multiple machine learning models are used together to average out an oversized impact from any one model. Factors used. They collected information on factors like soil cover, number of trees covering the area, distance from roads or mountains, etc. They used GeoSuduk, an online system with data on the national road network in India, displaying data on roads located outside cities. About landslides. Definition. It is a movement of a mass of rock, earth, or debris down a slope. Landslide-prone regions. The regions with fewer trees, closer to road building activity, and steeper local slopes are more unstable and prone to landslides. Overview of landslides in India. Increasing landslides in India. Over the past 50 years, the landslides seem to have increased in magnitude and frequency due to human activities. For instance, India has improved and expanded its road network in mountainous states under the National Bharatmala Pariyojana, Road to Prosperity Initiative. However, the Copernicus organization recorded more than one landslide per road kilometer along the NH7 between Rishikesh and Joshimath. ISRO's Landslide Atlas of India findings. Global standing in landslide risk. India is among the top 5 landslide-prone countries globally, where at least one death per 100 square kilometers is reported in a year. Rainfall variability pattern. Primary cause of landslides with the Himalayas and the Western Ghats remaining highly vulnerable. Land area prone to landslide. Excluding snow-covered areas, approximately 12.6% of the country's geographical land area. Regional variability. 66.5% of the landslides are reported from the J. 1. MAJORCAUSESOFLANDSLIDES. EXTERNALCAUSES and TERNALCAUSES. UNDERCUTINGOFTHEFOOTOFTH hill slope due to river erosion, quarrying, excavation, etc. Increase in EXTERNAL loads such as buildings, reservoirs, highway traffic, etc. Increase in unit WEIGHTOF slope immaterial due to increased WETER content. VIBRATONS due to earthquakes, blasting, traffic, etc. Anthropic changes caused by deforestation. UND and ENO caused BV2 in Annalena. Increase in PERI or pressure. Reduction in cohesive strength caused by progressive law TERA lysotion. CRAX2E to alternate swelling and shrinkage from tension. Presence OFFAULTS, JO and TS, bedding planes, cleavage, etc. THEIR orientation. Freezing and THAW in GOF rocks and soils. MATE RIA LP ROPE RTIS such as compressive strength, shearing strength, etc. OF earth material. collapse of underground caverns, seepage erosion, etc. Northwestern Himalayas, about 18.8% from the northeastern Himalayas, and about 14.7% from the western Ghats. Joshimath land subsidence reason, fragile ecology. Ecology is incredibly fragile since Joshimath city was constructed on an old landslip deposit, which is made up of sand and stone rather than rock and has a low load-bearing capability. Disregarded the 1976 Mishra Committee report's recommendations, the committee had come to the conclusion in its report that the area on which the town is built is actually a sand and stone deposit, the remains of a long-ago landslip. Tidal projects. Joshimath's foundation may have suffered more harm than any other factor from the construction of the 520 megawatts NTPC Tapovan Vishnugad hydropower plant, Dali Ganga River. Land erosion. Other factors contributing to the fate of the city include sliding along natural streams and rushing streams from Vishnuprayak. Geographic fault. Where the Indian plate is pushed under, there may have been a reactivation of a geographic fault, which is described as a fracture or zone of fractures between two blocks of rock. Way forward. Landslide monitoring involves the deployment of sensors, satellite imagery, and ground-based instruments to detect ground movement and potential landslide precursors. INCHAI Initiative. The National Highways Authority of India, INCHAI, plans to install a landslip detection system on the Gap Road stretch of the Kochi-Danish-Koti National Highway in Munnar to provide early warnings of landslips. Landslip detection system. Developed by IIT Mandi, the Indian Army, and DRDO, this system enhances monitoring capabilities. Landslide hazard maps. These maps, generated using UVs, terrestrial laser scanners, and high-resolution Earth observation (EO) data, ensure reliable and validated landslide zoning. International practices. Brazil's SNAKE system exemplifies advancements in digital monitoring and alert mechanisms for landslide early warning. Awareness programs. Aimed at fostering a culture of awareness and preparedness, these programs help communities stay alert and take preventive measures against potential disasters. Heatwave. The Indian Meteorological Department, IMD, has issued alerts regarding heat waves for various parts of India. About heat waves. Heat waves are extended periods of excessively high temperatures that can have severe implications on human health, environment, and the economy. India, being a tropical country, is particularly vulnerable to heatwave conditions. Declaration of heat waves. According to IMD, the definition of a heat wave depends on the physiography of regions. Following criteria for heat wave declarations have been provided. A heat wave declaration is considered if the maximum temperature of a station reaches at least 40 degrees Celsius or more for plains, 37 degrees Celsius or more for coastal stations, and at least 30 degrees Celsius or more for hilly regions. A heatwave severity is determined by its departure from normal temperature. Normal heatwave, when the departure from normal is by 4.5 to 6.4 degrees Celsius, and severe heatwave, when the departure from normal is greater than 6.4 degrees Celsius. Based on actual maximum temperature, for plains only heatwave, when actual maximum temperature 45 degrees Celsius. Severe heatwave, when actual maximum temperature 47 degrees Celsius. The IMD considers the criteria of departure from normal temperature and actual maximum temperature only when at least two stations in a meteorological subdivision report such a high maximum, or when at least one station has recorded a corresponding departure from the normal for at least 2 consecutive days. Status of heatwave in India. World Bank report in November warned that by 2030, over 160 to 200 million people across India could be exposed to lethal heat waves annually. The IMD forecast for hot weather has said most of India, barring parts of the east and the northeast and some pockets in the northwest, will experience above normal maximum and minimum temperatures. Heat Action Plans, HAP, to tackle heat waves. About Heat Action Plans, HAPs, are India's primary policy response to economically damaging and life-threatening heat waves. Objective. It aims to decrease the impact of heat waves and prescribes a variety of preparatory activities, disaster responses, and post-heat wave response measures across state, district, and city government departments. Challenges of HAPs. Local context limitations. Current HAPs use national thresholds to define heat waves, which do not adequately reflect diverse climatic, geographic, and urban conditions across regions. For example, many cities experience extreme temperatures without a heatwave declaration. Siloed approach. HAPs often operate in isolation with limited financial support, reducing their effectiveness. Inadequate legal foundations. Most HAPs lack robust legal authority, undermining implementation and compliance. There is no consistent mechanism for updating HAPs based on new data or outcomes. Components of FAP's regional heat profile overview of past heat waves, summer temperatures, and land surface temperatures. Vulnerability assessment identifies high-risk areas and prioritizes interventions for vulnerable groups. Mitigation recommendations offers strategies like urban greening and infrastructure changes to reduce heat impacts. Response plan specifies actions before, during, and after heat waves, including cooling centers and hydration kits. Roles and responsibilities assigns tasks to governmental and non-governmental organizations for disaster care response. Lack of focused planning. While HAPs mention long-term measures, they often limit planning to infrastructure, especially cool roofs, with minimal attention to green and blue spaces. Resource allocation. The success of HAPs varies widely based on local government priorities and available resources. Dedicated funding and collaborative financial planning are crucial for comprehensive heat action. Way forward, comprehensive climate risk assessments. There is a need to develop a full-fledged climate risk assessment framework that can accurately identify areas at risk of heat waves and evaluate the exposure of people and assets. Development of modified heat index. There is a need to create a multidimensional heat index that takes into account factors beyond temperature, such as humidity and the urban heat island effect, integration with urban planning and resilience. Link HAPs with broader urban resilience and climate adaptation strategies to pool resources more effectively. Incorporation of nature-based solutions. There is a need to focus on integrating nature-based solutions, such as strategic placement of green spaces and the development of Government Initiative India's Cooling Action Plan provides a long-term vision to address the cooling requirement of various sectors. Regarding heat waves. Climate Hazards and Vulnerability Atlas of India. The atlas provides a range of vulnerability with risks ranging from nil, low, moderate, high and very high categories for every Indian district with regards to immature weather events. Why? Model Heat Action Plan. It has been released by the National Disaster Management Authority (NDMA) to provide hyperlocal warning systems, vulnerability mapping of cities, and Clim 8 resilient housing policies. Blue infrastructure into HAPs to mitigate the impacts of extreme heat. Fact-wise, Geological Survey of India. According to NCRB, there may have been 374 heat-related deaths in India in 2021, which is a decrease from the 530 cases reported in 2020. The NDMA estimates 17,767 deaths from heat waves between 2000 and 2020, State of India's Environment and Figures. 2022 claims the country saw 280 heatwave days from March 2021 to May 2022, the most in the previous 12 years. Reasons for recent heat waves experienced in India. Increase in concrete areas. Urban heat island effects can make ambient temperatures feel 3 to 4 degrees more than what they are. Absence or weaker western disturbances. The rain-bearing western disturbances or tropical storms which bring rain from the Mediterranean over North India in March-April have been absent. Dry and hot westerly winds. The continuous dry and hot westerly winds blowing from Baluchistan, central Pakistan, and the Thar Desert over northwest and central India have contributed to the rise in heat waves. Climate change. More heat waves were expected as global temperatures had risen by an average of 0.8 degrees in the past 100 years. Nighttime temperatures are rising too. Lack of rainfall. Usually, periods of high temperature are punctuated by periodic episodes of rain, but this was largely absent during March and April. Impact of heat waves. Risk of wildfires. The heat waves act as fuel to wildfires, which destroys a lot of land area every year. Prevents cloud formation. The condition also prevents clouds from forming, allowing for more radiation from the sun to hit the ground. Heat strokes and sudden fatalities. Very high temperatures or humid conditions pose an elevated risk of heat stroke or heat exhaustion. Health problems. Older people and people with chronic illnesses such as heart disease, respiratory disease, and diabetes are more susceptible to heat stroke, as the body's ability to regulate heat deteriorates with age. Effect on vegetation. The trapping of heat can also damage crops, dry out vegetation, and result in droughts. Increased energy demands. The sweltering heat wave also leads to a rise in energy demand, especially electricity, leading to pushing up rates. Conclusion. Human-induced climate change has contributed to changing patterns of extreme weather across the globe, from longer and hotter heat waves to heavier rains. The intensity and frequency of heat waves can be reduced by creating awareness among people and disaster preparedness measures to mitigate the impact of heat waves. Forest fire. Forest fire may be defined as an unclosed and freely spreading combustion that consumes the natural fuels. Combustion is another word for fire. When a fire burns out of control, it is known as wildfire. Causes of forest fire. Natural causes. Many forest fires start from natural causes such as lightning, which set trees on fire. However, rain extinguishes such fires without causing much damage. High atmospheric temperatures and dryness, low humidity, offer favorable circumstances for a fire to start. Man-made causes. Fire is caused when a source of fire like naked flame, cigarette or biddy, electric spark, or any source of ignition comes into contact with inflammable material. More than 95% of forest fires are anthropogenic. According to WWF International 2020 report, it is estimated that humans are responsible for 75% of wildfires worldwide. Forest fire vulnerability of India. Classification. Fire UIOMLYAS. Forest. Surface fire. From OS spread across THE forest floor through surface litter AND vegetation. UND UND fire. Low-intensity fires burning beneath the surface, often spreading entirely underground. CROWN fire. Trees AND shrubs crow NS bomb. OF10 sustained by a surface fire. O. In slopes, fires co-in spread rapidly uphill due to HEATED airflow, with less likelihood of spreading down H. GROUND fire, burn subsurface organ-IC fuels, including duff layers, tundra, or organ-IC soils of SWMPS. Destroys herbaceous growth AND organic matter. Potentially D of astid and G vegetation. Forest fire-prone area. According to the Biennial India State of Forest Report, ISFR 2019 published by the Forest Survey of India, FSI, more than 36% of India's forest cover was prone to frequent fires. About 4% of the forest cover was extremely prone to fire, and another 6% was very highly fire-prone. Vulnerable states. The 11 main states with frequent occurrence of forest fires in recent times are Andhra Pradesh, Assam, Chhattisgarh, Himachal Pradesh, Mizoram, Madhya Pradesh, Maharashtra, Odisha, Telangana, Uttar Pradesh, and Uttarakhand. Forest fire vulnerability across ecosystems. According to the FSI, severe fires break out in dry deciduous forests, while evergreen, semi-evergreen, and montane temperate forests are comparatively less prone to fires. Triggering factors. Human activities trigger 95% of forest fires in India, such as burning agricultural practices, deforestation, firewood burning, etc. Drought and higher temperatures further aggravate the risk of forest fire. Forest fire situation in 2024. During March 2024, the highest number of forest fires were reported from Mizoram, 3,738, Manipur, 1,702, Assam, 1,652, Meghalaya, 1,252, and Maharashtra, 1,215, as per FSI data. Initiatives taken to prevent forest fires in India. National Disaster Management Plan, NDMP 2019. Under the revised NDMP 2019, forest fire has been included and addressed as a hazard, with specific time-bound action plans and clear roles and responsibilities of central, state agencies, and key stakeholders. Forest Fire Alert System. Since 2004, the FSI developed the Forest Fire Alert System to monitor forest fires in real time. In its advanced version launched in January 2019, the system now uses satellite information gathered from NASA and ISARO. Fire Weather Index-based Forest Fire Danger Rating System. FFRS identifies vulnerable areas on the ground for risk reduction and mitigation, identification of highly fire-prone areas, resource allocation and mobilization, Van Agni Geoportal. It serves as a single-point source for the information related to forest fires in India. National Action Plan on Forest Fires. NAPFEF. It was launched in 2018 by MEF and CC to minimize forest fires by informing, enabling and empowering forest fringe communities and incentivizing them to work with the state forest departments. Impact of forest fires. Global warming. When vegetation is destroyed by fire, the amount of greenhouse gases in the atmosphere increases, causing climate change and global warming. Soil degradation. Forest fires destroy helpful soil microbes that break down the soil and encourage microbial activity in the soil, resulting in soil degradation. Livelihood. Loss of livelihood for tribal people and the rural poor, as approximately 300 million people are directly dependent upon collection of non-timber forest products from forest areas for their livelihood. Loss of ecosystems and biodiversity. Ecosystem and biodiversity loss is caused by forest fires destroying the habitats and complex interactions of a wide variety of flora and wildlife. Forest degradation. The quality of some forest elements, such as soil fertility, biodiversity, and ecosystems, is steadily declining as a result of the nearly annual occurrence of forest fires in various forest locations. Health issue. The respiratory and cardiovascular systems may be impacted by wildfire smoke, particularly if it has a high concentration of PM 2.5 particles smaller than 2.5 millimeters. Way forward. Firefighting reservoirs. Water is still the main way to extinguish forest fires. Therefore, in large, contiguous and endangered forested areas, it is necessary to have, or build and maintain, a firefighting water supply system within suitable watercourses or to create artificial reservoirs for water extraction. Aerial surveillance. Aerial surveillance flights are a possible means to detect forest fires at an early stage during times of high fire risk. Communication equipment. Forest fires can only be quickly and successfully fought with functioning communication between the fire service and forest authority operational teams. Cooperation and joint exercises. Collaboration between forest owners, the administration, and different branches of the fire and emergency services is of special importance when it comes to forest fires. Machinery and equipment. Maintaining appropriate firefighting tools and machinery is necessary to tackle forest fires. Forest fire monitoring. Using forest fire observation systems, the number of forest fires has not reduced, but their extent has reduced. Conclusion. Forest fires are usually seasonal. They usually start in the dry season and can be prevented by adequate precautions. The best way to control a forest fire is therefore to prevent it from spreading, which can be done by creating fire breaks in the shape of small clearings of ditches in the forest. Floods. India is highly vulnerable to floods. Out of the total geographical area of 329 million hectares, MHA, more than 40 ma is flood-prone. Floods are a recurrent phenomenon, which cause huge loss of lives and damage to livelihood systems, property, infrastructure, and public utilities. Flood distribution in India. Vulnerability is highlighted by the fact that 40 million hectares out of the geographical area of 3,290 lakh hectares are prone to floods, which is 12%. Statewide study shows that about 27% of the flood damage in the country is in Bihar, 33% in Uttar Pradesh and Uttarakhand, and 15% in Punjab and Haryana. The middle and lower courses of North Indian rivers such as Ganga, Brahmaputra, Kosi, Damodar, Mahanadi, etc. are prone to floods due to very low gradients. Peninsular rivers are mature and have hard rock beds, so they have shallow basins. This makes them prone to flooding. The causes of flood in India. Natural reasons. Heavy rainfall. Heavy rain in the catchment area of a river causes water to overflow its banks, which results in the flooding of nearby areas. Sediment deposition. Riverbeds become shallow due to sedimentation. The water-carrying capacity of such rivers is reduced. As a result, the heavy rainwater overflows the riverbanks. Cyclone. Cyclone-generated sea waves of abnormal height and spreads the water in the adjoining coastal areas. In October 1994, Orissa cyclone generated severe floods and caused unprecedented loss of life and property. Cloud bursts. They result in flash floods, as seen in the Uttarakhand floods in 2013, Kedarnath flash flood in 2021, Chamoli disaster. Change in the course of the river. Meanders and changes in the course of the river cause floods. Tsunami. Large coastal areas are flooded by rising seawater when a tsunami strikes the coast. Anthropogenic reasons. Interference in a drainage system. Drainage congestion caused by the badly planned construction of bridges, roads, railway tracks, canals, etc. hampers the flow of water, and the result is flooding. Deforestation. Vegetation hampers the flow of water and forces it to percolate in the ground. As a result of deforestation, the land becomes obstruction-free and water flows with greater speed into the rivers and causing floods. Floodplain encroachment. Population pressure resulting in encroachments into the floodplains over the years has aggravated the flood problem. Urban planning. Improper town planning and inadequate drainage arrangement lead to urban floods. External floods. Impact of floods. Casualties. Human and livestock death due to drowning, serious injuries and outbreaks of epidemics like diarrhea, cholera, jaundice or viral infections are common problems faced in flood-affected areas. Structural damage. During floods, mud huts and buildings built on weak foundations collapse, endangering human lives and property. Financial burden. Some losses and damages brought on by floods are covered by insurance, but not all of them. The government occasionally provides state-level assistance to those affected by floods. Emotional trauma. Flood victims frequently experience a wide range of feelings during and after the disaster, including worry, fear, sadness, loss, and frustration. E.g. of inhabitants of Magellan Island who face regular floods. Material loss. All materials mounted on the ground, e.g. foodstock, equipment, vehicles, livestock, machinery, salt pan, and fishing boats can be submerged and spoiled. Utility damage. Utilities such as water supply, sewerage, communication lines, power lines, transportation network, and railways are put at risk. Measures for flood management. Embankments. By building flood protection embankments, flood water can be controlled from overflowing the banks and spreading in nearby areas. The building of embankments on Yamuna, near Delhi, has been successful in controlling the flood. Afforestation. The fury of the flood could be minimized by planting trees in catchment areas of rivers. Restoration of original drainage system. The drainage system is generally choked by the construction of roads, canals, railway tracks, etc. Floods could be checked if the original form of drainage system is restored. Reservoirs. By constructing reservoirs in the course of rivers could store extra water at the time of the flood. Such measures adopted till now, however, have not been successful. Dams built to control floods in Damodar could not control the flood. Conclusion. India is vulnerable to annual flooding because of its geographical location, and it causes huge damage to life and property. A flood is a natural phenomenon. It cannot be fully controlled. However, the government can mitigate the risks posed by floods to a greater extent by taking appropriate steps. Urban flood. Cyclone Machang has caused extensive floods, causing severe damage to infrastructure and disruptions of livelihoods. What is urban flooding? Urban flooding can be defined as the submergence of usually dry areas by a large amount of water that comes from sudden excessive rainfall, an overflowing river or lake, melting snow, or an exceptionally high tide. As per the data from government, over 17,000 people died due to floods and heavy rains in India between 2012 and 2021. Reasons behind flood in Indian cities. Urban flooding. Climate change. Global climate change is resulting in changed weather patterns and increased intensity rainfall events occurring in shorter periods of time. For example, urbanization leads to developed catchments, which increases the flood peaks from 1.8 to 8 times and flood volumes by up to 6 times. Urban heat island effect. According to the NDMA, the urban heat island effect has resulted in an increase in rainfall over urban areas. The hot air pushes the clouds carrying rain higher as they cross the urban heat island. Urban flood causes. Direct factors, indirect factors. Global climate change. Urbanization. 1S change in a weather pattern J. Heavy RA and FALQ. Encroachment flood. Continue to higher density. Improper and inadequate drainage system J. On-road vehicle parking J. I equals development carotidity of people and city land uses. Increased impervious areas leading to more runoff. J. Improper or no waste J management. Heat islands are urbanized areas that experience higher temperatures than outlying areas. Encroachment in low-lying areas. The original built-up area of Indian cities has expanded and new developments are taking place in low-lying areas of Indian cities and towns due to rising land prices and less availability of land in the cities. Faulty drainage system. The urban areas lack adequate drainage infrastructure capable of handling heavy rainfall events. Poor planning and impermeable surfaces, such as buildings and highways, do not let water penetrate the ground and overburden the inadequate drainage systems. The issue is exacerbated by concretizing the drains and preventing the water from seeping to the ground. Urbanization. Rapid urbanization, both planned and unplanned, is responsible for flooding. Gray infrastructure, which includes the flyovers, widening of roads, urban settlements, contribute towards urban flooding in waterlogged areas. The recent floods in Gurugram and Bengaluru are examples of such planning failures. Improper waste disposal practices also contribute to flooding. Illegal development and encroachment on water bodies, urban green spaces, and small woods have been observed in many cities. Velachery Lake in Tamil Nadu has disappeared due to sewage discharge. Impact of urban flooding. Tangible losses, the losses that can be measured physically and can be assigned an economic value. These losses can be direct or indirect. Direct. Structural damage to buildings, property damage, damage to infrastructure. Indirect. Economic losses, traffic disruption, and emergency costs. Intangible losses. Intangible losses include loss of life, secondary health effects, and infections or damages to the environment which are difficult to assess in monetary terms since they are not traded. Direct. Casualties, health effects, ecological losses. Indi may GIDLINES pre-monsoon phase URBN fellow DNG. Preparedness. Focus on plans to respond to a threat or occurrence of urban flooding. National Hydrometeorological Network. National Meteorological Network. Local networks for real-time rainfall data, Doppler weather radars during monsoon phase. Early warning. Measures to provide timely, qualitative, and quantitative warnings based on the intensity of rainfall. Effective response and management. Focuses primarily on emergency relief measures. Post-monsoon phase. Restoration and rehabilitation. Necessary measures to stabilize the vulnerable situation and restore the utilities. Indirect. Post-flood recovery process. Mental damage to the people. Glacial lakes outburst floods. Nanda Devi Glacier incident. The recent breaking off of a portion of the Nanda Devi Glacier in Joshimath, Uttarakhand, resulted in significant flooding in parts of the state. Dammed glacial lakes. GLOFs occur when a substantial amount of water stored in a glacial lake is suddenly discharged. Serious concern in Himalayan states. Building moraine-dammed glacial lakes and the occurrence of GLOFs are significant concerns in India's Himalayan states. GLOF are triggered by a variety of factors: fast slope migration, rapid slope movement, slides, falls, avalanches. Into the lake leads to displacement waves, causing the dam to overtop or triggering an immediate dam breach. Long-term dam deterioration. Over time, the internal structure of the dam can deteriorate, leading to increased hydrostatic pressure caused by basal ice melting, ultimately resulting in dam failure. Black carbon. Increasing levels of black carbon, produced by incomplete combustion of fossil fuels, wood, and other fuels, contribute to a lower albedo, leading to accelerated glacier melting. Anthropogenic activities, mass tourism, development projects like road construction and hydropower projects, and certain agricultural practices such as slash-and-burn farming in specific areas of the Indian Himalayan region can contribute to the risk of GLOFs. Heavy rainfall, snowmelt, and cascading processes. Intense rainfall or rapid snowmelt, along with cascading processes, result in a significant increase in water intake into the lake, potentially leading to a flood from an upstream lake. Earthquake. Earthquakes can directly cause dam breaches and failures, resulting in a glacial lake outburst flood. Keywords: liquefaction, earthquake swarm, Sendai Framework for Disaster Risk Reduction, Pacific Decadal Oscillation, Heat Action Plans, Glacial Lakes Outburst Floods. Previous year questions. Dam failures are always catastrophic, especially on the downstream side, resulting in a colossal loss of life and property. Analyze the various causes of dam failures. Give 2 examples of large dam failures. 2023. 2023. Explain the mechanism and occurrence of cloudburst in the context of the Indian subcontinent. Discuss 2 recent examples. 2022. Explain the causes and effects of coastal erosion in India. What are the available coastal management techniques for combating the hazard? 2022. Discuss about the vulnerability of India to earthquake-related hazards. Give examples including the salient features of major disasters caused by earthquakes in different parts of India during the last 3 decades. 2021. Describe the various causes and effects of landslides. Mention the important components of the National Landslide Risk Management Strategy. 2021. Account for the huge flooding of million cities in India, including the smart ones like Hyderabad and Pune. Suggest lasting remedial measures. 2020. In what way can flood be converted into a sustainable source of irrigation and all-weather inland navigation in India? 2017. Major cities in India are becoming more vulnerable to flood conditions. Discuss. 2016 Mumbai, Delhi and Kolkata are the 3 megacities of the country, but the air pollution is a much more serious problem in Delhi as compared to the other 2. Why is this so? 2015. Bring out the causes for more frequent landslides in the Himalayas than in the Western Ghats. 2013 Our Content, 81 on. UPSC Books. IB9 Udn. Free material. QS to the power of LVIA asterisk 1 UDN caret 00 Jodo asterisk asterisk. TON. JMMMVI MMPM UMS 2024. Free material. Comprehensive coverage 11-year PYQ solution, Prelim S plus Mains. Udn, Prelims static revision. Udn plus 5.